that stage, thank you for consolidating. We do have a couple of seats. People will maybe be flowing in. There are people who couldn't make it here, but we do offer a live stream. So welcome to the folks watching on the live stream. You're very welcome. You won't be able to make use of the facilities that we've just been through. There was good stuff in that opening, right? The live streams just joined us. They didn't get any of that stuff. That's just for you. You feel special. But welcome to the people on the live stream. We'll be underway shortly. I would like as well to call out during the breaks. We've got the lovely people from Google. They have a performance help desk up at the top, just at the top of the stairs at the back. Again, apologies on the live stream. You can't make use of that, but the people in the room certainly can. So during the breaks, go and chat to them, talk about the performance on your site, get some tips and tricks from them. Okay, what else do we need to talk about? Oh, yes, the hashtag. Social media apparently still is going strong. So if you're on social media, this is the hashtag we're using to talk about the event. We love seeing photos and comments and feedback and little nuggets from the event. That's the hashtag to use when you're sharing things on Twitter or Mastodon or your social media of choice. I'm very curious to know where people on the live stream are joining from. So tell us and use that hashtag. Maybe even show us where you're enjoying the conference from. It's always fascinating to see that as well. I would remind people joining on the live stream, of course, we do have a code of conduct that we mentioned here in the room earlier on. You can find details of that on the website. Last couple of things before, God, it's a lot from me, isn't it? God, you're very patient, thank you. A couple of notes about Q&A. You are very welcome to submit questions. After each talk, we'll have a little chat over in the lounge over here. We'll have a little conversation, and I'll put questions to the speakers following their talk. So you can submit questions that I will be keeping an eye on. You can do that using the hashtag on Twitter or Mastodon, and indeed via the website there is a form there so you can submit questions with your name or anonymously if you'd prefer, and we'll try and get through as many of those as you can. Also, questions can come through the live chat in the live stream. And then the final note before, oh, Mark's been waiting so patiently. The final note before we get Mark to open the day is that in the breaks, after each session, the speakers from that previous session are going to make themselves available for more chat as well in case we don't get through things in the Q&A. There's a table, again, at the top of the stairs where you can find the speakers from the previous session to chat to. Go and talk to them. I mean, they love a chat. So they will be there for you to talk to at the end of during each break. Okay, I think enough. You've heard plenty from me. Shall we get started? Yeah. There's enthusiasm down the front. I love it. That's great. Let's get things started today the way we mean to go on. I'm very excited to be able to introduce Mark Zeman to the stage today. Mark has traveled all the way from New Zealand. He has a creative background. He used to be a creative director once upon a time, cares very much about the experiences people have on the web, and of course how that bleeds through to performance, or is influenced rather by performance. So as the founder of SpeedCurve, that does all kinds of user monitoring and benchmarking and all of the rest of it. I had a wonderful conversation with Mark just yesterday, hearing about how the language we use when we talk about the building blocks of the web influences various things, and how we think about that and what we should be measuring, and how it opened up all sorts of possibilities for me. I was really interested in that. So thankfully we have a talk on that subject today. So let's start as we mean to go on with lots and lots of noise in this room. A huge round of applause, please, for Mark Zeman.
Thank you. Good morning. I just want to start by saying it's an absolute privilege to be here. This is my first Perf Now, and I just wanted to take a moment to thank the co-chairs, Tammy, Harry, Tim, for keeping our web perf community alive. As many of you know, conferences have come and gone. We've had Velocity, we've had Fluent, we've had all sorts of things. This is all we've got left. And so it's really special that we keep this going. Thank you to PPK and Krishnan. It's just great that we're here today. And I also want to thank you for coming as well. So just a round of applause, please, for the organisers. And so while I was thinking about why I love this conference so much and I love the WebPerf community so much, I was reminded of a conversation that I had over 20 years ago now. And I had dinner one night with a journalist, and he was retired. He was pretty old, he was pretty cranky. We spent all night debating things. And this was before the dot-com bubble. I was still young, I was still enthusiastic. I think, I spent most of the night talking about the web and the internet and how much excitement and enthusiasm I felt about that. And probably talked about things like, how it democratizes location, that information was going to, transform the way that we interact, that humanity was going to evolve through this thing we call the internet. And I still kind of believe those things. And I remember at the end of the night, he kind of turned to me and went, I've met a lot of idealists in my time, and most of the time they are quite jaded and quite cynical. And he said, you know what, this is probably the first time that I've actually met, is that working? A hopeful idealist. And that label kind of stuck. And I really, I like that. And for the last 20 years, I've gone, okay, that's me. I'm a hopeful idealist. That's the thing that allowed me to start a company, to do all sorts of other things, to reach out to the Perth community that has been so supportive of a little old Kiwi from the edge of the planet, from New Zealand. And it made me think about this conference as well, and what we do at conferences. And so, this is what we're doing here. We're putting together a whole lot of ideas. We're trying to be hopeful. We've got some wonderful speakers here. I can see Matt Hobbs down the front here, the Government Digital Services from the UK. I'm sure you've all come across them before, but they're literally transformed the way that government departments interact and bring sort of democratic ideals to making information accessible, and they've inspired governments all around the world to do that. To me, that is an organisation that has that hopeful idealism to it. Tim Cadillac, his talks, I'm not sure what he's going to talk about, but often we talk about accessibility, about the impact that JavaScript has on people on slow mobile devices. He reminds us that we need to think beyond just the little tech bubbles that we can live in sometimes. So those are all, wonderful things that I hope we all do at the conference over the next couple of days. And so I'd like to invite you to join in with me and to also be hopeful idealists. Yeah, I've got one. Yeah, so make some noise if you're a hopeful idealist. Come on. Woo! Nice. Okay. So I need to start with a confession. When I started putting this talk together a wee while back, I also discovered AI. And I spent a lot of time talking to ChatGPT, and I spent even more time interacting with Midjourney. And if you haven't come across Midjourney, Midjourney is a generative image AI where you put in simple prompts and it generates imagery for you. And so in the development of this talk, I spent probably more time in those tools just playing and marveling at what has been created and allowed me to create than I did the actual talk. So today you're going to see a whole lot of imagery. Most of it is generated in Midjourney. And it's a bonus as to what you're going to see. And you're going to laugh at this, but one of the very first things that I did, one of the first prompts that I put into Midjourney was actually my master password. And you're probably wondering at this point, who is this fool? Let's send him back to New Zealand. I'm not going to trust anything he says from this point on, but bear with me. This is my, it's not working very well. This is my sniff test. So this is my master password. This is the phrase, the affirmation that I use to unlock my whole digital life. And for me, this is a bit of a sniff test. So I think we're a long, long way away from the singularity, from general AI. And so this is my test. If I put my master password into the AI and it doesn't immediately hack me, then I know that it's not sentient in any kind of possible way. And I don't know, you guys might have the last laugh. Like in a couple of years, I might be some meme. Remember that guy that put his master password into the AI? It finally hacked him. You know, it took his full self-driving Tesla and it drove off into the distance with his Roomba. It's like, who knows what's going to happen? And so as I look at this image, what I want to really dive into today is like, what am I doing on that laptop? What is that thing in front of me? And like the hopeful idealist that I talked about earlier, to me, language is really, really important. And, oh my gosh. Language is really important, and to me, it expresses a intentionality. And so I want to talk a lot today about words and how words shape the way that we build things. And so the first word that I really want to dig apart here is this idea of the page. And 30 years ago, when the web was starting to evolve, we came up with this language, these sorts of ideas that helped us understand what the web was. We had pages, we had sites, there was a web. I seem to remember quite a few spiders. I'm not sure where they've all sort of gone. And we surfed from like page to page. That was fun. And so I really want to break this down and think about the language we use. There's other language that we use when we're talking about interaction. Often you hear people talking about making their interaction buttery smooth. And so when I asked the AI to put these ideas together, give me a buttery smooth page. I don't know. Is this the internet? Are we doing it well? Looks kind of tasty. I'm just, do I want to lick that? I don't know. I'm not sure. And so the sort of hypothesis I have for you today is that thinking in pages, that the language we have, it is actually, it does create constraints. And to me, at this point in time, 30 years in, it started to become quite monolithic. And I really want to pull those apart today, think about how we can deconstruct the page and reimagine it to build the next set of web experiences. So I want to bust up that monolith. I've been having nightmares about this space ape kind of top, kind of right there. I don't know what that is. Is that what we're going to evolve into? Let's burn those pages down. And you can see here why I'm so enamored by Midjourney. This was the prompt behind this image. A simple sentence, it's not even grammatically correct, it's just a bunch of keywords. And look what it's generated. The shading, putting these ideas together, like it really is phenomenal. And so how are we going to pull apart this page? And so my background is in design, and I started out in design and then transitioned into code. And the thing that always occurs to me when I put my user experience hat on and I come at it from that direction is that rather than thinking about the code, it's actually about the pixels that are on screen. And to me, not all those pixels have the same value. So how we build and organize those pixels, how we actually ship them, are really kind of fundamental. And that's what we're going to look at today. So what do I mean by that? If we take a simple marketing site here for a mountain bike website, how might we divide that up? And so you might imagine that you're building this with some divs, you're putting some elements together. We're going to talk about these as sort of islands of content and explore how we might do this. So our loose kind of theme today is islands. we're going to think about how we take an island of content, how we actually approach that from a design process, how we then might build that, and then finally how we can then measure those islands of content and hopefully move on from the page. Okay, so designing. Something that I have really noticed over my career is a shift from where we started out, where a web designer did both the code and the design, and it was a single role. And over time, we have broken that role apart and turned it into specialization. And we now have, front end, back end, marketing, all sorts of things. And unfortunately, in certain points, and certainly in organizations of scale, we find ourselves in silos. And that really doesn't lead to good user experiences. And the classic example of this is when you get marketing, running away, going, these are the ideas we want to communicate. They then go to a design team. That design team might create a full static Photoshop kind of layout, get that signed off. Great, this is what we're building. And then it gets thrown over the fence to developers, mainly you folks, and you're just like, okay, how am I supposed to make this fast? It's got all these rich ideas in it, it's got so much in it. It just, you're kind of hampered from the outset by having to deliver something that you didn't have an involvement in the creation of it. And so the thing that I've found really successful throughout my career is no secret, lots of people are kind of doing this now, and that is to have small interdisciplinary teams. And when I say small and collaborate early, I mean like really early. So in this example, it was a news website that we were creating, and in the room we literally had, the product owner, we had a UX researcher, we had a designer, and we had a developer. And they were all working in a very iterative fashion to create this experience. And most importantly, everybody was collaborating around the final output, which was actually in the browser. So the designer wasn't working in Photoshop, they weren't getting things signed off, and then the developer was there. We actually had a stream of content coming in, and from day one, we were iteratively working through ideas. And we had a weekly cycle where we created something in code that was an expression of an idea. The UX researcher went out and actually tested that, and then we fed that back into the next week. And so we iterated that for 5 or 6 weeks. And there are lots of opportunities to bring performance into the discussion when you do that, because you're immediately in code, you have a prototype from day one, you could put some measurement boundaries around that. You can talk about how fast or slow do we want this user experience to be. If we put too much JavaScript in there, what's going to happen? And we can identify that right in the creative process at the beginning. So if you're not already working in this sort of methodology, I'd really encourage you to try and do that, to try and get involved as early as possible in the design and development process so that it is collaborative. And if we think about our islands, what we're really talking about here is taking people out of those silos and putting them together on this small collaborative island where they work together and work on creating a new experience. And all sorts of things cropped up. So this was clearly a slow news day in New Zealand. A kumara is like a sweet potato, and so I think this was a Friday afternoon. I don't know, everyone in the newsroom must have been drinking beers or something, because this was the headline national news. And at this point in time, we realized maybe this isn't the right template. The content that's actually coming in, that was our real-time content that we're working with, it's not that great. Like, their image is a bit kind of, the headline. And so this caused us to, rethink some of our approaches. And if a designer was doing this in isolation, they would have found some, beautiful headline, a really nice kind of dramatic image. The client would have been looking at that same image the whole way through the design process and would have had it signed off. Then it would have gone into production and they would have seen issues like this. And so one of the key outcomes of this was not only design changes, but the product owner in the room went away and talked to the newsroom and just went, you can't do this. This is not good enough. Okay, the other thing that I want to do to try and break apart this page is that, to me, the idea of a page, that metaphor, doesn't really work for the web. I inherently believe that the web is a time-based medium. If you're thinking about a page, if you think about a nice coffee table book, you turn the page, boom, it's all there, it's already been rendered, you can enjoy it, it's great, it's good to go. That doesn't happen on the web. We click things, it can take seconds, sometimes tens of seconds to load things. How you actually spend that time is really, really important. And so we do have some tools and products that we can use to explore this. So this is a simple timeline where at the top, we're just looking at a frame every 10th of a second. We've got some key events, we've got CPU stuff at the bottom. The main thing I want to focus on here is just how long is it taking to render this marketing page that just has a simple mountain bike on it. And what does that experience feel like as it kind of renders in? You're asking me to spend, it's nearly 10 seconds here of my life waiting for this content to come in. You probably thought it rendered instantly, but it just doesn't. And as you can see here, you can expand that waterfall, and at this point you're all probably going, what the heck? What is going on there? And we'll explore this a little bit later in the talk, but yes, hundreds of resources down in the waterfall, the hero image finally loads, and that's why it was 10 seconds or so into the page. And so this idea of breaking up the page, of thinking about teams, we can approach this in a number of different ways. So this might be how you construct your page, how you pull it apart. There's different dimensions and lenses we can put on this. Is it static content? Am I building an app that goes in that slot, that island? Who's responsible for those different parts of the page? And so rather than thinking in pages, once we start to break that content down, once we start to think about the pixels that are important, the way we group those pixels into islands, how might we approach that as an organization? And it can be really valuable to think about it with those different lenses on. Okay. Now we're getting into the meat and potatoes. Building an island. So it's no surprise that we've been on quite a journey over the last 10 years. We started out with what we're now calling multi-page applications. I guess that was just, the web, the platform, whatever it used to be. And we've been through this real arc of exploring, I guess, developer convenience. And I love the frameworks that are out there now, the convenience that it creates. Building components, working in React, Svelte, whatever your chosen platform is great. But we're now seeing the real downsides of those strategies. And it really is as simple as we're just shipping far too much into the client, into the browser. And we're expecting that browser to do a whole heap of work for us. And that might work on some of our modern devices on the end of fast connections, but it doesn't work for everybody. And so we do need to think about the next billion or so people that are coming onto the internet. They're often in places on mobile connections, they're on slower devices that don't have as much CPU and as much memory, and instead we're jamming a whole lot of JavaScript into that client and expecting it to perform really well. and it simply doesn't. And so thankfully, over the last few years, we're starting to see a lot more discussion of the negative performance impact of our JavaScript frameworks and how we can address that. And so, as you can see here, there's various strategies around how we might approach that we're starting to explore. Server-side rendering, how can we do it all on the server? How can we then deliver some static HTML and then hydrate it? That has its own problems. How many times you're on a website and it looks like it should be interactive and you're like clicking away, and in the background it's still downloading a shit ton of JavaScript to try and make that page interactive, and it's just not there yet. So we've got ideas like progressive hydration, where we're trying to prioritize what it is that's coming down into the client. And so the new flavor of the month, I'm liking where this is starting to go, and that is islands architecture. And this is really a mixture, I think, of moving back to that multi-page app idea of using the platform as your primary delivery mechanism, like how the actual browser works, and then bringing in these islands of content and making them interactive when they need to be. And so Katie Sawyer-Miller at kind of Etsy coined this term, islands architecture. I think it's a really interesting idea, and it's a simple idea. It's going, let's get back to basic HTML, let's deliver that into the browser, and then really break apart the page and think about what needs to be interactive. And so if I have a whole lot of static content, that can be served from the CDN straight away into my user experience. I can see it, I can enjoy it. And then if there is something interactive, think about how that renders into my user experience, rather than locking the entire user experience behind a single page application and forcing me to wait for that to be instantiated and come alive on my browser. And it can really make a fundamental difference. And so the framework that's really championing islands architecture at the moment is Astro. I really encourage you to check it out. And so it is primarily a multi-page app-focused environment. And this really comes back to picking the right tool for the job. And so if you're a marketing site and you're delivering a lot of primarily static content, and then you just need a little bit of interactivity somewhere, this can be an absolutely fantastic approach. If you are genuinely building a single page application, and I would stress the application part of that, are you building something as complex as Gmail or something like that? Are you actually doing that? And if so, then a SPA might be appropriate. But I worry that people coming into our industry now are learning these frameworks as default, and they're using the same tool for all the same problems. And it's just not appropriate. And so Astro is something that I encourage you to check out. The stats here are quite entertaining, like they're true, but it's basically, if you turn off the SPA, it is faster. It's kind of that simple. It's also quite delightful in terms of the, it's only additive, which I really like. We're not replacing React, we're not replacing Svelte or Angular or whatever your chosen language is. You've already made that investment. You can use React here. You can build your designed components, you can put it all together, and then it just gets rendered as static HTML. And so this really is the best of both worlds, where you get to use all that lovely developer tooling, all that convenience, the collaboration across the team, but then it doesn't compromise the final output. It's still just static HTML, which is amazing. And then when one of your islands does actually need to be interactive, you can put this simple client load attribute onto it, and now into that island and just that part of the page, it will become a React app. And also there's some really nice methods here that allow you to manage how it actually loads. So should it load straight away, or should it lazy load? if you've got some interactive component that's down the bottom of the page and it's out of the viewport, don't even need to load that on initial load. And then as I scroll, it'll lazy load in those components as required. So I really like this. I think this is a great approach to solving the conundrum that we find ourselves in with all the JavaScript that we're shipping, and being a lot more deliberate about the choices and the way we send that in. Just going to skip that one. And so the other thing that this reminds me of, which I'd love to see more discussion in the perf community about, is the critical rendering path. We used to talk about this quite a lot sort of 10 years ago, and I think it's still a really, really important concept. And it comes back to that time-based methodology that I was talking about earlier, and that is that this is a time-based medium. How we actually render into the page is really important. We're taking people's time. And so if you are stuck in one of those environments where it's just marketing, build this fully rendered experience, we can end up with these horrible moments where we've got a spinner or we've got a blank slate and we're waiting for lots of resources and lots of things to download before, boom, we see a page. That can often be a terrible experience, and there's no need for that. The browser has wonderful mechanisms in it to preload content, to manage priority. We can give it hints about the most important things to load first, and we can create a critical rendering path that unblocks some hints for our users. We can let them know that they are in the right place rather than staring at a blank page. We can give them some color, a logo, some elements, a bit of a skeleton. If you've seen talks about perceived performance, there are all sorts of design tricks that we can use to let people know you're in the right place, the experience is coming, it's here, it's good. And so if we go back to our marketing site and that terrible waterfall that we saw at the start, this is just an educated guess, but I think what has happened here is that on the right, we have this great little interactive app that tells me how much stock there is for this particular mountain bike. And if I put in my address, it'll tell me, does the local store have one? So some great functionality. And what I imagine happened in the team is they went, okay, let's build this little corner in React. And then they were like, well, if we're already doing that in kind of React, why don't we, put the model in, like the images for, the content right next to it. And if we're doing that, we've got all these other models on the website, we might as well shove those in our app as well. And suddenly this little bit of interactivity has eaten the whole page, and we've ended up delivering a whole lot of user experience in a spa when it really doesn't need to be. And all those resources you saw at the beginning was a whole bunch of CSS and JavaScript and all sorts of things for hundreds of models that are on this website. And we're forced to wait for all of that to come down the wire before I see the one actual image that I care about. And I can show you the impact of that. So this is not even a particularly slow connection. I think this is like 5 or 10 megabits on a desktop. And all I've done here is I've taken that very same content as static HTML, and I've put it up on a crappy instance somewhere on the internet, and I've just compared those two experiences. So it could be even faster than that. And the problem we see here is that the spa and how long it takes to put that JavaScript together, to then choose the particular model that I'm on, to then find that image and download it, means that we've defeated all the great tools that we have in the browser. Like, the browser didn't see this image until about 5 or 6 seconds into the page. And then it doesn't actually render till 10.5 seconds here. That is a huge amount of time. There is nearly 9 seconds in there that is consumed by that spa. This is terrible. This is terrible user experience. We shouldn't be doing this. if this was delivered as static HTML, we could be rendering this in, probably less than a second if we did this properly and had it cached on CDNs. And so what these people needed to do was to really have an islands architecture and go, great, this bit on the corner, this needs to be an app. Let's create an island around that. Let's deliver that as a rich experience. In that first second or so, I should see, is this the right model that I want to look at? I can be reading the specs. I could be engaging with all this content. And in the meantime, even if it took that 10 seconds, you could be loading that in the corner, putting that together, and then I can interact with that when I choose to. So I think, to me, this shows how powerful having a different methodology is to approaching the way that we construct our pages, if we think about them as islands of content. Okay, so how do we measure an island? Now, I'm really, really lucky. I get to live on a great island down in New Zealand on the edge of the planet. And I'm part of Speed Curve. We're a small company. We're spread all around the world. And Hawaii is kind of in the middle for most of us. Sorry, Andy, not for you. But it's kind of in the middle. So this is where we do our offsites. This is where we get together. And this is us. We're a small company. It's quite fun. A lot of people think that Speed Curve is some huge, big, multinational, VC-funded thing. It's not. This is us. There's only kind of 8 of us. We're bootstrapped. And just this last month, we turned 10 years old. So happy birthday to us. And we're all here at the conference. We like to sponsor the parties, so come and have a drink with us tonight. Bring your hopeful idealism. Because we're not VC backed and we have no politics, the only thing we really care about is our users and the features that they want. So come and talk to us tonight, hit us up. After the conference, we've got 5 days here at an offsite where we're deciding what we build next. So this is your chance to kind of, really feed into where we go next. Now, the only person missing is Steve. Steve's actually retired now, if you didn't know. He lives in Hawaii. This is all he does every day. He's out there. Look how happy he is. And so the reason that I wanted to take this tangent is I wanted to talk about metrics and small teams and our community and how accessible it is. And something that struck me when I transitioned from sort of design into web performance about 10 years ago now is that it was very engineering focused. Things were measured at the granularity of the page, and user experience felt like it was missing to me. And so I asked a lot of questions. We spent a lot of time brainstorming around what is the user experience and how might we measure that and represent that so that people can actually understand where the problems are. And one of the really simple ideas we had was that, in JavaScript, once the DOM was finished loading, we could, look at a particular element. We could find the largest element on the page. We could get a rectangle of what that element was. And then we also had this film strip. And we were like, hey, what if we just looked at the film strip and we looked inside that bounding box, and when all the pixels stop jiggling about, we tell you when that element has finished rendering. And so it was this really simple idea that we called hero times, where we could choose different elements on the page and we could tell you when they stopped rendering. There were issues with this. If you have animation or overlapping elements, sometimes it can make things tricky to measure, but it really sort of helped move, I think, metrics forward into thinking about the user experience and how we represent those. A number of years ago, kind of Paul Irish picked up on our idea of hero times. He liked thinking about, we had multiple heroes that we were measuring, and he was like, what about the last painted hero? And, Steve's sort of like the godfather of web performance, so he was the last painted hero. And then this idea evolved, and the Chrome sort of team went, okay, well, let's implement this in the browser and let's do it properly, not the hacky sort of way that we had done it with film strips. We're building the browser, we can actually understand and tell you when elements render. And so that led to largest contentful paint. And I use this as an example to, share some history, but also to encourage all of you that, we have a tremendously accessible community. And the thing that has always struck me is how welcoming the web performance community has been. When I turned up as a Kiwi 10 years ago and went, hey, why aren't we measuring, user experience? How might we do that? I was welcomed with open arms. And any idea can be, a good idea if it has merit and it'll travel. And so I encourage all of you, even if you think all this stuff gets decided in ivory towers somewhere, to participate. And conferences like these are great venues for throwing around these ideas. And so we've got largest contentful paint, cumulative layout shift, first input delay. You'll recognize these as our Chrome Web Vitals. And I just want to pause for a moment and I want us to say thank you to the Google team, because there is a number of people in the audience here today that have contributed to Core Web Vitals. And I think over the last few years, it's really led to a shift in the way that we talk about web performance, largely for the better. So, can we have a round of applause for And the reason it's been so great is that there has been lots of confusion in the industry. There's been so many different kind of metrics. And so to have someone champion and go, what about these as a set of metrics? What about if we focus on these? How might that work? And I think it has really helped us focus as a community on these three metrics. Now, a bit nervous about this next bit. It's kind of like breaking up with a girlfriend. It's not you, it's me. We're just going our own ways, we're growing in different things. I want to critique where we're at with Core Web Vitals. As much as I love where we've got to, I think we've got some challenges. If you take your web performance hat off for a moment and just look at these words on screen, can you imagine being new to web performance? Trying to understand these words, trying to understand the nuance and the complexity of what's going on here. We've got a couple of people on our team that are fairly new that have come into web performance, and it's taken them a long time to really transition from Lighthouse is wonderful, and seeing that score out of 100, that's really digestible. Those are great things. But that transition from the high-level abstraction into these sets of metrics, I think that is deeply challenging. And a lot of that is to do with the words. And it's also to do with how quickly this space evolves. As you may know, we've got first input delay. We had some issues with that. It didn't really give us enough feedback in terms of being a good metric. So that's being deprecated. In March, we're switching to interaction to next paint. What's that about? Got to learn a whole new thing there. Does anyone remember this one? First meaningful paint? Oh, I love this metric so much. It's like, look at it. First meaningful paint. Finally, a metric that tells me what it is. It's meaningful. This is the only one I need to care about. And it's like, it went away. I don't exactly know why. It was, something to some bipolar metric, it all got complicated. And so this has been deprecated and it's gone away. Something else I've been struggling with recently is cumulative layout shift in the windows. We talk to people all the time that still don't understand how this metric has evolved. And I'd be keen to get a show of hands. So if you may not realize it, when cumulative layout shift first came out, it was all the shifts. So all the shifts got added together and it would have been the 0.43 there. But then we realized, well, there's an issue there because spars are really long-lived and it's a page, but it's not. And so we came up with this idea of windowing, which is great. So now we have this traveling 5-second window and it resets every couple of seconds when there's a gap in the rendering. And then the cumulative layout shift that gets measured is the one that's in the largest window. And here you can see part of the problem with that. As a user experience person, I care about all the layout shifts. These 2 shifts here that are being ignored, that are big shifts, I still want to fix those, but they're now invisible in terms of the cumulative layout shift. And I think to me this all speaks to how difficult these words are. And so when you say cumulative layout shift, people automatically assume it's the accumulation of all the layout shifts. And so, but it's not anymore. And this is great. This is good movement in terms of what we need to do with metrics, but it's still, it's just hard. Yeah, it's me. I'm struggling with this relationship with Core Web Vitals. There's other challenges we have in these metrics, so unexpected LCP, depending on the viewport, sometimes the element that gets chosen as LCP is not the one that you expect it to be. So in this example, when the cookie consent pops up, that paragraph of text is actually bigger than the H1, the first item in the list here, which, I probably keep thinking that it's this one when I'm looking at my metrics, but actually a lot of times it's this one. And so there's all sorts of challenges with these metrics. Sometimes we have bugs. So these images will look kind of the same. Per the spec, that first bag should be LCP. It's not, it's the second one. Woo! And, all credit to the Google team. They work on a lot of these issues. They're really important metrics. We're trying to kind of fix them. And so I want to break up. I want a new girlfriend. And I want this to be my new girlfriend. The Web Performance Working Group, I think, is an underrated and unloved section of our community that we all need to spend more time getting behind. And there's a number of reasons for that. One is just browser support. So a lot of the metrics, a lot of the core Web Vitals are still Chrome only. And we just can't continue to ignore large parts of our user base. Some websites have a lot of mobile traffic that can be Safari only. To have no visibility into that just doesn't work. And so the more we can get behind our standards bodies, the more we can have cross-browser support for metrics, the better. I've just got to take a quick time out and talk about this logo. Is Yoav here? Did he draw this? I've seen some of his drawings in previous presentations, and what is that? I don't know. Is it a cat? If you picked up a cat, when you pick up a cat, it goes really floppy. If you put wings on that, and it's isn't that going to be really slow? I don't know. I struggle with the logo, I've got to say. I think we could do better. And so in my alternate universe where I've broken up with Core Web Vitals, what is that relationship based around? And it might surprise you to know that if I had to pick just one metric that I wanted this body to implement across all browsers, it actually wouldn't be any of the Core Web Vitals. It would be this one. It'd be element timing. And the reason that I like this approach, this is an experimental spec that's already implemented in Chrome. You can use this today, and it's really, really simple, and that's why I love it. you can put this attribute, element timing equals whatever the name you want it to be represented as, and you can put this on an image or a text node. I'd love it if I could put it on a div or something like that and just sort of break up my page and understand when that particular element got rendered. And to me, that takes a lot of the complexity out of this, because I know my own website. I know what's important, and I can choose those elements that are really important and then measure them. And so to me, it becomes really simple. And so this is supported in Rum and Synthetic. As far as I know, SpeedCurve is still the only product out there that supports element timing. So you can do this today. You can add more, yeah? Who's that? Is that Debug Bear? RumVision, yay. I'd love everyone to support this. I think this is a great spec. So you can use this today in RumVision, in SpeedCurve, hopefully in more vendors soon, to just say, this is the element that I care about. Tell me when it renders. And why is that so important? And to me, it's because of this. And it's that getting an organization to care about performance culture, can be really challenging. And so when you define an element and you decide to measure it, you make that so much more easier. I don't know about you, but when I have to get in front of people and try and explain LCP and cumulative layout shift and all those acronyms, all those concepts, and trying to get a whole organization to care about that, like, we sort of get it. I think even amongst us, there's debates as to how things work and how they should work, but trying to get someone in marketing or someone in design to care about those metrics can be really, really tough. But if you worked at somewhere like Twitter, X, whatever we're calling it now, and you had a time to first tweet, like, that is a metric name that instantly travels and is recognizable throughout that organization. And I think you can probably look at your own products and think of an equivalent metric that if you could just measure, in this case, when is the first tweet, when is it the first item in my cart, when does that come together, then how much easier would that be? And this is why I love element timing so much, and why I'd love to see it supported in all our browsers, and then I'd be really happy with my new relationship. All right, winding it up. So, the takeaways that I have for you today is I'd really love you to think about these smaller islands, think about the language we use and how we can move on and stream content into the browser. Just changing some of that language can really change how we think about our experiences and the way that we build them. Don't prioritize the developer experience over user experience, please. Everything has a cost, especially those spas. I think we all kind of are starting to understand this now. It's got to be a balance. Keep measurements simple and keep it really easy for people to understand across the whole organization rather than just the developers. We want to build that performance culture. And so what I'd really like you to do is to move your mental model away from I'm a coder, I'm a hacker, I'm pushing code every time I deploy. Thinking like that keeps us focused on the tools, it keeps us focused on the frameworks, the mechanics of like what I'm actually doing. I want you to, the next time you're doing a deploy and you're drumming your fingers waiting for it to kind of hit production, say to yourself, I'm pushing pixels, I'm not pushing code. And then, who are the people that are seeing those pixels? What is their experience like? How can I deliver a better user experience for them? How can I push better pixels? Yeah, thank you.
Thank you so much, Mark. Fantastic way to start the day. Mark, do you want to come and join me?
Yes, I do.
I called this the lounge earlier on. I don't know what I was thinking. This is an odd lounge, isn't it? Oh, up we go. What a brilliant start to the conference. I'm nodding along furiously to so many of the things that you mentioned. There were quite a few questions. I'm going to leave some of them for the chat upstairs and be quite thrifty here. But MPA, SPA, SSR, CSR, ESR, FML. It feels like acronyms are everywhere, right? And you call out the importance of language and the fact that MPA and SPA in particular have this word application in them, and it feels like that implies that we're building something of a particular stature. How can we get past that kind of issue? Because it feels like we're encouraging people to ship more code potentially, or use things that feel more complex. So Brian asked, how do we convince others to reduce the amount of code they ship? And I'm just kind of curious about how language impacts that and how we can possibly address that, since it feels like we're always adding more complexity and innovation.
I think it's a tricky one. What it reminds me of is an experience I had when I was still working as a creative director, and I was talking earlier to Sergey, and it was like, is it numbers that motivates people to change, or is it visuals, or is it a combo of the both? And we were working on this website that had a tremendous amount of third parties. Marketing teams from around the world were just dumping in remarketing tags, all sorts of things, and it was a problem. And we couldn't get any movement based on the metrics. And the only thing that worked is I created 2 film strips. No numbers on them at all, 2 film strips. One had all the third-party stuff turned off, and the other one didn't. Right. And there was about a 3-second rendering difference. And when I put that in front of the board, they were like, what's that? Yeah. What's that empty hole? What's going on? And we were like, well, that's the impact of your third parties. That's the impact of, I guess, making this an application. Right. And that simple visual led to a board decision where they were like, turn it off today. Just turn off all the third parties. Like, we'll make them squeal, we'll figure it out, they'll do a proper audit, we'll move. And so I bring that up because it's not always the numbers, and it's not always the technical stuff that can convince an organization that an application isn't necessarily the right idea. Right. Yeah. Yeah, it has to be really tangible, right? Yeah. So people have to feel the pain. And I guess the challenge is making that happen early enough so that you're not committed. Yeah, right? and communicating in a way that works across the organization. Indeed. Yeah. I've got a list of questions that I'd love to get to, but you are prepared to go up to the speaker table and talk to folks around the audience, around the conference rather, for the rest of the time, right? Yes. Amazing. Okay, so in which case I'm going to cut us short. Thank you so much for a wonderful start to the day. A massive round of applause, please, for Mark Zeman. Thank you, Mark. Thanks so much. Okay.
Friends, we are going to start again in just a minute or two. So if you're still grabbing refreshments, now's the time to start making your way back downstairs to your seats. And we'll get on with the next section in just a couple of minutes. So yeah, please make your way back downstairs, find a seat, and we'll get started in a moment. All right, folks, so just a reminder as you are finding your way to your seats, if you can consolidate and leave some space at the aisle, that will make it easier for people who are arriving after you to find a seat. Just avoid that awkward shuffle past to find the empty seat in the row. So yeah, just another couple of minutes and then we'll get started. So come on in. Plenty of room up at the front, over here. Actually, both sides. There's seats over there, seats over here. Don't be shy. Okay, then. So it looks like most people have just about found a seat. Keep on coming in. Don't worry, there's a few seconds of me before we get to Baz. But come on in and find a seat. While people are milling in, did many people get to the meetup last night? Yay! Yeah. Oh, there's weary voices. Well done for going to that and also being here. I hear there was a quiz. There was a quiz there. Thanks to SpeedKit for making that event happen last night. I gather that there was a quiz and there were winners of the quiz. Second place I gather was Mr. Andy Davies. Is that right, Mr. Oh, third. Okay, third. The fact that he came third might be the reason that he forgot his certificate, which is out by reception for you. So the people who won first and second, proud they took their certificates. Third place, you shouldn't be ashamed, Andy. You shouldn't be ashamed. Second loser, Andy Davies from the quiz last night. You get your certificate. But yeah, our thanks to SpeedKit for organising that. Okay, I think folks have just about found their seats. If you are still milling in, that's fine. Come and make yourself comfortable. Because now I get the opportunity to welcome Baz. Baz Schouten is here to talk to us next. Baz is tech lead working on Mozilla and also has a history. Those bells are, can everyone else hear those bells? Okay, that's a relief. That's not a good omen, is it, for you, Baz? Like the bells tolling for you, or maybe you requested it. I don't know, but there we are. That's the mark of the hour, I guess. But Baz also has a history in computer graphics and like squeezing performance out of GPUs and also kind of working with OpenGL. So has very interesting background in terms of performance. Now kind of concentrating a little bit more on kind of benchmarking and what happens, and also caring for all browsers and thinking about how the variety of browsers available to us is important, and thinking about the tooling that exists in those. So not surprising then that Baz works at Mozilla, working on the tooling in Firefox. So I think we should hear from him next. Are you ready for your next talk? It's the best I can. Are you ready for your next talk? So proud of you. Bravo. Please, a huge welcome to the stage. It's Baz Schouten.
Thank you. We're all here to talk about performance. And the reason for that is obviously because we've all heard this statistic, right? 1 second of an improvement to page load means a 27% increase in conversion rate. And what does that mean? It means that 1 second improvement to page load, you could be selling 27% more products or something along those lines, right? These next couple of days, most of what you'll be hearing about is going to be helping you improve your websites. I'm Baz Schouten. I am a principal engineer from Mozilla, and I am the tech lead for Firefox Performance. And I'm going to be talking about what we can do as browsers to help your websites be faster. In reality, applying performance best practices to your sites and services is much more likely to move the needle for your user more significantly than anything that we as browser engineers can really do. However, the unique leverage that we have as browser engines is that improvements to the engine diffuse quickly and across the web. And they apply to all users and all websites. And so to really make the web fast is an industry-wide effort. And we need both. We need you advocating performance and best practices to your teams. And we need browsers bringing cumulative improvements to the web, making it faster for all users. And so today, I'm going to talk about how we as browsers can become better at doing that. And I'm going to do that in this. I know. Well, now you should be. It should have just been black. Is it there now? There you go. So this was going to come in as dramatic effect, right? But sadly, that didn't happen. I'm going to talk to you about Speedometer 3. We've been fortunate to work with Google and Apple at standardizing a new way of benchmarking performance in browsers. So there's a couple of things I'm going to be talking about. First of all, I'm going to give a brief history of browser benchmarking so that we understand a little bit more of the landscape and how this came to be. Then we're going to talk more specifically about how Speedometer 3, how the idea evolved, and what it is now. As the next step, logically, we'll be talking about what speedometer is measuring and what kind of workloads are in the benchmark and how do we pick those workloads. And finally, I'll be talking about our experiences optimizing for this benchmark in Firefox, and I'm going to look at some real user monitoring to see whether we succeeded. So I'm guessing I need to stand closer. There we go. So first, a brief history of browser benchmarks. For the early years of the web, testing the performance in browsers was sort of a niche thing. And it was happening in most browser engine code bases, but there wasn't much interest outside of that. Slow network connections and static pages meant that the performance of the rendering engine on the early web was not that important for the experience that people were having. As the web became more dynamic, it wasn't until the second browser wars erupted in the mid-2000s that an interest for benchmarks started to evolve. As the technical press was writing one article after the other about what the best browser is and why you should be using one browser over the other, they turned to benchmarks to provide them with a quantitative way of comparing the performance of browsers in an authoritative manner. And so what the most popular benchmarks were shifted over time. But generally, there was always one benchmark, or maybe two, that were dominating most of the public discourse. The first benchmark that was widely used was SunSpider. Developed by Apple and released in 2007, it measured the duration of a number of workloads with a focus on latency. In 2010, Mozilla released a benchmark called Kraken. It never really became widely documented. And the real shift came when Google released Octane in 2012. Octane was a benchmark that focused much more on complex algorithmic workloads. It had more of a focus on throughput. A couple of years later again, Apple released Jetstream and Speedometer 1. At this time, Jetstream got most of the attention. Jetstream contained a combination of benchmarks of workloads from SunSpider, Ares, Octane, Kraken, and a number of others. And it tried to be a more balanced benchmark, but it continued to have issues. And in 2018, Apple released Speedometer 2. Speedometer 2 was developed with some collaboration from Google as well, and it was a huge improvement over the benchmarks we had at the time. Speedometer 2 measures a number of operations in a small to-do application called to-do MVC, and it then computes some times, as synchronous time and asynchronous time. We'll talk a little bit more about what that means later, and it assigns a score to that. While that was a big improvement to benchmarking the web, there were still a number of issues. For one, what these benchmarks still did was they forced us as browser vendors into a choice. Are we going to spend resources making our score on a benchmark better? Or are we going to focus on making our browser faster while maybe ignoring some of the perceived performance in our benchmark scores? These choices were not always aligned, and sometimes they were even in direct conflict. Sometimes a change which actually increases your score on a benchmark actually makes the real user experience worse, which is, of course, a situation that isn't great. And so let's look at what some of the reasons are for these challenges. First of all, there's representativity. Most of these benchmarks focused on complex, highly measurable, long-lasting workloads. If we look at Jetstream, for example, it has a cryptography library, a 3D ray tracer, a JS implementation of a regular expression parser, a JS implementation of a Gaussian blur. Needless to say, these are not generally the things that your websites are doing in JavaScript. They have a strong algorithmic JS focus, which is different from the type of JavaScript that you are running. And on top of that, the real web is ever evolving. These benchmarks have tended to be released once and then used for years, which means that as the web evolved, they became even less representative of what the real web looked like. And finally, all of these benchmarks were developed by one of the vendors. And that means that they were optimized and tested on one browser. They were developed by experts on that particular browser. And without even trying, that means you end up tailoring to and avoiding performance cliffs in that particular engine. And if that's not enough, there's, of course, also product marketing interests that can play a role in when you're developing or releasing a benchmark. And all of this means that there is an opportunity for the web performance community to do better. And so one question we can, of course, have is what does make a browser fast? How do you determine how fast a browser is? And why don't you use real user monitoring? Like this man. I found this while I was researching this talk, and they already figured out the answer back in 2012. The fastest browser, quite hands down, really, if you look at it, 40% faster than any of the others, is Internet Explorer. So I'm afraid that the web has really regressed over the last couple of years, because we'll have to do without that. But why don't we use real user monitoring, right? Well, aside from the fact that page load is a notoriously bad metric for the actual user experience, even if we're using other metrics, such as largest contentful paint, there are numerous reasons that RUM can never be the driver for proactive browser optimizations. And so we get to speedometer 3 and how that came about. So what are the advantages of having a benchmark? One of the first and primary advantages is that benchmarks are proactive in development terms rather than reactive. Benchmarks provide a way to test features and code before they actually reach users. While real user monitoring can help optimize a browser through A/B experimentation and longer feedback loops, benchmarks can test them in the lab. All browsers have certain quality control methodologies, right? At Firefox, for example, if you regress a benchmark, it triggers a regression alert. That regression alert feeds into a process where a bug is filed, and if the regression cannot be adequately explained, the patch is backed out, right? And all of this happens before the code ever reaches users. But at least as important is that these can be run locally and in the lab. And so that means that ideas that aren't quite ready to be shipped to users can be tested using them. And we can make decisions. We can iterate on ideas faster and discard the ideas that don't work much faster than we ever could if we were using real user monitoring. And that means that benchmarks help guide fast and good decision-making by browser vendors. At least as important, browsers help us with competitive analysis. And this is to all our advantages, right? We can't do that with real user monitoring. We can't compare the real user data coming out of Firefox and compare it to data coming out of Chrome, or take data coming out of Chrome and compare it to data coming out of Safari. These are not the same groups of users. They're in different locations. They're using different devices. They might be running other background processes because they might be more likely to use one browser at home versus using one browser at the office, right? And so benchmarks allow us to run the same workload in a consistent environment. In addition to that, for competitive analysis, they allow us to build a shared understanding of what needs to be fast. It means that all competitors know what it means to deliver a good web engine. And all of this is good for the web, and it's good for browser choice, and it's good for engine developers as well. And so this started because in the summer, did that work? Oh, there we go. And how this started was in the summer of 2021. Google had developed a number of extensions to Speedometer 2. They had added some new workloads, made some methodology changes, and they came to Mozilla and said, we really want to do something with this, and we don't want to do it by ourselves this time. By the winter of 2021, we'd internally reviewed the benchmark that they'd created, and we'd concluded that there was a legitimate opportunity to build something that was better than what we had. One of the primary requirements for Mozilla was that we wanted this to be a truly joint project. We contacted Apple, and we spoke with them about the benchmark. And they agreed. They saw value in this. And in the summer of 2022, we agreed on a joint governance structure, and the joint governance model was landed into the now public WebKit speedometer repository. Microsoft and Intel joined Google, Apple, and Mozilla for weekly cross-vendor meetings, starting to develop the actual benchmark. And in December 2022, there was a tweet, or X, I don't know what to call it these days, where Microsoft, Mozilla, and Google, Apple, and Mozilla made an announcement announcing Speedometer 3. Speedometer 3 was now born. And so what are the goals of Speedometer? First of all, Speedometer provides a place where browser vendors can talk to each other and align on what should be fast. It allows us to have a shared definition of what it means to be a good implementation of the web. And when doing that, it has other advantages, because we don't have to make all those decisions based on what is most popular in the core places where we ship, right? Or for the majority of people. We can look at things such as accessibility or language features that are only used by a couple of smaller languages in the world. And we can include them in the benchmark. And now there is a real incentive for browser developers to make sure that they perform well. And that can lead to a better web experience for everyone. Another core goal of the benchmark is that it needs to allow for effective optimizations. It needs to not have the issue that I spoke about earlier. It needs to make sure that when a browser has a higher score on the benchmark, that means that it actually has become faster for real users. It can't be encouraging overfitting for specific APIs, specific frameworks, or specific workloads. And it needs to not contain micro-benchmarks that encourage browsers to optimize very specific little things that are never going to actually be noticeable for a real user. And if we get this right, that means that browsers can safely dedicate their resources to improving these scores, improving the perception of the performance of the browsers, while at the same time making the web faster for everyone and your users. Now, what are the principles, then, that we built the benchmark on? First of all, and I think I teased this a little bit, joint governance. The benchmark is under a joint governance model, and what that means in practice is that all major changes to the benchmark that change the score or that add a workload are added by consensus between the three major browser engines, so Gecko, WebKit, and Blink. It means that the workloads need to be based on real applications. It means that the model provides for community involvement and community contributions so that all of you can help us make sure that the benchmark's workloads are representative of the types of things that you are doing. We are planning a regular cadence of updates after the release of Speedometer 2 to make sure that the benchmark stays up to date with what the web looks like at this point in time, or at that point in time. And finally, it needs to be simple. The benchmark needs to run in any tab without special tooling, and it needs to be quick. It needs to be fast enough that a user can look at it to make a browser choice so that the tech press can run it when writing an article. And finally, it needs to provide what all benchmarks have done, over the years, still provide a single authoritative score that tells us how well a benchmark performed. All of this sounds pretty obvious, but it is actually quite hard. And so I'm going to talk a little bit about how we define the workloads that now make up speedometer 3. So, defining new workloads. First, let's talk a little bit about what speedometer measures. Here you can see a profile of speedometer of one specific workload. You can see that there's these two things. There's a sync time and an async time. And I want to talk a little bit about what that means. Each workload consists of a number of JavaScript commands that simulate certain user interactions, right, and that trigger a bunch of work. The synchronous time is relatively easy. You put some performance timings around those actual JavaScript commands, you execute them, and you measure how long it took. And that's your sync time, voila, easy. The async time is a little harder. What you're trying to capture in the async time is all the things the browser does next to ensure that whatever that workload is trying to do has actually shown up for your users. And that's tricky. It can be tricky because you may not be measuring the same things between browsers. So what we've actually done is we've included a measurement based on request animation frame, set timeout 0, force layout, and we've put a bunch of those things together in kind of a clever way. And that actually gives us a pretty good approximation in all of the browsers between how much time the browser took to actually display that content. If you look at this, you can see that up here, those times actually, they have a little bit of different things in them, right? If you look at the sync time for this particular test, there is quite a bit of layout here, the purple that you see here. And if we look at the async time, there's actually a significant block of JavaScript, which is the yellow here, then some layout, some painting, and some other things, some styling. And so this is actually capturing most of the relevant work that is happening in these benchmarks, or that is happening in these workloads. And so the next question is, how do we actually decide what workloads to run? And that's not easy. The first approach that we considered is one that was focused on technologies. You would pick a couple of things, right? Like, I want SVG, I want some canvas, something like that. And then you would start building an application around those technologies. The problem is that already violated, kind of, as you start doing that, one of the core means of the benchmark. You start developing a benchmark that is actually measuring that particular technology, rather than the real user application that we were talking about. It very easily becomes unrealistic, and you start overfitting for the particular technologies that you're choosing. And some technologies may actually be much more common across different applications, and those deserve to get more coverage in a benchmark, right? Another approach that we considered was taking existing applications. But that provides issues on its own. First of all, you have to decide, what are the interactions with that application that I'm going to measure? That's not obvious from just saying, I have Slack, or I have Gmail, right? And then there's logistical limitations. How do you actually reduce those into a measurable workload? How do you make them measurable? And perhaps an even more important logistical implementation, most real applications that people use a lot are closed source. Even if you can somehow extract the source code or get at it in another way, you wouldn't be able to ship it, probably, in an open source benchmark. And so where this idea seemed interesting, it also wasn't what we ended up doing. And the direction we ended up going into was that we defined user journeys that were important on the real web, and that what people were going to care about. Around those user journeys, we built a realistic application using the most common libraries, the best practices for implementing an application like this, and we designed it with measurability in mind, right? Because in the end, we do have to measure the times. This is more labor intensive than any of the other options that we considered. However, it does make for much better workloads that are more representative of the real web. And it is the methodology that ended up guiding our decisions for most of the workloads. So now, I want to take a little bit of time and talk about what actually ended up in the benchmark. First of all, there's the trusty to-do MVC. How many of you actually recognize this from running a benchmark, this particular thing? Great. So this is what Speedometer 2 was all about, right? It was a to-do MVC application that was just a little to-do application called to-do MVC. It was implemented on a number of different benchmarks and with a number of different best practices in mind. And then it added some to-do items, and it checked them, and then it deleted them. And it measured how long that took. And that's great, but it was a pretty limited thing, right? It was one little user journey. And it did it on a whole bunch of different frameworks. What we've done for Speedometer 3 is we've done that thing that we spoke about, where we keep it up to date with the real time. Some frameworks, like Inferno, were retired. Other frameworks, like React and Vue, were updated to use the most commonly used versions of those libraries, of those frameworks on the web at this point in time. And those may not necessarily be the latest, right? We introduced some new frameworks that weren't around or weren't popular when Speedometer 2 was built. Svelte was added. Lit was added. And so that updated this so that we still have this user journey. We still have this broad coverage of the different frameworks, except modernized for the modern web. But like I said, this was pretty simple, right? And it didn't really look like a real application that much. And so engineers at Microsoft actually contributed something where they embedded this particular application into a much larger, complex DOM. We asked them to make it look like a realistic application. And this is what came out, right? It looks a little bit like a thing that you might expect a little to-do application to run in. And it provides a much more realistic layout tree, much more realistic CSS style sheets and things like that, right? And while it may not be obvious, considering the workloads that we run here are identical. We're checking the same, we're adding the same items, we're checking the same checkboxes, and we're deleting them again. It may not be obvious that that should be slower, but in every single browser, there was a significant increase in the duration of the tests when we made these changes. Because there's a more complex DOM to render. There is more CSS rules to match, right? And so we believe that this is a significant improvement in the representativity of the to-do MVC workload. Another thing that people care about on the web is looking at charts. Perhaps most of us, more than some others, but everybody uses charts in some way, right? Whether it's about the economy, whether it's about the stock market, whether it's about web performance, right? And so we did that. We included a number of chart workloads. And those are an interesting area, because as we looked into that user journey, there are so many libraries to choose from. And there's not only a bunch of different libraries. There's actually a bunch of different technologies inside the browsers, right? Some use Canvas. Others use SVG. There exist even some that use WebGL. We ended up having 4 different workloads. There is React stock charts, observable plot. You probably won't be surprised to hear that Chart.js is the other one used to implement the workloads. And there's my personal favorite, which is Perf Dashboard. And Perf Dashboard is kind of cool because the workload was built based on Apple's performance monitoring tools. So that means Perf Dashboard is now monitoring the performance of Perf Dashboard. So that's kind of a cool little meta trick. On top of that, there is something that I think we all do on the web for sure, and I was doing it as I was preparing for this talk, and it's editing. And in order to do that, we've added an editor workload. So there's two different types of editing that we've considered. One of them is code editing, and the other is rich text editing, right? Just a large document. We've added two different workloads. One of them basically takes a very large, one of them is in TipTap, and it basically takes a very large, complex document, and it changes some of the layout on that document. The other uses Code Mirror. It takes a whole bunch of code, and it changes some syntax highlighting options. And that way, we hope to provide decent coverage for all the internals of that, what these editor libraries might be using, right? Finally, there's still that little challenge that is always hard for a benchmark, especially if you not using any tooling with the browser, and that is static pages. We considered the user journey of accessing a news site and switching between pages on that site, right? And it's not obvious how we can measure that in something that runs in a tab. And so we couldn't really do page load. So we used have implemented a news website in both Next.js and Nuxt.js. And we kind of found out that way, if we use a little bit of clever trickery, we can get something that is very, very close to what actually happens when a page is loading inside the browser. And so this is kind of our attempt to have some coverage of actually static page loads inside the benchmark. And with that, we get to the list. I'm not going to mention all of them again. Feel free to look at the repository. Remember, all of this is open source. But yeah, these are all the workloads in a new benchmark. And please remember that this is not final. When we are iterating, we're not just looking to update. We are looking to expand. We are looking at ideas as to how to expand our methodologies such that we can still run inside a tab, but actually measure more types of things. As I said, the benchmark is open source. You're all welcome to contribute and provide ideas and tell us what we've gotten wrong or what we could do better. But finally, I want to talk a little bit about our experiences using this benchmark to improve Firefox. So when we are improving Firefox, we do so using the Firefox profiler, right? And so if we look at this is kind of a view of the profile UI. And we've tried to do some things as we develop Speedometer 3 to actually make it more usable for browser developers to actually use it to optimize. And so one of the things we've done, if we've added these performance markers, and you can see them here, right? We've seen them before when I talked about the methodology. There's all these performance markers that tell us exactly when the workloads were running. And now we can use those performance markers to filter out the samples of the profile that are actually relevant to this particular workload. And that means that we can look at exactly what a benchmark is trying to measure. If we look here, we can see almost immediately when we do that, right? You can see that we filtered here. And now we can see that almost all of that time inside the workload is spent in this canvas event ring buffer thing, wait on read count or something like that. And so that is basically us just sitting there waiting for the canvas to actually render its content. Now that's kind of interesting. So you dive into that a little bit further, which we can do because of the filters. Yeah. And then we find out that if we look at the entire benchmark run for this particular test, which is the chart.js test for the record, 34% of our time is spent here for a total of 760 samples. And this is not some contrived benchmark, right? This wasn't us writing a benchmark for Canvas and flooding it with commands and then going, oh, look, we filled it up, right? This was running a real website, running a real framework, and doing a rendering of a plain chart. And we were hitting those limits, right? And so now we knew that we have a problem. And once we know we have a problem, we can go and spend some time on it. This profile was taken at the start of this year. And if you look carefully at the brown boxes here, They represent the measurements of the benchmark. Here is a profile that I took a couple of weeks ago. We can see that these boxes have shortened significantly. If we look at that particular function that we looked at before, we can see that it now has a total of 144 samples. And remember that before, those were 760. So the wall clock time of this particular function has reduced quite a bit. And on top of that, that 144 samples is an 80% reduction. But the total time, or the percentage of the time it took, went from 34 to 16%. So in that time, we apparently made lots of other stuff in this benchmark faster as well. So that's great news. And then let's look at what that means for our benchmark score. This is a plot of the score on speedometer 3 for Firefox builds starting in February this year to today, or a couple of weeks ago. If we look at this, we can see that there is a 40% increase to the score of the benchmark. And we can see that that comes from a couple of these large jumps in different places, which were, sort of big flaws or big ideas that we had based on profiling these workloads in the benchmark. And they were big improvements that we were able to make to the browser. And we can also see that in between those, there's a gradual upward slope, which represents all the other little things that we were able to do by getting teams to focus and look at these workloads. But of course, I've talked to you before about how we don't really want just optimizing for a benchmark score, right? Looking at a benchmark score is all well and good, but it doesn't really tell us whether users are having a better experience. And so we do want to look at real user monitoring. And so the first number I want to talk to you about is the time from receiving the first byte over the network, because we weren't really optimizing the network connections here, right? To the first contentful paint. I wish we could have used largest contentful paint. I do apologize, but I have been promised that largest contentful paint is coming to Firefox this week and will be in nightly. But we're going to have to do with first contentful paint for now, because that's what we've been tracking for the last year. And we see this. And if we look at this, this is the median, right? Be careful, this doesn't start at 0, obviously. We haven't made them instant yet. But it starts at roughly 255 milliseconds at the start of the year. And the median drops down to 215 milliseconds. That's a 50 millisecond improvement, or a 45 millisecond improvement to first contentful paint, right? To the first change that somebody sees when they're trying to load a new page. And that's a great result in itself already, right? You can see, by the way, that this is not just the web getting faster. I can see how that would be a tempting explanation, but if you look at these little areas here where the big movements take place, those are all when a Firefox release occurred, right? This is all data coming from release. Now, we did look a little bit about what did we make faster? How did that happen? And so another metric that we track is the time that we spent executing JavaScript code between a navigation start and the onload event, right? So this is basically the time that we spent, how fast we are able to execute the JavaScript on pages. And for this particular metric, we are going to look at the 95th percentile, because that represents those pages with the heaviest JavaScript, right? Those represent the pages that we are really need to make faster. And if we look at that number, we see something even cooler. When we look at that, we see that that was hovering around 1600 to 1650 milliseconds, 1.6 seconds of just running JavaScript. And today, it is hovering around 1250 to 1300 milliseconds. That means that we are spending 300 milliseconds less on at least 5% of all pages before the page load event. If you look at the median, you see improvements of up to 100 milliseconds, so half of pages have improved that much. And that's just how much we sped up JavaScript, right? So I want to think back to where I started this conversation. 1 second improvement to your site makes a 27% increase in conversion rate, or at least that's what the stats tell us. This is a 100 millisecond improvement or much more to 50% of the web. And that is the kind of thing where browsers can make a difference for you and your products. And finally, I want to talk about one more metric that is not page load related, and which is a little bit like IMP. It's a metric we measure and treasure, called key press present latency. It is the time between receiving a key press from the operating system and actually presenting the result of that key press onto the screen. So it's kind of like an IMP just for key presses, right? Again, I will be looking at the 95th percentile. The reason for that is simple. If you're typing on Google Docs, you expect most of your key presses to be pretty much instantaneous, right? It's not that interesting to look at the median for this. But the slowest ones are the disruptive ones. And so if we look at the 95th percentile, we see the following. We see that at the start of this year, that hovered sort of around 65 milliseconds. And a bunch of improvements came in here. And now it is sitting around 59 milliseconds. A 6 millisecond improvement might not seem like that much. But for the 95th percentile of key presses, 1 out of every 20 keys that you're pushing, it means that a lot more key presses are showing up instantaneously for users today. And these are not just results that we are seeing. Google and Apple have both reported that they've seen correlations between the benchmark scores in Speedometer 3 and their real user monitoring. Apple has mentioned that in CI, Speedometer 3 has caught a regression that none of their other tests had caught, and it prevented it from shipping to their users. And so I want to thank you for being here and for talking about web performance and thinking about how to make the web fast for everyone. We are very grateful for the effort that other browser vendors have spent making this a success. I believe that I've been able to convince you that we can build a benchmark that helps us make the web better. But that doesn't mean it's done. We need the benchmark to become even better, and we need the help of the web performance community to do that. We need to know the types of things you are doing, the types of things you are planning to do, and we need to ensure that the browsers are good at doing them. Speedometer 3 is likely to be released in the spring of 2024. We're not going to change the workloads there, but there is going to be a Speedometer 4. We all are already working on it. Remember that this is all open source. You can look at it. You can look at the developments that we're making. And I hope that you all have a little bit more of an understanding now of what we as browser vendors are doing to try and make all of your pages a little faster. Thank you. I think it's time for some Q&A.
Super stuff. Thank you, Baz. Do you want to perch on a stool here?
Yeah, sure.
Come and take a seat. Oh,
it's a little high for me.
I know it is a bit high, isn't it? Yeah, I'm trying not to sit here swinging my legs, and now that image has happened. So that was a mistake. Thanks so much. It's so fascinating to get a glimpse into this aspect of browser engineering. And you know, one of the first kind of questions that came in was about the biggest performance wins that maybe we've seen. You showed some interesting kind of stats there about some real gains that have been made. But can you think of, you know, what's the biggest performance win that, you know, you've had as a browser engineer?
In all of...
Yeah, sure. I mean, why not dance in the limelight for a second?
I think the biggest for me, like for me personally, but it's not something that anybody ever noticed. It was actually my own mistake. I had left code in that meant we double buffered something that didn't need to be double buffered. And I fixed it, and it didn't really make things faster, but it prevented this extra copy, right? That was fast, but it used a lot of energy. And I ended up using a combination of telemetry and knowledge of electricity production to calculate how much energy the planet had wasted with that extra copy over the last 6 years that I left that bug in.
Right.
And I cannot do anything anymore to make my carbon footprint any worse, to be honest.
That's, well,
But that was my favorite bug to fix. It was quite easy as well.
I love the answer of like, my best gain is fixing my biggest disaster. That's great. I mean, I think we can all relate to that in some aspect. But actually, that leads me onto another question I had, since you were talking about performance gains that we've seen in terms of speed and efficiency. And I was wondering, are measurements being made specifically about energy consumption as well? Or, I mean, can we just correlate the two, so it's faster so it uses less energy? Or I'm just wondering about the specifics of that, because it feels like a really important topic as we use the web more and more.
It is really important, right? I think that as far as we publicly know, and the people from Google can disagree with me if they should do so publicly if I'm wrong. But I think that Microsoft has been the party that has historically done the most measurements on this that have been made public. We do try to do some measurements, but they're not automated. I'm not sure what Google is doing at the moment. So we're not really measuring that. But we do believe that the amount of CPU cycles that you use is a pretty good proxy. And we do use those as a proxy in our real user monitoring as well, actually looking at, so not at the speed, right, but the actual cycles in total that you used.
Right.
And that's complicated, because if you're using multiple cores at the same time, you might be using, in total, slightly more cycles, but you could still be more energy efficient if it means that that particular execution unit can be powered down more quickly, right? So it's a very tricky domain. We could definitely be doing better, I think.
It feels like a...
But speedometer doesn't really take it into account, right?
Sure.
Also, because we can't even. One of the problems is that if you get any idle time in the benchmark, the CPU starts throttling down. And so if you would leave idle time, you could become faster, have more idle time, and get a lower score. Because by the time you get to the next workload, the CPU has throttled down more, and so it needs to throttle back up.
Yeah.
And that goes directly against the idea of a higher score means a better performance.
God, it turns out this stuff's complicated. Who knew? Who knew? So it's almost like, it is a bit of a double-edged sword, isn't it? The fact that devices are getting more powerful. We're putting more and more effort into, making them more efficient and being able to crunch more data and be faster with the CPU and GPUs, exactly. As the tools that we as developers get access to get richer, and we have, you showed like frameworks and meta frameworks being used as well. I wonder, to what extent, as we see some of those libraries and frameworks get very popular, does that dictate or lead browser engineering to kind of cater specifically for those over and above, or as well as the platform itself? And is that a good or a bad thing? I wonder what's leading what.
I think that the reality is that frameworks are largely leading the browsers. I know that Google has at least some context with the React team. We don't. Like, we just need to make fast whatever the web throws at us, right? We don't. Right now, we don't have those connections. So I think they're leading to some extent. I think that it's going to be hard to make power usage improvements specifically geared towards, the way that frameworks use the web. I think something that lots of speakers here have mentioned is do less things with SPAs. The last talk obviously talked about that a little bit, is going to have a significant impact on your energy consumption, which may not help you directly, but it's going to help the planet, so it's still going to help all of us.
Yeah. And there were some questions as well about, how atomic and how specific some of the things are that get benchmarked in speedometer, such as, do you go down to the level of, well, how quickly can we render image, like an image or a video?
No, we very explicitly don't do that, because you get that risk of overfitting for one specific thing that you decide to measure. So when for example, if we take the to-do MVC benchmark, right, we add an item to the list, and then we just measure how long all of it takes. Adding it to the tree, whatever frame we do, the hydration, all of that. It's just one big measurement, and we try to capture it all using that synchronous and asynchronous block.
Got you.
And if we look at something more like the editor workload, right? I think what we do is we bold a whole bunch of the text or something along those lines.
Okay.
But we do that, and we measure the whole thing. We try to measure the painting of that. We try to measure all the updates. That means storing it, all that stuff, right? So we're very explicitly not
Understood.
trying to do those kind of
Okay, and my
atomic
very final question. You mentioned about Speedometer 3 being open source. What's the best way that people can contribute to this or help? Is it in defining some of these scenarios and workloads or something else?
I think there's a number of things. I think contributing user journeys that you believe are really important on the web and that we are not currently testing would be a good one. I think telling us if we're, like, we develop these applications, but we're not really web application engineers generally, right? We come at it from a very different perspective. If we've made mistakes in terms of the best practices that we believe we've applied, that's really useful feedback. But we also have room in the repository for experimental workloads. So if people want to contribute a full workload, like a full application with a workload, that's fine. And there's an experimental branch that this can go on. It's not guaranteed that it gets into the benchmark, but it makes it easier for browser vendors to measure. And in the long run, who knows, it might make for a workload that actually gets benchmarked.
Excellent.
And into the score. Right?
Valuable contributions all around. Thank you so much for a wonderful talk. I think you're going to make yourself available up at the speaker table around sometime during the lunch break. So if you didn't get some of your questions asked and answered, then you can certainly go and find Baz during the lunch break. But for now, thanks again for a wonderful talk. Everyone, a giant round of applause, please, for Baz Schouten. Thanks, Baz. Okay, so we'll do that thing that happens at conferences where we do the laptop shuffle, which is not a dance, and I will not dance, in case... No one's asking for that. That's fine. So I'm going to invite Nishu to come and get plugged in while I talk to you for just a second. So we have Nishu's talk, and then we will have a lunch break. And that is food is served upstairs where you had the refreshments earlier on. So you can find food up there. And there is also Sentry, I mentioned, who have a booth upstairs, along with Google, who are doing all kinds of troubleshooting and answering your questions at their booth also. But now, in just a moment, we'll be able to get Nishu talking. We're really excited that we have Nishu Goel here with us today, who's got a history in developing things with the likes of IBM and Web Data Works, now at ePilot, and has worked on all manner of different types of tooling and crunching through data and working on optimizations. Now working on various micro front-end implementations at ePilot. Also is the author of Angular Routing, so a book on Angular there, and has worked with all kinds of different technologies and frameworks and has lots of different insights as a result. She's written interesting things on long tasks and executing long tasks and how we measure those and optimize for that. And that indeed is going to be the subject of this talk, breaking down long tasks. So how are we looking? Are you plugged in and happy? We've got the thumbs up, folks. Okay, please now another giant round of applause for Nishu Goel.
All right. Hey, everyone. How are we doing? Good. Great day, right, so far? By the way, great job, Baz. He's in there, but yeah, I think he's listening. All right. So I'm going to be talking about breaking down long tasks. How many of you have heard of long tasks? Actually, let me rephrase. Has everyone heard of long tasks here? Because this is perf now, right? Almost all of you. All right. So how many of you have experienced this behavior? When you click on something, or your users click on something, and it doesn't respond, or it takes some time, and then you click again because, come on, you want to get your work done. Happens, right? All the time. And this is kind of that interaction delay that the user faces, which makes them click again, right? And then it happens again and again. Now, this is where the browser is actually trying to, there's this visual feedback that's trying to come in, right? And the browser wants to bring a frame that paints it, right? The browser wants to paint it in the form of a frame. Now, the time that the browser takes to paint that frame is where interaction to next paint comes into picture. That's what INP was about, which all of you have heard of, by the way. So that's what INP is. It's a page's ability to assess how the page is doing in terms of stuttering, the jankiness on the page, and so on. Now, this is also a pending Core Web Vital, which becomes official and replaces FID, which is first input delay, in March 2024. So you'd ask me, why does it need to replace FID? I mean, it should be different, right? So anyone wants to answer that? Why would it replace FID? Because FID is rubbish. No, let's not say that. OK, so the idea is FID only measures the first interaction of the page. And 90% of a user's time is spent after the page loads, the first load. So you want to do the interactions, or you want to measure the interactions, if you want to get it right, when the page has done loading, right? And that happens with INP. INP measures not just the first interaction, but every interaction after that. And then it gives you that worst interaction value, which is where all the interactions are going bad. So according to Web, OK, let's do it again. No, go back. Yeah. According to Web Almanac of the year 2022, INP does like this. So in the first 50%, it's doing good. 55% of websites have actually a good INP. What do I mean when I say good INP? So there's this range. A good INP is usually below 200 milliseconds or at 200 milliseconds. And anything above 500 milliseconds, it's a bad INP value. And anything in between is a needs improvement situation. So looks like at P75, 36% of websites are not doing well. And with FID, the situation was completely different. I mean, I usually say that I used to be happy when FID was there, because there was at least one metric that used to give me that positive feeling that my website is doing good. But OK, let's face reality. So yeah, INP helps in that sense. Now, we have INP, good. We get that value, good. We have that interaction value that tells us that, OK, this is not doing great, and maybe you want to improve here. Let's try again. Yeah. So it gives you that value. It gives you that worst interaction situation, but it doesn't tell you what caused it. And now, if you're getting a bad value, you'd want to know right away, what is it? What's causing it? I mean, I did everything right. I'm the best developer, and so on, right? But what if the INP situation could also give you that this particular thing that you're doing in the code maybe isn't that right, and maybe can be refactored or improved performance-wise to just ensure that it's a good INP finally. Now, to do that, we have to do some work. We have to find some slow interactions on the app, right? We have to do that maybe from users' perspective. We could also do that in the lab data, in our setup where we just check on our local, for example, that what's going wrong and so on. But if you do it on your laptop, it's not going to be that close to the user's experience. Like, I have a Mac M2, and my user probably has a Windows machine, right? And the gap over there is crazy. So the best bet in this case would be to just go in and try to measure it from the field data. So how would you measure it from there? There's different ways you can do that. You could just go to page speed. That's the first thing that we do. We go to page speed. We try to measure, you put in your URL over there, and you try to measure how the app is doing, how the website is doing, and how do the scores look. But now, that's going to be very high level. It's going to give you origin-level info, but it doesn't tell you page-wise, right? It doesn't tell you how this page was doing for this interaction, and so on. And it's good that it gave you a glimpse of what might be wrong. It might have given you an idea that, OK, maybe the main thread is too much blocked. Maybe there's some script that's taking too much time. But it still doesn't tell you that this part of your code is causing it. And the best situation is when I know that, OK, I wrote this line of code, and maybe that's not too performant, and so on. So we get that glimpse from the first point, which is page speed using the crux data. But what else? What if I use my own RUM provider, right? people use different run providers. We use Datadog at work, and that already does tell us the INP value. It's a chart, which would tell that, OK, this is how INP is doing. Again, needs improvement situation, but does it tell me which part of code is causing it? Still no. So then we come to my favorite part, which is the Web Vitals JavaScript library. And that comes with some information that could actually benefit you and let you know that this particular thing might be the reason that the INP is really slow. This particular thing is the event or the element target that's causing it when you click on it, and so on. So let's get more into that. We want to record something. Now we know. We have the INP value, but we also want something else along with it. What do we need? So we need to understand what really do we want to record, right? And that's when we understand that, OK, INP value, first thing, I had it from the other sources as well. In this also, I'd want to know what's the INP value. What else? I want to know what's the responsible element target, right? I want to know that I clicked on this button, and that's when INP went wrong. Right? That's when something happened that the performance just degraded somehow, or it just took forever to load, and we didn't give any visual feedback to the user, and the user kept on waiting, and so on. So I definitely want to know what's the element target on which INP is going wrong. What was the loading state of the, of the document when your interaction was being recorded, the INP was being recorded? So at that time, you want to know the loading state as well. Is it still loading? Maybe that's why there's long delays, because when the first load is still happening or the document is still loading, it could get slow. So you want to not bias the situation and know the real picture. So you would always want to record the loading state of the document at the interaction time as well. What about the interaction start time? It's always a good idea to know what's the when did you start the interaction, because for example, you're recording like a small profile, and it's a click on a button, it's scrolling through the app, and so on. Now, you don't know when was the INP recorded. Was it during the scrolling, or was it during the button click? So if you know that for this element target, that's like a click on the button, and this was the interaction start time, you would have a real picture of what really is happening, and this is exactly when things went wrong, and so on. Now, what about the event type? You would definitely want to know if it's a key press event, did you tap somewhere, or is it a click somewhere, and so on. We didn't also discuss what does INP cover in terms of interactions, right? So it could be a tap event, it could be click, or it could be any keyboard events from, the remote keyboard or the physical one. I think that's kind of understood, right? Yeah. Now we know we want to record this information. And looks like the Web Vitals JavaScript library is going to help us with that. So let's look at that. OK. No. Yeah, good. OK. Yeah, this is going to be a struggle. But yeah. So we noticed that we had this other way of also recording INP or any core Web Vital. In this case, it's Datadog. This is what we use at work, again. And I recorded the INP for our own website, what Datadog recorded. And it falls somewhere here. So it needs improvement in a way. And this is how it would look on your provider or anywhere. But now, again, in this in this graph, it does tell me that this is the INP situation, but it's not telling me that this particular thing caused it. So I would still want to go to my favorite part, which is the Web Vitals library that causes it. So, OK. Sorry. Yeah. A bit laggy, but it's OK. OK, so yeah, great INP value. I mean, not great INP value because it's in the needs improvement situation. But we don't know what's causing it. So let's move to the next part again. I think I'm going to just use this instead. Would be much better. Yeah, so we are recording now using the Web Vitals JavaScript library. Now, I say that we need the attribution build. Does anyone want to answer why we would need the attribution build? To make the bundle larger. OK, OK, good one. What else? OK, yeah. So the idea of using the attribution bundle is exactly because we want more information from it, right? We don't want only the INP value, but the diagnostic information as well. So if you import it like this from the attribution build, it would cause some problems in the sense that it makes the bundle larger, but it's only 600 bytes. So you're adding something here, but it might end up helping you in so many other places by actually letting you know that these are all the places where your INP is going wrong, and this is where you could fix it. So the build is 600 bytes larger, sure. The build is broadly compressed. I mean, if that makes the statement better, that it's making the application larger. So you could import it from there, and then it comes with some information that would really help you then. So this was how the INP metric looked earlier, and then you add that extra value with the attribution build, which is that attribution property, and that includes all of these fields that you might be interested in. It involves the event target, right, which was what one of the things that we wanted to record in the things to record. Then it includes the event time. It includes the type of the event, again, the tap and key press and so on. It also includes event entry. We'll look more into what event entry is. And then the load state. Loading state, again, is the situation where you want to see if the document is still loading while the INP was recorded, or is it already loaded, and so on. So what is event entry? Yeah, it was moved. So these are the values that you can get from the event entry. It could be different timings, like the startup time, the load state. Load state was already there outside the event entry. Processing start, processing end, and so on. So this is all the durations that you might need to have a proper understanding of how INP was recorded, when was it recorded, and so on. And then you could just send this information to your analytics tool or something. You could just log it, but it's always a better idea to just send it to your analytics tool. So you just record it from there. You can maybe visualize it later and then see the final picture of how INP is doing on your application in the field. This is not lab data, right? Because now you're getting it really from the users. So once you do that, can I just click over here? Yeah. What could go wrong? What could happen with INP recording? What if the INP value is not there at all? Is that possible? Or the event target is not there at all? That's kind of possible, right? So what if I use micro frontends at work, and there's a lot of detaching of nodes and attaching of nodes all the time. So it could very much happen that when the INP was recorded and we were trying to capture the event target, it was null, right? Because it was maybe detached from DOM, or maybe you were using shadow DOM, so it doesn't even capture from inside shadow DOM, and so on. And in those cases, the event target value would be empty, but we know why it would be now, right? So now we have the field data, we have INP value, we also have diagnostic information with it, but what next? What do we do next? We got it from the field. Now we have to reproduce it somehow on our end, right? We have to somehow try to fix it. So that would be next. Yeah, that would be next. How do we reproduce and fix it? So to do that, we found slow interactions on the app somehow, but that's when comes testing in the lab, right? You want to see and you want to reproduce it. However, if you were like me, you'd just say, let's go to the performance profiler. But you know how overwhelming it can get sometimes, how intimidating it can get sometimes. And maybe let's try something low effort. Let's try something that doesn't lead us directly to the performance profiler, and then we have to see those long tasks and huge, so many tabs and so on. So there's this Web Vitals Chrome extension that you could use, and it would look something like this. So you'd have to enable logging, and then it would give you some information like this, which tells you that, OK, this is the INP value or situation, that it looks good, it looks bad, and so on. And these are the different interactions happening over there. Let's actually try to enable logging from the browser. Not sure how many of you have done that before, but it would be a good small activity. So there's this dummy application, or dummy page on the application, wherein let me know if I need to zoom the DevTools a bit. Would be good? Let's do it. OK. Yeah. So now, first, let's just close it. Yeah, I'm going to reload the page. And I have this Web Vitals Chrome extension already enabled here. You could just download it, install it. And then there's this settings icon over here, where you could enable console logging, and then you save your options. Also, if you're interested in any other options, that. And then, now let's close this tab. Let's open the DevTools. And I expect that I see all that information in the console now. So let's interact with something. I've already filtered for INP, by the way, in the console. So I'm only getting that information. But let's get rid of that for once. So you would see I'm getting everything from Web Vitals extension, the interaction time and INP time. There should also be other core Web Vitals, CLS, LCP, CLS, and so on. Yeah, so let's filter for INP in this case, and let's interact with something. Yeah, so it tells me that, OK, this is the INP situation. And now if I zoom this, it tells me the event target element that could be causing it. It gives me some things that are happening. The input delay took 1 millisecond, for example. The processing time was the most time-taking thing, 81 milliseconds. I mean, the INP is still good, but I could question why is the processing time, in this case, 81 milliseconds. I just clicked on a small selector. And then the presentation delay, and so on. So these are the information that could really help you to understand what's going wrong in this case, right? What's going wrong to measure INP or just with your application in general. Now, let's go back to the slides. So it's going to be here. Yeah, we already saw this. But now, we use an extension now, right? What if we cannot use that extension? Or what if you want to simulate the experience on a mobile phone, right? You can get the dev tools. You'll have to connect it to your machine. But yeah, what if you're doing it on an incognito browser? So there's this piece of code. It was a small detail. There's this piece of code which does exactly what the extension was doing. So yeah, just use that in the console, and that would give you exactly the same logging, which would, yeah, it might not be much visible, but you know what it was showing. It would give you the element target again. It would give you all those timings that you need, and so on. So yeah, it also solves that problem of trying it on cognito machines or browsers or just some other machines. Now, at this point, you would say that, OK, I also tried to get it from the lab data, right? I also tried to get it from the console. It still doesn't clarify what exactly it is. That's when you'd finally go to the performance profiler. Let's do it. So you go to the performance profiler, and OK, intimidating, right? Yeah. So I see that there's some little red triangles on the top right, which we now, I guess, at perf now know that this is a long task, right? And this long task could be caused due to anything. At this point, I'd question, is it is it some third-party script that's bloating the main thread a lot, and that's why the main thread is busy? Is it some expensive event callbacks that are causing it? What is it? So at this point, to understand that, let's see, first of all, one example of a task, right? So this looks like a blocking task. It's taking more than 50 milliseconds. What exactly is a long task according to you, by the way? Something that takes longer than it should, right? There could be some expensive tasks. They have to do the job that they are doing. But there's something wrong if they're taking more than it should need. 50 milliseconds for a task. What if you could break down a task into smaller tasks? What if there was one activity that one task was doing, and the same part in the same method was done into another task? That would not block the main thread. That would at least allow the browser the space, or the main thread the space, to understand that, OK, this task looks like I can do it first, but it needs to prioritize those. It's just that we have a little more room now to play around with those chunks of tasks instead of this one long task that you see here. And that's where you would see that, OK, you would think that, how do I tell the browser how to prioritize a task, and so on? So we already discussed this, right? It could be expensive event callbacks. It could be an input delay, and so on. The clicker is working now. So yeah, how do you tell the main thread that there could be something prior? Scheduler.yield. So you would want to yield to the main thread. What does yielding to the main thread mean? You want to let the main thread know that there's something more urgent. Do that for now, and then continue with what you were doing. So the yield API would do exactly that. There could be your own yield method, which just uses a set timeout, right? That maybe has a promise that resolves on doing that set timeout. And that simply puts the action into a different task. And then the browser has the ability to prioritize it, and so on. Now, this is in origin trials right now. You can access it from there. Good idea to just access it, try and give the feedback to the team. But yeah, that's what scheduler.yield does. We'll talk more about it in the latter parts of the talk. But how does React do it? Because you'd ask me that I don't want to use that vanilla stuff, right? I just want to do what I do in React. So start transition API actually allows you to do that. Now, there's a difference in the understanding. With yielding to the main thread, we were telling it that there's something more important. React does it a bit differently. It classifies urgent and non-urgent tasks. Everything is urgent by default, by the way. But if you want to say that something is non-urgent and can be dealt with later on, you would just wrap it in a start transition API. They also have this use transition hook, I think, that does the same thing, and which basically exposes the start transition API. And then you could just use that to wrap a method inside that start transition, and then that kind of becomes non-urgent. That can be dealt with later on. How does React do it? It gives back the control to the browser every 5 milliseconds, so that the browser knows that it has something to do. Yeah, so that's how React does it. Now, this was the input delay part. This was the expensive event callbacks that we were dealing with. But what if it's the rendering part, that takes most of the time? What if big DOM size? I think most of our applications have this problem, right? We have bigger DOMs. We have so many elements. I think it's the framework industry that made us do that, ultimately. But yeah, so that's also called the presentation delay, right? And your applications could look like this. I mean, I regret saying that, but mine looks like this, kind of. So yeah, this could be so many divs, and this is all of this tree situation. And that's what leads to style recalculation. I'm not sure if you noticed earlier in one of the screenshots that I shared from the DevTools, the profiling section, where it said recalculate style, right? And that's one of the most common issues in the profilings that we do. At least in most of my profilings that I do, I always see recalculation of style. And that's because the styles have to travel up the tree, and the tree is so big. What could you do to help this situation? We already use fragments, right? So that's one way to solve it. But the idea is to just keep it simple, just keep it small, do as little work as possible. Yeah, so style recalculation could be kind of fixed by having a smaller DOM tree. What else? Forced reflows. OK, clicker. Yeah, so there could be complex CSS in your application as well. And now imagine doing this with a simple CSS. The browser would have to do a lot less work. But in this case, the browser has to understand and find in the DOM tree which one is the element which has this class, the .title class, and which has a parent of this particular class with that particular child, and so on. Now, this is where the browser could also take so much time, because it has to do all of those calculations. And the idea would be to keep the CSS maybe simple, not that complex, for the browser to avoid having to do that much work. So that's going to be forced reflows, and that's going to help in your presentation delay if you try to avoid something like that. Yeah, so this was the long task situation, what we looked at. Now, what are the problems with long tasks in general? Has anyone already tried to use long tasks and saw that it was not that helpful because it was not really giving you the right picture? Happens, right? So it tells you that a long task has happened in the, and it took this long, but it doesn't tell you, again, that what really caused it. It's that, high-level event container that might have caused it. But again, it doesn't tell you that this particular function or script was the one that caused that long task. Also, it doesn't count that rendering update, that presentation delay later on. So it happens in a different task, and it's not included in the main long task measurement. So again, it's kind of not close to what you would want to have. And already, because there was feedbacks from schedule, the origin trials and so on, there was an improvement on this while we were still understanding what long tasks are, and that's long animation frames. So that kind of does the same thing. It has the same threshold of 50 milliseconds, but there's one difference. It doesn't measure tasks. It measures frames, and that could include so many tasks in themselves. And now the idea is to measure frames instead of tasks, right? And that frame could include one whole activity in itself. It would also tell you that this particular thing was in that frame caused that delay or something. And how does it do that? It has a better attribution way of doing it. So it tells you exactly the properties that might be causing it. It tells you the name. It tells you the type of the event, so that's quite helpful, right? It would tell you which event type it is. It would tell you all the kind of timing data that you might need. Start timing, and how long it took, when it ended, and so on. And then the window attribution, which is like not the up-level window container, but exactly what might have, where it might have happened. So that's better in terms of understanding what might have caused the long task, or let's say long animation frame in this case. And how do you enable that? So you might have done that before, right? Experimental web platform features. So you just enable that to be able to access the API, which is the long animation frame API. And again, this is in origin trials right now. I was looking at how to pronounce this. Is it loaf? Loaf? It was written on the blog, but I couldn't figure that out. Loaf. Let's see what the Google team has to say. But yeah, so you could enable it on the origin trial and explore it again. So it would be a good idea. There's already one good case study from Rumvision, I guess. Actually, the team of Erwin. They tried it, and they used the long animation frame API. They could figure out some third-party script that was causing the slowness for them, and they could actually figure that out. So they tried to, they went to the application that was causing it, and then I think it was Moment.js eventually, but the team can tell you more. But yeah, so it's been helping people already. They are recording it. They're trying to find what's that script causing it, or what's that piece of code that's causing that slowness. So yeah, that's how you would enable origin. I mean, this is how you can enable origin trials. And the result could look something like this. So this is definitely more information as compared to what you'd get from the long tasks API. And so it fits everyone's separate use case. You decide what to do with what information. I think I would use the element target and the timings a lot. But yeah, let's give feedbacks according to how it helps. So we saw earlier the scheduler.yield method, right, which allows you to yield to the main thread, which lets you let the browser know that, OK, this is where you prioritize something else, and so on. But there's different strategies. You're telling the browser that, OK, prioritize at this point. But do you even know when to prioritize? I don't know. I don't know that at this point of code, piece of code, I want to say that, OK, browser, just prioritize it. Not that simple, right? So this was the main method that I was talking about. If you don't have the scheduler.yield API, you could just do something like this, and then it would put that task in a separate thread, in a separate task, and then prioritize it if you want to. But it just chunked the task. It just made that long task into 2 smaller tasks now. So the other way is scheduler.yield API again. The problem with the previous way was that if you're prioritizing something, you would expect that this is prioritized, but everything should be continued the same way, right? The priority should be the same as it was. But that's kind of not what happens. What if there's another event source, right? What if there's another click from the user that happens? Would the browser prioritize that, or the things that were already in the queue? So the problem is, with this particular thing, with this set timeout way of yielding to the main thread, it pushes everything to the end of the queue. And that's taken care of at the end, when the main thread is completely idle, maybe. Anything that comes in between is tackled first. And that could lead to inconsistencies, right? You wanted to deprioritize some stuff, but not maybe towards the end of the queue. That's kind of not what you would want to give the user the experience of. So scheduler.yield API tries to do that. We already looked at that. It tries to combine both of those, which is also being able to defer, right? Also being able to yield to the main thread, not defer, but yield to the main thread, but also at the same time, keep everything in the same priority as it was. If something was before in the queue, it should still be before, and then anything that comes after that should be tackled afterwards. So that's scheduler.yield way of doing it. But you'd ask me, what if I could just prioritize them? What if I could just say that this task seems more important, but this one can be tackled after this, when the main thread is a bit free. And the last one should happen completely in the background. I don't care. It's completely an asynchronous way of doing it. Whenever you have time, do it. I don't care. It's not going to be visible to the user, and so on. So there's actually priorities that come with it. This is, by the way, just a screenshot of the scheduler.yield origin trials, if you want to apply for those. So scheduler.postTask API allows you those priorities. And it would tell you that, OK, you want to prioritize something for the background, which is like the least important, you just give it the priority background, and then it would just do that in the background. What would be the most important? User blocking, right? Anything that the user is waiting for. It might not be a successful acknowledgement that, OK, whatever you were trying to do by the click of that button is done, but it can be some visual feedback. You maybe want to just show a spinner, right? You maybe just want to say that, OK, this task has been aligned or queued or whatever, but we are working on it. You don't have to click twice or thrice and so on, right? So you're giving some visual feedback to the user. And this is how the priorities would work. So user blocking blocks the user, so that's the first most thing. User visible has to happen, but it doesn't have to go to the end of the queue, but still, do it after the user blocking tasks. And then there's background, which can happen anytime, and you don't, really care about that. Now, again, this involves more work from me. I have to say that, OK, this is when prioritize it like this is when prioritize it like that, and so on. What if you could just tell the browser, do it when you think that the user needs some feedback, right? Do it when you think that the user is waiting for an input. And that's what is input pending API does. So this was from Facebook and Google that they introduced this API, navigator.scheduling.isInputPending. And the idea is exactly that. So you would only prioritize, or you would only yield when the user is actually waiting for an input. So it would return a Boolean value saying true. Now the user is waiting for an input, right? And the way it works is, I think it looks for an interaction within a frame of time. And if there has been no response to that interaction, that's when it would say, yeah, that the input is pending. And that's when you would want to yield. So that kind of takes some task away from you. You don't have to decide what's more important, what's less important, but the user kind of decides for themselves, right? If you see that the user was waiting for something, or if the browser sees that the user was waiting for something, the browser decides to prioritize that particular task, because that seems more user visible or blocking. This is kind of the way it does that. So if the is pending value returns true, right? Or because it's not available in all the browsers, there's a hack also to do that, which is you just, OK, that's kind of cut. But yeah, you could calculate the performance right now and then subtract the performance from the 50 milliseconds from it. I guess it's 50 milliseconds, the threshold. Yeah, and then you would do a set timeout, which would then put it in a separate task and then yield to the main thread. So that's the is input pending way of doing it. Now, yeah, let's go to the recap. So we looked at how, first of all, INPs work, right? INP works. We saw how it could you could yield to the main thread. We saw how it gives good attribution now, right? You could also diagnose some information. It's not just one INP value. It leads you to measure field data, right? It gives you the ability to measure field data using the Web Vitals JavaScript library. You could then use the lab tools to kind of try to reproduce it first without the profiler, and then maybe with the profiler if that was not that helpful. You now know what could be the different delays in the browser, right? You can maybe read the long tasks a little bit, or the long animation frames now a little bit. And then finally, we talked about the strategies to kind of let the main thread know that maybe prioritize it, maybe deprioritize it, and so on. So yeah, that's basically it. And that's how long tasks kind of work. I would, in the end, just thank you.
Awesome stuff. Thank you so much. Come and join me on these ludicrously tall stools. That's fine.
Let's try to sit. OK.
OK, we made it. We made it. Thanks for such an interesting talk. It's so fascinating to see some of these tools that I personally don't spend so much time in, as many as so many of the people around the room, I think, do themselves. I'm curious about the type of events. You're talking about interaction events, and you did mention like a bunch of different types of events. Do they have much impact on the measurements you get out of there? I mean, so for instance, do we see different characteristics for coming from events that are triggered by click versus tap versus drag versus? I mean, I guess lots of these events are kind of compound kind of things anyway. But do we need to take that very much into consideration, or is it purely as simple as something is an initiated something, and then we start measuring?
Yeah, that's a good question. I didn't think of it this way. So you're saying, for example, if the user tabbed, is that more expensive than if the user would have pressed a key on a keyboard? Or
Yeah, exactly that
Yeah.
kind of thing. Because I think there are, if I recall correctly, I know there are particular characteristics of what constitutes a tap versus
Yeah.
a press or what have you. I'm a bit ignorant of this part of the world.
Yeah, I think the way I would think of it is that what really is the work that you're doing on that tab, right?
Right.
If that tab is making you do a call to the backend, get some data, also render it, and then also give the feedback to the user, that tab is going to take some time, right? But if a key press, for example, is just showing a snack bar saying that, OK, this is done, then it's going to be quicker. So I guess it might not depend on how a tap or a key press event would differentiate in terms of how much more expensive what is. But yeah, I really think it just depends on what task you're doing behind the hood.
The actual work that's happening,
Yeah.
which I guess is what the point is in the first place.
Yeah.
You also mentioned a little bit about breaking longer tasks down into shorter tasks, and I kind of imagine that there are implications for like the perceived performance if you do that as well. If you're breaking down longer tasks and then, I don't know, gradually displaying things to the user over time or what have you. But if lots of tasks are associated with one particular action, are there ways that we can break a longer task down into shorter tasks, but then still associate those or can visualize those together? Is that purely down into the job of the tools that are visualizing these bits of data in the first place, or is there anything we can do to help us with that?
Yeah, I think that's why it really depends where you're using this yielding to the main thread, right? Because there can be tasks where you cannot give a feedback before the task is done, right? You cannot say that, OK, I've done something for you. It's happening in the background. No, the user's not looking for that fake feedback. So I guess it really depends, again, on the task that you're doing. For something that can get a visual feedback, like send to the queue, then it's going to show you a loader. That's good enough. I've gotten some feedback, and rest of the stuff is happening. But for something that I click on, for example, a table, and I want to load an entity based on that, and if I see some feedback that, OK, we are loading your entity, maybe that's not that promising, because you want to see the entity right away. So the way you perceive it would really depend on if the deferred task is kind of making sense also to the user.
Yeah.
It's not just because you want to give some visual feedback. It's also because it makes sense in that place to give that visual feedback, but not just to share something with the user.
Sure. Yeah. I also had a question. Maybe this is unfair because maybe this is more of a human thing than a technical thing. But was just thinking about when is the best time to be doing this kind of testing and monitoring. I mean, you showed really nicely how you can be using different mobile devices and also how you can be gathering data from real users. I wonder. Sometimes it feels like we measure things while we're doing it, right? So as we're building something in a development environment, and you also kind of called out the capabilities of your development machine over there versus the things that we have out in the real world. Do you think it's as valuable to be testing these things and trying to optimize during development, or should we simply wait until it's out in the wild? And do we even ever get a chance to revisit it then?
Yeah, that's a good question. We've been thinking a lot about that at our work as well, because it's difficult to make every developer performance mindset, because they don't want to. They just want to push something. They just want to have that feature up live. So we've been thinking of several ways of doing it. So every time a feature goes up live, right, you deploy it. There should be we were thinking at work that maybe there's a pipeline that kind of blocks, and we already have this channel which is called alerts performance, and that tells us every time a long task went beyond.
Nice.
It became a long task, basically. So it tells us that for anything that's every time a feature is pushed. So that's one time that you would want to do it. You don't want to do it actively when you're developing, but maybe finally when the feature is up there, and maybe in a canary situation or something where you are now measuring how the performance seems. Has it degraded after that new feature? Did you use something that might have brought it down? So I would say that's maybe one place or situation, that's where you'd want to do that. I still find it really difficult to make everyone performance mindset. It's so difficult even at our work. There's this two people who are always focusing on performance, but then rest of the people are like, okay, let me just push the feature. So
Yeah, I love the idea of being alerted to these things that are happening out in the real world when some of these signals are detected. And talking as well about how we visualize some of these things and report them. There was a question that Stuart asked about Google Analytics. And I don't know if you know this or not, but he was wondering if there are any tips about how to get Web Vitals recorded in Google Analytics 4 now that I think some of these performance aspects have been removed from Google Analytics. Have you got any tips for how to get these things visualized there, or should we be talking to the folks from Google are around the room?
Yeah, I guess so. I've not used Google Analytics before, but the other example that I was showing using the Web Vitals library, which would give you a metric like on INP, right? And on that method, it would give you values like attribution, interaction ID, and so on, and that you could just send to Google Analytics. I don't know how to visualize it over there in Google Analytics. That maybe someone else can answer better. But yeah, we can definitely send that information.
Yeah, cool. And there was another question actually from where are we? From Aaron, who's talking because you had mentioned about the impact that the size of the DOM can have, and a few other aspects as well. And Aaron was wondering about CSS containment and whether or not the different aspects of or the approaches to encapsulating CSS could impact on there. Are you aware of big impacts that can have?
Yeah, I guess I've heard a lot from different people. We even tried it in one of our micro frontends. That CSS containment was really helping a lot with, just drilling, bringing down the INP, or just making it more performant. So you have to try different ways, but CSS containment in general is a really good idea, I guess. We have tried it at work. That helped us. People are using it as well to just bring down INP. So yeah, definitely a good idea to try CSS containment for that. Yeah.
And I guess really my final question is, can we not just keep some nice metrics that we can hit, that we get a nice green check mark from straight away, so that's just nice and easy? Because I think that will encourage us to pursue the other things as well. So at the very beginning, you were talking about, it's kind of nice to have some of these metrics. Yeah. I'm for that. Can we just not have some of that? Can we get that?
Yeah, I mean, as a developer, I'd just hack it from DevTools, make it green looking.
Just sending, it doesn't matter what the numbers are, send them back green. Brilliant, I love it. Okay, brilliant. Well, I think we should let you go. Thanks so much for answering the questions, and thanks for your wonderful talk. Please, everyone, a big round of applause.
Thank you very
Nishu
much.
Goel. Thanks, Nishu. Okay, well, as you might have started to hear and indeed smell, food is available. It is our lunch break now. So food is upstairs. I think the same housekeeping as you've already heard. If you do bring things back downstairs, paper, please. Use the cardboard cutlery and what have you. Cardboard cutlery. Good luck. Paper plates and cardboard cups. Also, just a quick notice. Storm Kieran. You may know that there is a storm coming in, and apparently Amsterdam. And the area is on code orange for wind and rain. This venue is going to be open until 9 p.m. tonight, but just be aware that you should probably check your travel situation if you have got a little way to go today. So just be aware of that. That might be something to be looking at. Okay, enough from me. See you back here at 5 to 2. We will start again at 5 to 2. See you in a bit. Thanks a lot. Right. Welcome back, everyone. Welcome back. I trust you had a good lunch, including people at home. Hope you managed to find something to eat. We've eaten well here. So we did at the beginning of the day invite you, encourage you to kind of adopt the Pac-Man rule and meet new people. Show of hands, has anyone had a conversation? Anyone made a new friend? Oh, how lovely. How lovely. You were very wise to put your hands up just for a second, because that way you didn't get around to look around and see if your new friend had their hand up or not, because that's awkward, isn't it? So I thought we'd made a bond. But that's great. I'm very happy to see that. Okay, before we get started with our afternoon programming, first of all, you may have found the job board, the job booth upstairs, just at the top of the stairs there, where you can post jobs if you're hiring, and you can find kind of those adverts for jobs as well. Pay a call up to there, kind of visit them later on if you're in the market. Okay, before we get going, we do have a quick word from Yoav. Yoav Weiss is going to quickly come and chat to us. Oh, there we are. Lovely. A special message from the W3C. Yoav, the stage is yours.
Thank you. Yeah. So, hi, I'm Yoav Weiss. I was very happy to see earlier today that Mark mocked my kid's artwork. That is very kind of him. So basically, I co-chair the Web Performance Working Group. One of my goals as a co-chair is to make sure that browser folks are always outnumbered by people who are actually using the APIs that we're working on in order to prevent us from doing silly things that are not very useful. And this is where y'all can come in. Essentially, browser behavior and browser APIs are something that you can influence and you can have agency on. So if you're interested in keeping tabs on the work that's happening and influence it, making sure that it is actually useful for your use cases, then the Web Perf Working Group will be happy to have you. And I will be at the help desk at the break after this session, so feel free to hop over and chat about this. Thanks.
Jolly good. Thank you, Yoav. Right. One more reminder before we get going. I've run up 2 stairs and I'm out of breath. Is that a good sign? Whew, maybe it's emotion. I'm just very excited about the day. One more reminder about questions. As you know, I get the chance to chat to our speakers just for a few moments on stage, and then of course you can chat yourselves up at the kind of the speaker table. I saw that was very busy earlier on. Lovely to see. But also you can submit questions over Twitter, Mastodon, using the hashtag, also via the form on the website. So do keep those questions coming in throughout the day and indeed tomorrow. Okay, with that out of the way, let's introduce Keerthana. Keerthana Krishnan is a software engineer working in Munich, based in Munich, and I'm really excited about this talk because I'm a big believer in we should choose the right tools for the right jobs, and it's not necessarily the same tool that works for every kind of project, and a diligent kind of choosing process is really important. But also, once you've chosen the tool, then using that right is also important. And you know, with some of the modern frameworks, we don't always hold them right, and sometimes they don't emit the best performance. So with a talk about optimizing your use of React, and I think many other things along the way to do with performance, are you ready to go? Let's do it. Please, a giant round of applause for Keerthana Krishnan.
Thank you, thank you. Thank you, Perf Now. Everybody looks happy. Thank God I got the slot after lunch. Nobody is cranky anymore, yes. So my name is Keerthana. I am from a place called Cochin in India, but currently I am based in Munich, in Germany. I am a software engineer working for a product called Yamdu. And a little bit about Yamdu. So what we do is, the easiest way to kind of say that is we are like Jira, but for a media project. So if you are going to direct the next Thor film, for example, you would want to use Yamdo to like maintain or manage kind of the planning that you have for it. So you can upload a script, and from the script you can say, okay, these are the locations that you want. Asgard might be difficult, but maybe Norway. And you have a few roles, you have a few characters, you have a few locations. And I'm just saying this because I will be using a couple of scenarios that we faced later on in this talk. So when you see Yamdo and when I say scenarios with some characters and roles, just it doesn't feel out of place. So that's kind of that, and that kind of real-world example is what I want to talk about with you today. Because I don't think, OK, so just to get a temperature of the room, how many people here have worked with React? Show of hands. Oh, that's a big crowd. How many people here are happy that they worked with React? OK, there are still some hands. I'm very happy to hear that. So some caveats before we start. Even though I do stress, again, that I do have some React-specific examples, I do believe that some of the concepts you can work with, no matter what framework that you have, but especially the examples, they will be React-specific. And I would like you to choose, or I would like you to focus more on the principles behind it. So I'll be deep diving into why some of these things are worse for React. So hopefully you can still get some takeaways from that. And just to set the agenda right, so I will be handling 3 things here. What do we use to manage the React performance, which is like the easiest answer. Everybody sitting here, I think you already know. Why is it important, and how can we improve it, right? So what do we use? Gimme, there's 3. What are the 3? Come on, you guys, you had lunch. What are the 3? We have LCP, we have FID, we have CLS. Those are the 3. I hope you guys know that. It would be really sad if people didn't know that by now. And specifically on LCP and FID, or INP now, Nishu already talked about that, so I do have a couple of slides, but I will be going a bit faster because that was the talk right before me, and you cannot forget it. And of course, why is that more important? Because compared to the lab-based stuff, you have more user data, so you have more, even if you have like your website. And I do hear it from my dev friends. I come from a very dev background, and they do have things that say, oh, no, we run it on Lighthouse, and it looks good, so why do I care? Because this has more user data. It's real-world user data, so these are kind of the metrics you should care about a little bit more. So everybody knows about Web Vitals now, but I would really like, I'm not sure how many people have seen this talk from Dan Shapir or read this article. So he did a very interesting study because, to be honest, Web Vitals are still quite new compared to the age range of the internet, right? The span of how long the internet is. These are quite new metrics. So when Dan did this kind of an analysis on after they were introduced, he noticed some really interesting kind of patterns spread across the different frameworks. Now, I'm not going to talk about all those patterns. I will be talking very specifically about how React behaves, but I would highly recommend that you go find this article. It's linked in my slides. Read it, and I don't want to spoil it. So across all of the websites, the percentage of the Web Vitals which show green, which means they have good performance, these are the numbers that they've shown for this particular time period that they studied. And very key things I would like you to notice. One is this is only for the United States. So compared to the global amount of data that you can collect for this kind of a metric, he very specifically focused on the deep set of the United States so that we wouldn't have kind of the variation in latency or network or the kind of things that could happen when different locations have that kind of a problem. So it's that one geographic area. And also the client is mobile. So across the spectrum, mobile is still the most highly used device, but we still have desktop. Very recently, I found gaming consoles. So a bunch of things in which people use the internet on. Mobile is still, by and large, the most populous. So here's how the data shakes off for everybody. And now, interestingly, when you pull it down to the top 1 million, which arguably, top 1 million means the top developers are working on it. So we expect an improvement in the statistics. And however, React is the only one. In the earlier slide, if you noticed, it used to be 36%. When you pull it down for 1 million, it goes down to 34%. And that 2% of a drop, when it comes to 1 million data points, is not a small drop. So when you poll it down to the top 1 million websites, why are React websites doing worse? Arguably, these are the websites that have more top-tier content or top-tier talent working on it, so we expect those metrics to get better. So just to present the other important conclusion, LCP scores actually do not vary much for React. They do remain quite same. And LCP is, to be honest, the least that you can affect via a framework, right? It has more of a backend influence on it, I would say. So that would be also the metric that I would be touching on the least. And we have a wonderful talk tomorrow by Estelle. So I'm just mentioning some stuff there. I will not be going into it too deep. And a comparison that Dan made was with Vue. So Vue, when you compare it with React, when you go very specifically into the metrics, Vue does better in some metrics compared to React, and we will be looking into why that is the case. FID, again, asterisk, that's changing soon. But when they did the analysis, FID was still FID, so I feel like I need to say a note. FID was kind of meaningless, and not my words, because all of the frameworks kind of had a pretty good score for FID, which means all of the metrics had pretty performant first delay, but the difference came in when you measured over the loading of the page. So again, FID changing soon, asterisk. So when you limit for 1 million, what are some of the key things that we notice? So the amount of JavaScript downloaded increases when you filter for the top 1 million websites with the most traffic for the United States on the mobile clients, which means arguably these are the most popular website, which means arguably they have more features, more expectations from the users, more users using it. So consequently, the kind of libraries that they use and the features that they give, they do have more JavaScript usage. But at the same time, compared to sort of previous versions of the study, I believe, these newer websites, they download significantly lower sort of media data, not just images, videos, which means images, which used to be one of the biggest drain on performance, things are getting better. People are kind of paying attention to it. So if we do take images out of the equation, if we just focus on development and data and rendering, how can we do better at this, right? So essentially, when React sites actually go down in terms of like performance improvement, when you limit to the top 1 million websites. Again, FID. We are sort of phasing it out. Again, you should be remembering this. This was just the last talk. And the difference between FID and INP, I will touch on it again. But I just want to stress that at this point, some of the things I will be talking about is just my hypothesis, because INP has not come into play yet in terms of a stable metric. So I will be giving you my assumption about it, but once the data comes in is when we would really have more kind of concrete conclusions on this topic. So as I mentioned, that was very much a deep cut into one significant data set, right? When you zoom out of the United States and go a bit more globally, so this data that I have in the dark blue, it's from 2018. So we all hopefully remember 2020, there was this little thing called the quarantine and stuff, and that did, in a lot of places, really push digitization in previous places where digitization was considered, OK, I don't need the internet, right? I don't need to use it. I have cash, or I can just talk to a person. That kind of scenarios changed unimaginably. And I say that as somebody who's from India and who has experienced this. Like, my grandfather asked me, hey, how do I install Airbnb? He had a Nokia. That was a very weird discussion. So in a lot of ways, mobile, when you zoom out of the United States, is the leading use case in a lot of websites, and it is being used by an increasingly diverse population, which might not have the same kind of access to the internet and the same kind of, let's say, access to quality internet. So those are also important metrics when it comes to this kind of a consideration. So I had a talk in 2019 about this topic, and I went back and watched it kind of recently, and I felt like, wow, some of the things I said do make sense. Cool. And I don't want to toot my own horn or anything, so if you are interested in this kind of zooming out kind of reference point, I would still ask you to go take a look at that. But this is what it comes down to. If you are building for a global audience, the world still uses the internet with very crappy speeds and very slow internets and unimaginably innovative ways. So I would recommend checking that out if you're interested in that kind of a deep cut. So as you see, I'm going to touch upon these things, but as a 50-minute kind of a talk on performance, I do not, unfortunately, have the time to deep dive on any of these topics individually, but hopefully I can give you some thoughts and vibes on these very specific kind of ideas. So I did promise you a scenario, right? I'm bringing in my scenario now. As hopefully you guys remember from about 20 minutes ago or 10 minutes ago, I do work with scripts, managing a media application, and managing a media project. So this is very much our CEO's vision board scenario, the next John Wick movie, we wish. It's not John Wick right now, but he really does wish. So assuming that we do get our hopes up and we do get it, assuming that we do get the next John Wick movie, and we want to manage that kind of a media project, how can we? And here's where I'll be going a little bit deeper into the React-specific cases. So this, I just wanted to show like a flowchart of how the data would be like. So what would be the different kind of classes that we have? We have a bunch of roles. You know, John Wick is a role. We have Winston. We have the little dog. I hope people know at least a little bit about John Wick. You know, shoot, 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 shoot. We have some props. We have some really amazing location. Things that I've not added here. We have stunt work. So that has its own set of data and parameters to manage, which are much more complicated. You know, you have shooting dates. And again, I've only included the very simple stuff. So if we include stuff like shooting dates, those could change. For example, today the weather is unimaginable. You do not want to shoot stunts in a weather like this. So that kind of reimagining of a real-time situation is very complicated when it comes to such a large data set. So first metric that I want to deep dive into with these kind of scenarios in mind. You know, it's very easy to talk about performance when we just have a sample application and we can just reference some things from the documentation. But that's why I want to go through a scenario with some complicated data points with you. Again, LCP is the metric I'm going to touch on the very least. And why is that? Because, again, a lot of the things that you need to do to improve on your LCP would be things that kind of has a bit more of a back-end influence. Mostly it will be about eliminating load delay, improving your network latency, reducing your resource load, stuff like that, which I don't know how much as a React developer you can influence those things. But just to do my work as a speaker, I would be amiss if I did not mention at least a few steps. So going back to my scenario, what would I be doing if I wanted to have a better LCP score in my application to manage a script? I would be, of course, improving a server response time. So that would include something like a CDN. I would be minifying my code. I would be optimizing my media files. So I hope everybody knows about, like, if you're using a standard React application, I assume you're using Webpack. So you can go through Webpack, talk about how you need to implement a production build, do some tree shaking, stuff like that. Again, I'm just touching on these top points. I will not be going in too deep on any one of them. These are all kind of connected to LCP at this point. Moving to something that we can actually control with React, let's talk about CLS. CLS is a cumulative layout shift. So I assume people at least know the top level of what CLS does. But just in case, I'm going to go a little bit deeper into this. So what CLS measures is like an unexpected shift of the layout for a user. So if you are going into an application, for example, you're coming into my application, and you're at the login page, and you're like, click, I want to upload a script, and it goes to the script page, that will not be counted in CLS, because that is a user interaction. It is not unexpected for the user. It is something that happened as a reaction to the user interaction. So that will be what INP covers. So let's be very clear on the distinction between those. So how is it measured? So the browser looks at the viewport size. So here, most of my examples will be in mobile, because again, that's my use case that I've chosen to work on. But it will be working pretty much exactly the same on desktop, I think. I hope. So one single unstable element, so how does CLS make a difference? And I want you guys to keep this kind of a screen in mind, so that when I bring the React-specific example, you can see how this kind of shift would make a difference. So I have, at first, 2 boxes, one with white, one with green, and then I bring in something which a little button pops in. It's a very dynamic DOM element added to the first box. Now, the first element, the white box, it doesn't move. It has the same starting point in the first screen as the second screen. So it is not considered an unstable element. The second DOM element is the green box. That does move. It goes from almost the middle of the viewport to a slightly lower, right? That's where that calculation comes in. Now, you might be interested in the orange little button that comes in. Technically, that is not an unstable element because it did not exist in the first frame. So we only consider the elements that actually moved. If it did not exist in the first screen, then technically it is not unstable, because only if it moved and it just popped up in the second one. So when it comes to multiple unstable elements, looking at the previous example, we can see only the first one, cat, has remained exactly where it was in the previous screen. In the second screen, we have a few creatively named predator animals who just pop in unannounced, but they are all elements that did not exist in the first screen, so they cannot be considered unstable elements, right? But there are a few, starting from dog all the way down to zebra, which existed, and they moved individually down, down, down. And in this case, the CLS calculation will only take the maximum distance that it moved, so which is the blue arrow here in this case. So having that kind of a calculation in mind, and I'm hoping that since a lot of people have worked with React, you can already get what a React context is and the use cases for a React context, right? So I have a bunch of data that I want to manage, and in the case of my scenario, the screenplay is the source of truth. Right? Once I upload a screenplay, that is where I get all my roles from, my costumes from. They're all dependent on the data I get from the screenplay. So then, a React context is very ideal for that kind of a top-down approach, where there is a single source of truth, and once you have to change the source of truth, everything connected to the source of truth should re-render. Right? So the minute I change the screenplay from John Wick to The Dark Knight, all of the other 4 should change, because the roles are different, the costumes are different, the makeup is different, the props are different, wildly different. Each one of those things will be impacted. So screenplay is a very good use case for a React context. Yes? You guys are with me so far? Yes, I see nods. Fun. That's when we get a feature request. Hey, we would like some versioning of the script. Now, as anybody who sits in the front row would know, there is no way in which we can have only one version of a talk. You start writing a talk, and there are multiple versions, which is what our clients told us. Hey, it's very nice. This is a very useful application, but we have multiple versions of the John Wick screenplay, and we would like to maintain the different version and some editing. But that is when things go very wrong, because the minute I upload a second version, everything re-renders. But that's how I wanted it to work. I wanted everything to change when I changed something in the screenplay. However, how can I do just a conditional upload? Now, if you wanted to do that, clearly React context is the wrong data kind of management tool to use, right? And I wanted to show a scenario like this where it started off being the perfect thing to use. It started out being the right tool to use from the React toolbox. But as the feature creep comes in, as you get more feature requests, you can see how, OK, this has started out exactly how I wanted to do, but then it changed into something that I definitely did not want it to work like this. And this is a very simple example, but it can be only after 3 or 4 iterations down the line you come to a point like this. So what will I do in this kind of a scenario? I will come to that. But before I talk about that, let me talk about some other conditions for the CLS. So the React context re-rendering is a very small example. And the thing about React context is that when you change anything in the context, the data that you store, everything connected to the context re-renders. So that can be, if the user doesn't expect it, it can be quite jarring, especially if you have images and things like that in your data that you've put into your React context, which is also why in my slide with React context, these are some of the ideal use cases for React context, those conditions where you do want everything to change. So in case you have authentication, light mode or dark mode, or for example, localization, your user is going from, they are originally based in the US and they flew to the Netherlands. So you want some localization stuff to change based on where the user is accessing it from. So those are still ideal cases for React context, because we do want those data to re-render at that point. But if that data changes too much, then React context becomes the worst use case for that kind of data management. And so that's a very simple example, and here are some more CLS kind of scenarios that can come into play. One, as developers that we might not think of, is kind of like images or third-party stuff that, while development, we do not face. Or even if our testers do face, some stuff is cached, and we don't really see or experience it the way our users do it, because it's cached, it's third-party stuff, and I really don't have to touch that. But those can really be some CLS gotchas that come down the line. So some more, and I want you guys to understand the principles of it and see the different cases in which this happens, because there really is no one way to fix it. It really depends on your application, your data structure, what you're trying to do. I really cannot give you like, hey, if you have CLS, do this. Because if that existed, somebody smarter than me would have already done that by now. So this is very much a think about all these scenarios. This is all the way in which your code can go wrong. I am very sorry. Glad you had lunch. So let's talk more about ways things can go wrong. Images without dimensions. I think these are the simplest of cases. Of course, when you add in an image or any kind of media, you do want to have that kind of section in your viewport in mind, have height, width, whatever it is, given there properly. Ads, embedded stuff, iframes, those are all. Iframes would be, for example, if you have a Google Map plugin coming into play, or a YouTube coming into play. Those are all iframes, which can kind of have an unexpected layout shift when that iframe pops in, or when that widget loads, right? So do keep the space that you want in mind when you develop stuff like that. Top left animations, again, as I mentioned, each one of my slides has things where you can deep down into how performant things can be, and that really is out of my scope of my talk right now. So do keep those things in mind. One thing I can say about animation is that animation can be a really good way to improve your CLS score if you use it the right way. So if you have kind of something where there is a user interaction, the user has clicked something, and it's taking a lot of time to load it from the server or something like that, you can have a really good animation in there in place to keep that kind of space hold, so that when the data comes in, if it is out of the sort of time limit that the CLS calculation usually takes in the browser, it holds the place, and that CLS calculation doesn't take hold, It kind of smooths things over that way. So using CSS transform as a method. Web fonts are, again, a huge kind of opportunity or a threat, depending on how you look at it or how you use it. So these are all fronts on which your CLS can get better or can get worse. So in my scenario that was previously, React context was screwing everything up. So I brought in Redux. as a lot of us do, right? And in Redux, I have all the different things that my screenplay was supposed to do. They are all individual units now. The roles have its own object. The costumes are its own object, right? And they're all separated in so that we don't have that kind of a re-rendering when a central point of contact is changed. So if I wanted to change something in my script, if the only thing that changes is the location for it, I can just send a second version of the locations API or something like that from the server, and I can just update the locations data that is connected to my project, right? So this is, in my scenario moving forward, I will not be having that kind of a centralized data flow. I will be having them separated out. But don't worry, there are enough problems that happen in this scenario as well for us to be entertained for the rest of the talk. More scenarios for things go wrong. Yes, displaying a large collection of data. This will come into play in one of my future examples. But when you have a large set of data coming in, so when you use something like lazy loading or caching, so those were some things that I recommended back in my LCP slide, which I don't know if you remember because there was a lot of content up on the screen. So that is point number 4, if I'm not mistaken. Yes, there you go. So things that you do to improve one metric can end up causing something for the next metric. So if you do caching and lazy loading, OK, my LCP score is improved. Going down the line, when you have a CLS score and you have lazy loading, oops. I wanted to show a very specific example here, right? So when you have lazy loading and you have not done it properly for a large list of data, it pops in at various times in between because it was supposed to, but you have not put in the kind of space that you needed, right? Is it performant? Yes, the data came in. You did not load too many in the first go around. But for the user, the visual stability is not good. You know, it's jarring when you are scrolling through something, suddenly more data kind of pops in. We have all used certain social media platforms, we will not name names, where you are scrolling through things and suddenly pop in or goes back up. You know, I'm not going to name names, but we all know who we are thinking about. So everybody makes these mistakes. That's all I'm saying. Don't want to get sued. So having large amounts of data is, again, there is no simple way to do it, because if they could do it, those guys would have done it already. So it really matters on how your data is, how you can manage it. And one thing I would like to say, sort of, which might not be something that I put on a slide, but I do notice it from my experience that sometimes when CLS issues come to front, it is something that my designer thinks, hey, this would be really cool user experience. You know, in the beginning, the user doesn't even have to think about it. But when they scroll down, this thing pops up, and they can see this cool animation. And at that point of time, I would like to tell my designer, would the user really like it, though? Would they like it, though? Have you seen how our users use things? Have you talked to customer support? Do you really want to give them jump scares? Really? But your designer is your designer, and be like, but it'll be so cool. I designed something. You scroll down, it would be amazing. And then this happens. Finally, you have an engineering reason to tell them, hey, your ideas are great, but engineering says. So displaying large amount of data, or whatever your designer feels like doing, sometimes if you have that kind of caching or lazy loading or whatever it is, where initial perception of how the page render is slightly different from what once the user kind of interacts with it could happen, then keep that in mind. So again, another thing would be the non-discrete inputs. So non-discrete inputs is something that the user does not engage with directly. So a click is a discrete user input. Tapping a keyboard is a discrete user input. But scrolling through, hovering over, these are not considered discrete user inputs. So if you have a tooltip that pops up, I think it would still be considered as a part of your CLS score, because it is a visual shift that the user did not expect. Or sometimes they do. They see the tooltip icon, but maybe the calculation algorithm does not expect the user to expect it. And another condition, which I don't think these would be common, but I thought just to say it out loud anyway, is error conditions, especially error conditions which are unexpected, server error conditions, where you have a large list of data or images or something, and you expect kind of, maybe even in streaming, you have that kind of data coming in from the server, and at some point of time, the data just snaps off, and if you're not concerned about it, or if you're not clear about it, then the minute you have that kind of an error, if the full screen was this much, it'll pop down to just a text saying, oh, there was an error, there was an issue. But you should keep that kind of visual area perfect so that when the data reconnects again, you don't have that kind of an unexpected visual shift for your user. So there are so many different conditions in which these can happen, and I'm sure this is not exhaustive. There are other things that can happen very specifically for your application that I have not thought of. So this is just a principle of how to calculate it, what are the things you can keep in mind, so that hopefully when you see it next, you have an idea of how to tackle this, how to approach this. So now I'll be talking on to INP, and again, I hope you remember, Nishu talked about this, so I will be kind of zooming through this a little bit. And again, this is not a stable metric yet. This is still something that's going to be stable next year. So some of the things I'll be talking about, especially when it regards to INP, is a little bit of a hypothesis until we get real-time data from how users interact with it. I would like to touch upon the difference between FID and INP, especially when it comes to kind of the calculation of it. FID is the first interaction delay, so it only deals with the first time the user interacts with a page or content or something like that. And it did kind of slant towards LCP in terms of like a low responsiveness metric as well. But as I've noticed with INP kind of measures it for the full life cycle of the page, right? So rather than first impression, I feel like it really would sort of give a better scope of the user's interaction during the life cycle of the page. But again, we'll see. So going back to the kind of analysis that started it all, I hope you remember, LCP React didn't really change much when we had the whole data set and when we filtered it down to 1 million, right? FID didn't really matter that much because all the frameworks had like a really good ratio for FID. The one thing that React went markedly down on was the CLS, because React has some re-rendering kind of biases that come in with the virtual DOM. I will talk into that. But as we move from FID to INP, I do believe that React is one of the frameworks, because of the way React is structured with the virtual DOM and that kind of the way the DOM is set up, it could impact kind of 2 metrics at the same time as compared to how FID was measured, right? So if CLS was React's weak point in our previous analysis, moving forward, it could be that it does weak in 2 more metrics as we calculate kind of how React does across the interaction throughout the lifecycle of the page. So re-rendering, the final boss of all React problems. So again, I would like to compare this with Vue. Vue and React, if you compare, one of the biggest things is how Vue, when you have the re-rendering, the compiler, you can sort of have optimization both at compile time and at runtime. But in React, you can only have that kind of optimization at compile time. React is unable to optimize during runtime. So any runtime kind of re-rendering that you have to do, it has to traverse through the DOM tree again and again. And that is also why we can have that kind of a re-rendering issues, if you may, when you don't pay attention to how your React state management or your data management is done incorrectly. And don't worry, I do have examples of how things can go very wrong. Fun part of my job. So we go back to how things were perfect in my application when I introduced Redux, right? Everything was independent. If I wanted to change versions, I could just change only the locations, only the roles, and it was all perfect. But then you realize some things have interdependencies. So for example, once the role changes, we have to change the costumes. makes no sense to have the costumes for Winston or the costumes for John Wick if I change John Wick is played from Keanu Reeves to Halle Berry, right? So there are some dependencies between these data. They are not completely independent of each other. Again, for props, based on how the location changes, I do want to change the props used in a particular scene. So each of these data points is not as isolated as I would like to believe. So if I do have such a condition, how do I solve it? In React, there's a very simple solution when you have dependencies. What is that? We use a use effect. Very simple solution in React is you have a use effect hook, and a use effect hook, what it essentially does is that I would write a level of code where, okay, this very specific thing, in this case, for costumes, that's a role ID. So once a role ID changes, now everything in the square brackets is always a dependency. So the minute the role ID changes, I want you to refresh the costumes. So this runs every single time anything in the square brackets changes. So first case, dependencies, I add a use effect. I have more complexity. I bring in one more data item, which is makeup, and makeup is connected to both costumes and to location. What would this cause? This would cause a re-rendering mess, kind of similar to what we had when I had use context. Now you can see, we started out thinking context was perfect, but then context was not good enough. So I switched to Redux, thinking, hey, Redux has more of a fine-tuned control over my data. But as more features come in, as more iterations come in, you can see how as much as you want re-rendering to be perfect and as much as you optimize for it, as features come in, you can run into these scenarios where, yes, at the virtue of your previous kind of scope, you do run into this kind of re-rendering problem, for lack of a better term. So how would that be termed? I believe it's called layout thrashing. So there is a lot more that I would like to talk about. Unfortunately, I do not have time for when it comes to layout thrashing and that kind of calculations and what it takes and why React is especially poor at it. And that fundamentally comes down to, as we said, during runtime, React doesn't optimize as well. So based on how your data is structured, the minute you add more dependencies to it, it could cause that kind of a chain reaction that re-renders a lot of things. One point I would like to note, if you are facing this kind of a layout thrashing kind of a scenario, one thing you can do is use the profiler. I believe if you use Google Chrome, it shows up in like a lovely purple color. So you can see the different points at which the layout calculation is happening, where that kind of a sort of crisis is happening in your specific scenario. And those are kind of the scenarios that are places that you have to look into and the places you have to optimize when that kind of thrashing occurs. So I would like to give a very special mention to use layout effect. Use layout effect is something it is similar to use effect, to be honest, but it fires quite before the browser repaints the scene. Now, if anybody knows anything about layout thrashing, that you can see where things can already start to go wrong, because you want to minimize the number of times that kind of an effect happens. But there are cases for which use layout effect is the right deal to do. For example, things like tooltip. Now, imagine you have an entire application and you want to show a tooltip, right? You want to be able to render that tooltip somewhere, calculate the height and width of it, and then again re-render it as the window paints so that it is on the right side, like above the icon, below the icon, whatever it is. So there are cases in which even things that generally the community says, please don't use, because there are cases in which things should be used. Nothing is evil, nothing is bad performance-wise. It is just, it would be bad if you use it the wrong way. It would be bad if you use layout effect in the place of use effect just because they look similar, right? It would be bad if you used React context in the place of Redux just because I don't want to add a new library, right? So each tool has its own place in the React kind of pantheon, but be very careful when you use these hooks and be sure about what kind of consequences they have when you use them in your specific scenarios. So I do have a few minutes, so I would like to talk about some React-specific methods to improve that kind of a layout threshing problem that I faced earlier on. And the first kind of optimization method I'd like to talk about is React Memo. So React Memo is a kind of a React tool to reduce the re-renders of a full functional component. So compared to, there is a specific one that you can use for a function, there is something else that you can use for a value, but very specifically for a functional component, to stop a component re-rendering again and again, to avoid that kind of full, if your layout, for example, is held within a single component, and you don't want it to re-render again and again. And in the scenario I mentioned before, the minute I introduce makeup into it, there are a bunch of other interconnected ones that could re-render again and again. So I want to make that kind of re-rendering more conditional, more fine-tuned. I would use something like React Memo in those cases. And I do have an example coming up, but just for people who are not as familiar with React, I just want to give a quick overview. Memo is a customization option in the Memo basically lets you have a customizable function right after the component. So how it's done is basically you give a functional component, it does whatever the component is supposed to do, and then by default, you do not need to, because by default, React kind of compares all of the props that that component has, and it says, OK, if none of these props change, the component is cached, and it will be memoized, and it will just show it again without completely re-rendering it. But there could be some scenarios in which you want to give a very custom kind of memoization function. So let's go into that. So here is a use case that we had. So for example, I showed you a bunch of data. We have data for the different roles in a script, different costumes in a script. And one of our clients wanted different views of the same data. Right? They wanted it in thumbnails. They wanted it in a table. But at the end of the day, the data is not doing anything different. The only thing that is changing is just how the client looks at it. So we used React Memo in that kind of a scenario where absolutely nothing was changing except how we showed it, so that the component underneath, which was making that kind of calculation and having that kind of data, would not re-render. It's just that the final parent component, which was rendering that kind of data, that was the only thing that was re-rendering again and again. So that is one, again, a scenario, an example. So an example would be, in this case, we have costumes. And I'm not going to show you all the code. This is, again, scenarios and things that you can consider. So I have my costumes. They are connected to both roles and location. So what do I want from my costume? If the particular role ID, which means these costumes are connected to a single role and to a single location. If the location changes or the role changes, I want that costume component to re-render. But as long as those two remain the same, no matter what else changes, I don't care. The costumes should not be re-rendering it. We should have that kind of fine-grained control over how my costumes are displayed in my application. So I did mention that we can do this for methods as well as for values. How would I do it for a function? I would use a use callback. A use callback is, again, once you get one of these kind of memoization techniques, they are quite similar. It's just that each are recommended for a very specific use case. So there is use callback, and the next one I'm going to talk about is use memo. These are both React hooks. So there is no conditional rendering of these things. They can only render in the top level of your component. So how does use callback work? Let me show you with an example. So I have an actor profile, and I want to do kind of a size conversion for an actor. So what would that change? Every time the costumes are every time the actor changes, or every time the target country changes where the actor is, I want that kind of size conversion to happen again. Those should be the only two cases where that method is re-rendered. Until then, OK, I missed something, my bad. So what does React callback give you back? You basically enter a function, and what React callback gives you is a function that is kind of memoized. So no matter what input you give into it, as long as the dependencies don't change, it would still give you a function that gives you a very specific processing of the input that you give. So coming back to the example, as long as whatever costume list I give, it should have the conversion, but this conversion should change when the actor ID changes, right? When the actor changes or the location changes, I want the size conversion to change. So the last one I have for you is use memo, very similar to use callback, but instead of having a method there, I just have a value calculation. So here, one thing I'd like to note is that the role details, that one thing is under a loop. So as you remember, for hooks, you cannot do it conditionally. So I kind of took it out into a component by itself as role details, and I ran use memo inside the component, so that I would avoid that kind of a conditional rendering of use memo inside a loop. So at the end of the day, what does this all come down to? You will always have dependencies, especially when you use React and that kind of a React framework to do your re-rendering and your component management. You will always have dependencies that will always cause re-rendering, but do keep an eye out on where the most re-rendering happens, where your dependencies are. And this is just a starting point. Again, there is no silver bullets to this. Keep these techniques in your mind, use them, go forth and prosper. That is it from my side. And I will be taking your questions pretty soon. Thank you.
Keerthana, yeah, thank you so much.
Thank
I
you.
think we've got a time for probably just a couple of questions. Let's do that awkward perching on the stool thing and try and
yes.
I might just lean this time. I don't know.
Accessibility, am I right?
Yeah, exactly. There we go. Awesome. So, yeah, there's so much. First of all, there's so much in that talk. It's really dense and full of great stuff. So thank you ever so much for that. One of the things, I mean, you're showing lots of techniques and lots of tools that are available to you as a React developer to address particular aspects of performance. But I guess one of my questions might be about keeping that in mind in the first place, because there are so many ways that you can build with React, or indeed with any tool, right? So although you've got access to all of these techniques that you can use, are there any things that you particularly like that help you while you're developing something to keep performance in mind? I mean, are there ways that it exposes to you what the implications are that you're creating by building in a certain way? What makes performance visible to you as a developer, I guess, is the question.
That's a really good question, and I'm just thinking about it right now. To be honest with you, I think there is a major difference. One thing about React is, again, as you mentioned, there's so many ways to do things. React really is the wild, wild west of web frameworks, and you really need a sheriff in town to tell you, this is the performant way, please don't do it the other way.
Right.
So it's really hard to kind of do that as a developer, but one kind of, and there is a big difference between if you have a legacy system versus if you're building something brand new. Because if you have something with older React versions like 16 and above, I am not as familiar with that code, so I couldn't think of kind of the same ways in which I would do it.
Right.
But for code which does have hooks, I would think one thing I keep in mind is how many use effects I use.
Right.
How many times I have that kind of hooks which have dependencies, and if I start to see there is too many, that's when I have to sit down, at least with the rest of my team, with my management, hey, maybe it's time to rethink some of our data structures, because we are having too many conditional calls and dependencies happening in the way we do things right now.
Absolutely, yeah. And I guess another symptom of all of these tools available to us, and this is one of the questions that came in actually, is, in your opinion, do you think that frameworks like this are helping, are they making it easier for us as developers to make sites that perform well, or are they making it harder for us to make sites that perform well because of the power that they encompass? I mean, that's a bit of a gut check and an opinion as much as anything else.
It is. It depends. The $100 billion word.
There it is. That's perfectly fine. Yeah.
But as I mentioned in one of my slides, there is a reason why all of these top websites are still doing so bad in performance, because they have so many features. There are so many expectations when you're a highly used website from the users. They want to give third-party stuff. You want to have all those things that users enjoy using, but those things, they take iframes, they take JavaScript, they take third-party libraries. So if there there is a better way to do it, which we will probably find out throughout the years. But currently, it's all we have. We just keep getting better at it.
Fair enough. Okay, excellent. Well, thank you so much again for a wonderful talk. Are you going to be around in the break to talk to people up at the table? Thank you ever so much. So yeah, if we didn't get to your questions, apologies for that, but make sure you find Keerthana upstairs after the break. So once again, thanks so much for a wonderful talk. Keerthana, Krishnan, and everyone, thanks so.
Thank you.
Awesome. Okay. Right. Well, as we do another quick laptop change, I will probably dive straight in to talking about Ryan. Why not? Here he comes. Because I was looking through the schedule a few days ago and looking at the talk descriptions, and I'll be honest, I had a feeling that Ryan might have written this talk just for me. It felt like the abstract of this. How can I frame this? If I was looking through a dating app and I saw this would have me straight away. I don't think that's what he was going for. It wasn't just your photo. No, it was all of the aspects of the abstract. This is right in the sweet spot for me. And I'll maybe expand on why, because otherwise that's weird. But first of all, a little bit about Ryan. I first met Ryan over in Leeds at an event over there, and I was instantly kind of delighted by the kind of things he was saying. He's run an agency for a long time, has been in web development for a long time, has been a CTO for many years. Right now, he's getting all kinds of nuggets of wisdom about that he's learned from being a CTO out onto Instagram. So who knew there was a crossover between CTO and influencer? So that's a new one on me. But I've been harvesting that content eagerly. It's really, really good stuff. Ryan talks a lot about a judicious kind of application of powerful tools. We've got lots of powerful tools, as we've just seen in the last talk, and knowing when to use them and how to use them, and how not to be kind of weighed down by some of the things that they can bring as well is really important, and thinking about how we can use the web platform and the APIs that exist there. Just lots of stuff that I'm very, very interested in and excited by. So a wonderful title as well, The Unbearable Weight of Massive JavaScript. Oh, I don't know where this could go. Shall we see? Ryan, are you good? You ready?
Yeah,
Plugged in?
ready.
Happy? Thumbs up all around. Okay, a giant, loud round of applause, please. It's Ryan Townsend.
Thank you. So I brought a couple of things today that I don't think you're going to be overly happy about. It's not a hatred of React, but one is the terrible British weather. Usually we come to Amsterdam to get out of that. And the second thing is I've got a really bad cold, so I apologize if I sound really nasally. I was hoping to be on, a bit of recovery and sound more like Liam Neeson with a raspy voice, but I might actually sound like a teenager whose voice is just breaking. Anyway, the show must go on. So despite all of our best intentions, we're all here to improve our performance. We're amassing a larger and larger volume of JavaScript every year that passes. On the last data from the Web Almanac, which was a couple of years ago now, it was growing at about 10% a year, and I've no reason to believe that it's any different now. And this is at the detriment, obviously, to our end users in terms of performance, but also to us as developers. And with IMP on its way, JavaScript really is the very literal elephant in the room at this point. There's an element of CSS recalc in IMP, but ultimately we wouldn't be getting such low pass rates purely if it was just purely down to our CSS. So today I'm going to talk about our priorities. How did we get them kind of misaligned from our end users? I'm going to be talking about what does it really mean for us to be actually productive. And I'm going to be showing you some things with the web platform that can help us improve our web performance, can give our users a better experience, and ultimately everyone wins through better productivity. So it's my goal to convince you that you should be looking to the web platform first for features to implement, rather than re-implementing everything in JavaScript straight away. So to rewind a little bit, to see where we've come from, I'm going to embarrass PPK a little bit here maybe, but this takes me back to when I first started working for the web. It's a particular honor for me to be on stage today. If you're too young or too new to the industry to know, PPK's website was a precursor to Can I Use. He was documenting the inconsistencies in browsers and the different support levels. So it was pretty important for us. Like, Can I Use only came in 2008. So if anyone's done the quick math, that's 15 years ago now. And that means I've been building for the web for over 2 decades. At this point, in any of the industry polls that we have online, state of HTML, that kind of thing, I just get bucketed into some kind of open-ended entry at the end. And I know it's a weird flex to kind of point out my own age, but what it means is that I've experienced different eras of building for the web. When I first started, we were doing things like this. We weren't debating over whether we should put CSS in JavaScript. We were putting JavaScript in our CSS. Does anyone recognize what this is for? A few hands going up. Yoav, do you want to take this one? So, close, but so this is how we actually implemented transparent PNGs before they were existing in Internet Explorer back in the old days. And it wasn't the only thing that we didn't have. There were no evergreen browsers like we have today, where they just constantly update with these new features. So even when new features came out, it was a snail's pace at which they were adopted by our end users. Front-end development wasn't really taken seriously. As you've heard earlier from people like Mark, we had the kind of web designer role who was kind of crossing over between design and development, and they were kind of responsible for both, or you had back-end developers who also dabbled in the front end, and there was this kind of gap in the middle where it wasn't really just an isolated role. Half the web was inaccessible Flash websites, and in terms of automated testing, while Selenium did exist back then, it was so resource-intensive, so slow, that most people just YOLO'd some jQuery and hit refresh all the time to QA their sites. And finally, unlike today, we only had really rudimentary web performance tooling. There's no such thing as Lighthouse, Core Web Vitals, or Web Page Test. But despite this, it was an incredible platform like it is today. You can reach a global audience. You can iterate faster than any other platform. If anyone's done any native mobile development, it does not compare to building for the web. You can literally go from writing a few lines of code in an IDE, slinging it up on an SFTP, or pushing that up to GitHub, and it can be in users' hands within seconds. And back then, we had a lower disparity in our devices and our connectivity. Everyone was on crappy dial-up or early broadband. Everyone had these old archaic CRTs and desktop computers, and that meant we were more connected with people experiencing the kind of problems. Nowadays, everyone's got these fancy iPhones or MacBook Pros, and you're kind of disconnected from a lot of your users. Because of this kind of disparity in both the kind of connectivity side and the browsers all supporting different things back then, 2 terms, progressive enhancement and graceful degradation, were coined, and that helped us push people to build these more robust websites. And the web standards movement focused on creating more consistency between the browsers. Obviously, things have moved along a lot since then. We've even managed to get border radius native in CSS. If anyone remembers that, we used to cut up bullet points to make the 4 corners of a square round, which was ridiculous. But kind of despite all of these improvements since then, the web's felt a little like this. We've seen incredible growth in the industry. Front-end development's now taken very seriously, which is great. I mean, we're a subset of front-end here, and we've packed out this hall. But big tech and VC have moved in and showed us these kind of very shiny demos that are actually quite shallow. It's like a hello world demo. Look how great this is. But in reality, there's a lot of problems with them. And the pressure on the available talent over the past decade has meant that we've been kind of chasing our tails in terms of everyone wanting to get the best job possible, which, I don't blame anyone for, and wanting to use the technologies they're excited about, and companies being like, okay, well, we've got to offer that, otherwise we're not going to have any developers left. So that has meant that we've lost sight of our users a little bit. Earlier in the year, I was on Reddit, and I saw someone, it wasn't me, who posted this question: why are you still using React? And they We're posing that there's a plethora of better options these days. Why are you still using it in 2023? And the number one voted answer was primarily the money. People chasing employment. And I'm not hating on React here, not hating on people just trying to earn a salary. Those are perfectly legitimate reasons. However, that's a far cry from being user-centric. That said, we've been kind of promised that this would trickle down to our end users, right? And it kind of makes sense. On paper, if we focus on the developer experience, make developers more productive, then that'll mean that all the outsourcing of that expertise will mean that users get a better experience, and it'll mean that they can focus, they've got more time to focus on enhancing that user experience as well. But if that trickle-down had actually worked, we'd have some incredible websites right now. Well, the whole web would be incredible, rather. But it's not really worked out like that. So this is another thing that I saw at the start of the year, dropped into my inbox. It was a case study, a bit of research done by Storyblock. And they found that the resounding majority of businesses felt that their website was actually holding sales back because of poor user experience. 92% is a pretty incredible figure. This both shocked me and didn't surprise me at the same time. And in fact, this goes even further. So behind the scenes, there's also 10% of these businesses felt that the cost was over £100,000 a year in lost sales. So pretty significant. So I said it was shocking, and obviously these numbers kind of stand for themselves, but it wasn't surprising. And that's because the modern web is often broken in very fundamental ways. Whether it's like janky sliders that are like 2 frames a second as you're trying to swipe on them, or they're not locking the scroll direction properly. Whether it's menus that you try and hover over to the item that you want to click on and the menu disappears. A couple of months ago, I was going on holiday, trying to check into a flight. I'm not naming any names. I've tried to cover up who this is. And I couldn't actually check in because the form wouldn't render. And looking into DevTools, it was because there was a JavaScript error on the site. Annoyingly, I couldn't hack around it because I didn't actually have a clue what the markup needed to be able to hit that form. And then a couple of weeks later, it may have been on the return journey actually, they had another problem. The form was working, it rendered, but I couldn't submit it. And ironically, it was because their JavaScript library that was collecting errors had an error. So I don't know how they managed to realize and fix that in future. But in fairness to them, they're not the only one here. Checking into my flight to actually attend this conference, I had exactly the same problem with another airline. So we've got to be able to do better than this, right? We need to recognize that a lot of the time, when we're being promised a great developer experience, really what we're being sold is just purely convenience. Yes, there's a time for convenience. When you really need to get something done very, very quickly and you're willing to compromise on a lot of factors. But we shouldn't be using that up front. You could do all of your shopping from a local convenience store, for example, but over time that's going to be way more expensive and you can have way fewer options than going to a larger out-of-town supermarket. In terms of development, productivity is more than just being able to npm install something or copy and paste some third-party script into your site. There's always knock-on effects from this, and performance is often one of the key victims here. I actually messaged Harry Roberts, sat on the front row here, a couple of weeks ago to ask him, how many of your clients actually come to you ahead of time to try and mitigate against any performance trade-offs that they might have to make as they're developing a new project. And somewhat unsurprisingly, as you can see, not many. Most of them come to him when their world is on fire. And these are big brands. They've been promised, it'll be so productive, it'll be incredible performance, costs will be lower. These are promises made by outsourced agencies, by their own in-house dev teams from time to time. And it's because nobody really took the time to analyze these projects holistically. They were focusing on, what do they really want to use in terms of the technology. So in my work as a CTO, I've been a CTO for 8 years now, and I've just gone self-employed to do it in a fractional capacity. It's my job to kind of look at the whole spectrum of functional and non-functional requirements and kind of manage all of those trade-offs in terms of what's important and what's going to have the impacts. And one thing I can tell you is that when web performance is suffering, it's generally like a code smell for other problems within the organization or the project. We need to strike a balance between all of these different elements, particularly the top 6, because they're the ones that really our users see. And I think the trouble is that a lot of the time we don't talk about kind of our failures. So I'm going to kind of fall on my sword a little bit here. I have made this mistake. We've focused way too much on the availability of talent and retention of developers. So I'm not innocent at all. A couple of years ago now, one of my dev teams came to me and they wanted to use a new tech stack for the next site that they were working on. Everyone at the time, as today, wanted to use React. Everyone wants to use whatever Netflix and Facebook are using because they have, those grand ambitions, and there's nothing wrong with that. But few people were talking publicly about when that goes horribly wrong. And as I mentioned earlier, we're in this kind of cycle of, hiring because people have that expertise and they want to work on those things rather than focusing on what the users want. So the team suggested using Next.js. And naturally, given my background in the kind of web performance space, I was a little bit reserved about just accepting that on face value. But they assured me, obviously, it's got server-side rendering, and you can customize it. So any suggestions I might have, they would be able to implement. And I accepted that decision at the end of the day. I said, OK, you've convinced me. And we do need to factor in the fact that everyone wants to be using these tools now. But it was quite costly. And I want to be clear, it wasn't the end of the world, but because of those other factors that were at play, it did impact us. So this is the site in question in terms of its core web vitals. And as you can see, the team did an incredible job of getting it to pass all 3. But with every little change that came, every little optimization that we focused on, it took way longer than expected to implement. Their tools were fighting against them rather than working with the grain of the web. Kid you not, the amount of times that I had to put in a request to even just add some loading feedback, because by default they're working on very fast machines and they can't experience that slowness, so everything feels instant to them, but to our real end users, they just didn't, they didn't have that experience. And these were senior engineers. The project cost hundreds of thousands of pounds. So it wasn't that they were starved of budget. We were obviously having to prioritize performance. It had me literally on their backs if they didn't do it. And obviously we had the experience and the expertise. I've learned so much from the various speakers that we've had at Perf now over the years, and other people in the community. And this is particularly important. If you watched Nishu's talk earlier, you can see how important IMP is going to become, and we need all those kind of that loading feedback and whatnot. And on that note, I had actually hacked that screenshot. I wanted to kind of remove the distraction of IMP failing, but even after all that investment, now the site is back to failing again, well, as of March next year when this becomes improper. But ultimately, this is showing what the users are really experiencing. We've got a problem here. We need to solve this today, not in 6 months' time. So it's really important that we are able to focus on this properly. And obviously, with this project, they had, as I say, investment into it, prioritization, and expertise. I'm sure you can imagine what organizations are facing when they don't have all of those 3. We were in a very fortunate position. In fact, I can actually show you with one of my old clients. So in the background of this slide, you'll see 3 speed curve reports. This is from a project that we built, a before and after. We did the before, just to be clear. This is just a standard kind of server-side rendered. It was using jQuery. It was a normal website, really. And when they looked to migrate, their agency was pushing them into using a single-page app. And obviously, you can see it's a sea of red. It may have needed a bit of modernization, but the site did work back then. And they've taken on this massive project because they were pushed into it. And this seems to be a kind of repeating theme, is that they're not making these decisions based on the end users. So if businesses are often sold these dreams in terms of what it's going to be like an app, it's going to feel amazing, everything's going to feel instant. That's great, but it's not really come from user feedback. If anyone's actually looked through customer feedback on a website before, and I know that's not an exciting prospect, but I'm fun at parties. There'll be all manner of weird comments in there, I can assure you, but I wish the website was more app-like will probably not be one of them. If you're listening to the vocal audience on social media, they'll make you feel like if you don't have an architecture diagram that looks like this, if you've not got 2,000 microservices unified by GraphQL and rendering a componentized design system via serverless edge workers, then you're just not doing it right, are you? But the reality is that all our users really want is a consistently actually working website that's reasonably fast, accessible, and usable. I don't think that's too much to really ask for. I know this can be a bit of a hard sell versus all the kind of fancy technology, but we should be focusing on these solid foundations rather than trying to deliver an amazing experience for the very small minority of users who manage to dodge all of our bugs, be on the right fastest device at the time, and have great connectivity and a full battery. We should be focusing on the top 6 here. So I'm going to walk through these different elements and kind of talk about the different problems. They're all kind of interconnected when we utilize JavaScript way too much and re-implement parts of the platform as best we can. Obviously, firstly, we've got to talk about performance. So whether it's the network impact of loading a big network or loading large JavaScript files, things like VDOM diffing, complex DOM updates, missing the GPU compositing, if we just implement things in JavaScript rather than using CSS properly. Obviously, there's a plethora of performance problems. I'm sure you've all brought many with you today to try and address. And yes, we have tools like we have compression, we have bundling, we have tree shaking, we have resource hints, speculation rules, all these different things. But they are just that, they're tools. They're not silver bullets, they're patches over problems. A lot of the time, they're treating the symptom rather than the actual problem. And a lot of the time, they actually add to our build processes as well. And that gets more complex, and leads me on to my next point, which is there's more to maintain. If you've ever opened a JavaScript-heavy application that's maybe not been touched for just 6 months, you're going to have a whole wide array of dependencies that you've got to update before you can even make a minor change to that project. Staying on top of, just NPM package updates can be a full-time job in itself. I have actually seen that. Don't get me started on people using buttons that are supposed to be links and links that are supposed to be buttons, or just div tags for everything. Yes, you can do that outside of JavaScript-heavy applications, but it generally happens more so when it's easy just to hook into any old element. In terms of security, 2 of the most powerful features we have are content security policy and feature policy. Both of these are loaded at document level. So if we have soft navigations, that means that you've got to open those policies to include anything that could be soft navigated to across your site. No longer can you compartmentalize scripts and things like that down to a per request or per section or per page format. You have to cast your net wide, and that means that you've got a much greater area of attack when it comes to security. So things like if you've got to do HIPAA audits or you've got PCI compliance if you're in e-commerce, those are going to be a lot more difficult because you're not able to target those navigations properly. With soft navigation, you also have to take up the job of re-implementing things like loading spinners, as I've mentioned. Even if you use the navigation API to update your URLs, you still need to manually manage things like scroll position. And if you've ever seen someone trying to browse, clothing online, for example, you've got this myriad of different items on a product listing page. You'll see very quickly people start just opening thousands of tabs because they don't trust the back button working properly, that it'll go to the right position. My partner's laughing down there because I spotted her buying dresses the other day in exactly that way. And yeah, there's a massive amount of stress when things don't work quite as they should. And this is, follows on to our kind of reliability and the website's actually working properly as well. When you've got hard navigations, the browser's very good at saying, okay, we don't need that content anymore. It can live in the cache, but we can actually tear down that old page state. We don't have to worry so much about things like memory issues or getting into a bad state. Like if you have a long enough session on a single page app, you're probably going to end up with some weird Redux state at some point, and the website's not going to act as it should. And then on this final point, I've kind of put questions against it, and I've used the whole kind of it depends thing, because everyone's onboarding and training processes are very different. Every project is very different. I don't think there's any kind of standard format where I think Rails has done it best, maybe, but generally when developers join a new company or a new project, there's always going to be some training involved. So I suppose that doesn't really matter what technologies you're using. But I could go on, and I think it's pretty clear already that few teams of developers are actually ready for this degree of complexity. I hope your teams are the exception, and the fact that you're all here today, trying to learn more about performance shows that you're cognizant of kind of non-functional requirements and that you want to give the best experience to users. But if you do want to try and improve things, what can you do? And that gets me to the kind of crux of this talk, is that I think we should all be embracing the web platform a lot more. You may not be aware of this, but the actual way that the platform is defined is to make our lives easier. So yesterday I was sat in a Google summit. In that room, there was maybe 10, 15 browser engineers, people like Yoav, who are literally there trying to make our lives easier. W3C calls this the priority of constituencies. And as you can see, we're fairly high in the list. We're the authors in this text. Only our end users are considered more important than us. So it seems silly to kind of throw away all of that and just go, oh, we'll just do it all ourselves. So I've got an actual real example. And with all of this in mind, I wanted to see how far we could really push the web platform. And I was doing an e-commerce migration. We're taking an online marketplace platform, moving it to a new one. And this is the kind of before in speed curve. You can see that LCP is a little off, but it's not terrible. CLS had already been very well optimized, but when it comes to our JavaScript, we had a lot of problems. That's the purple bar in the chart, and on this screen, you may not be able to see the chart, but that's 12 seconds is the time to interactive, which I know isn't the perfect metric, but that's pretty awful, right? 12 seconds is a long time. So obviously, we wanted to address this, but it's not the only problem we had with JavaScript. There's a few bits that SpeedCurve didn't show. I looked into GitHub, and there were 55,000 lines of JavaScript for this website. And yes, that was the source code, but 55,000 lines, even being pushed through a build pipeline, is not going to output nothing. There was a clear problem with the productivity here as well. So something had to be done. And today I want to show you 5 web platform APIs that really got me excited about working with the web again. These are things that we used on this website that you should be able to use today, and hopefully it'll get you pumped for using the web platform. These are things that have shown me, we can learn from the past. We can use the good and the bad, and produce a site that is more productive for us, better for our end users, faster, more accessible, so everyone wins. So, before I actually go into those APIs, I know that was a bit of a tease, I need to show you the kind of approach we took, because they all have varying degrees of browser support and varying degrees of demand on JavaScript. So the first thing I need to mention is progressive enhancement. We've kind of covered this a little bit with the island architecture coverage from Mark earlier, which is a great example of progressive enhancement. Send as much HTML down as you can. But some people feel that this means kind of re-implementing your website twice. You've got to make sure that the HTML-only version works, and then make sure that when JavaScript comes, then we've got to check that as well. But it's really not that hard. It just requires some education and true empathy, which I appreciate is effort as well. So just for the avoidance of doubt, it's about sending real HTML, forms, links, buttons that work as they should. It's about accepting that there will be bugs in your software. You know, I advise my clients, I say, look, you know, we've all experienced problems. Whether you're technical or non-technical, everyone has experienced problems in software. So we would be naive to think that every project is going to be perfect. There's going to be no bugs. So as long as the cost isn't too high, why don't we just accept that and prepare for it? We don't have to make sure everything works without JavaScript, just like our core functionality. So things like checking into my flights should be possible. We don't have to go cold turkey on our frameworks and libraries. You can still use them, but try and use things that, you know, are aligned with the web rather than, you know, not really working for it. Secondly, browser support. If I go back in time again, this is when I was at university, and you can see how slowly web browsers were releasing updates. Again, there might have been a few, you know, this might have been around the time of the evergreen thing coming in with Chrome, but you know, it was still very slow. This is today. Things move a lot quicker. So it's really important that you pay attention to how features are getting adopted. You don't have to wait for every single browser on the planet to support a feature. You don't have to wait for all of your user base to update to gain access to that feature. So developing against the lowest common denominator doesn't mean that you'll effectively sacrifice all the goodness that we can bring with these APIs that are designed to be more powerful, more performant. So if we can target significant portions of our user base, it might be Chrome only, and that might be, say, 40% of your traffic, but that's a huge chunk of people. So that's what we should be aiming to do. And then, of course, if we can target the rest of everyone using polyfills or shims or alternative code paths, then that's great too. You know, we can target as many people as possible. Obviously, we want to use the kind of platform-native optimized versions, but this will fill the gap until then. So, again, this doesn't mean making it work for absolutely everyone, especially regardless of performance impact. Some polyfills are quite significant in size. You know, we don't need to polyfill necessarily back to the Stone Age. Some will assume that you want IE8 support, but you don't actually need that anymore. So consider what a polyfill is doing. Similarly, you might only be using one API and not 20. So for the sake of one line of code, if you can get away with like an if-else and just do a different code path, that may be way more optimal. It means that your JavaScript is going to be a lot smaller and you're not maintaining another polyfill. Obviously, we try and load polyfills as optimally as possible in terms of detecting that browser support and only loading it if needed. But that's not always possible, so always make sure you're reviewing this on a regular basis as to what you still need to have in there. And again, this is about giving as many people in your customer base the best experience as possible. So, I don't have a wonderful ton of time, but I'm going to crack on as quickly as possible. So, back to those APIs. The first one that I want to mention is import maps. These had a lot of noise about them a couple of years ago, but then it kind of went quiet. Apparently, I checked this earlier, less than 1% of websites actually use these, but they're really powerful. And thankfully, Safari added support earlier this year in March in version 16.4. So you can now use it completely across all major browsers, and you can shim it for Safari if needed. So what does it do? Well, it effectively gives you a little blob of JSON that's a mapping between a file name and where to load it. It's as simple as that, really. You can see a couple of examples here. You drop this into your HTML, and then when you're doing an import just like this, it will actually transform that on the fly for you and load it from wherever that file actually exists. So I suppose this is one little note. You can load them from third-party sites. Please don't do this. Bundle everything into your kind of first-party site and serve it from there. But effectively, what this gives us is a better control over our caching and maybe a lower need to depend on bundling. So typically, without this feature, if you had a shared library that's used by 3 different files, obviously you could just load it on the fly. But if you wanted to kind of bundle this together, Harry's doing a talk on caching tomorrow, so I'm not going to go into this too much, but effectively you want to fingerprint all of those files. You're going to have a version number or a hash of the contents. And of course, if you update your shared library to version 2, that means that all of the imports need to be updated to version 2, which then means that all of those files need to be updated to version 2, and suddenly you've just wiped out the entire cache of your site because one library changed. So with import maps, we can get an improved cache ratio because we're not wiping out the entire cache in one go. You can have far more simple build pipelines, faster to get code out into production. There's a lower reliance on bundling. It can still be needed depending on how much JavaScript you're serving. Pat's going to be doing a talk tomorrow on shared compression dictionaries, which do help with this problem. And one of the great things that you get with this is better control over prioritization, because as soon as you bundle all your scripts together in one file, or in a couple of files, those files can only be loaded at one time, and effectively you have to serve that in the highest priority of any item within that bundle. So you may have something that's, say, powering a burger menu. That's pretty important to become interactive as soon as humanly possible. If you bundle that with a load of lower priority features, then you're suddenly loading a whole bunch of JavaScript way earlier than you needed to. Whereas if you have these individual files, you can load them as and when they're needed. You'll load a tiny little bit for your burger menu, and then you'll load the other features further down the waterfall. So ultimately, this is what your kind of build process output can be. It can be this simple. One little mapping and loading a couple of scripts. And the great thing is you have full control over just outputting these scripts as you want. If you're using any kind of server-side rendering, generally you can control just the output of these tags. You don't have to worry about the kind of masking between what you want out from Webpack and what it actually just spits out. The second architectural decision we made was to use custom elements. It's one of my favorite features. They're really well supported now. The adoption of them is rising massively. I think a lot of third parties have started using them, so it's a little bit muddy. But I definitely recommend using them. A lot of people get scared off, and I hesitated to mention web components specifically because everyone hears about the shadow DOM, and it's very scary. And there's terminology like the declarative shadow DOM and other things. So you probably don't need that. Most people don't actually need the shadow DOM. It's a great way to encapsulate if you want your CSS styling, for example, not to bleed in, to reference external styles that part of the rest of your page. That can be useful, but 9 out of 10 times you just don't need it. So with the light DOM, the DOM we're all used to, you can just simply wrap your custom element around any other elements, or it might just be its own standalone element. It looks just like this. One thing to note is that they have to have a hyphen in them just to differentiate them between the native elements. If anyone's used old school class components in React, this looks probably very similar to you, and that's one of the beauties of how they work. You don't have to worry about when a DOM node gets added or when it gets removed. The native API will manage all of that for you. All you've got to do is fill out these two methods. So when they get added to the DOM, the connected callback occurs. When they get removed, it gets called disconnected. Simple as that. So you can attach events in here, do whatever you need to do to initialize them. Just like React, you can respond to attribute changes, which is great. Simple API again. You just literally give it an array of attributes you want to respond to. If those get changed at all, then it's going to call that callback. You can actually make custom elements act like form elements. Again, very simple API. And one of the benefits here is that they'll get serialized just along any other checkboxes or input fields. And you can even participate in the native validation process as well. So it takes a little bit more code than this, but it's very easy to do. And in terms of our kind of progressive enhancement, there's a CSS kind of pseudo selector, I don't know exactly the terminology for that is, called defined, which allows you to style differently when an element has been connected versus one that's just come down in the HTML. So you can prepare, if maybe avoiding CLS problems, for example, you can prepare your aspect ratio and hold that space. Or it may be that you can actually get away with fully rendering all of your styles and then only changing some small parts when that's been connected. So if you've got for example, a button that activates with the JavaScript, you might want to hide those buttons before the element has been defined. So just to kind of summarize them, don't overcomplicate them. You probably don't need to use slots or the declarative DOM, declarative shadow DOM. Your custom element can just use query selector internally to reference its internal nodes and inner HTML to modify things. You probably don't need isomorphic rendering. I know everyone's kind of used to the JSX thing now where it's like, you can just write one component and it gets rendered in both places. But a little bit of duplication isn't a major problem. We've got some examples in a second that I'll show you where we rendered one thing in Liquid and then we had some JavaScript kind of enhance that. It's probably fine. I think we're all a little too afraid of any duplication at all. Things can be too dry. And if you do need that, then there are some alternatives. You can use libraries like lit or webc or enhance. Some great options there for you. So my first visual feature for you is scroll snapping, scroll linked animations. These are really exciting to me. So for years, we've had the kind of swiping on mobile, and I mentioned like janky, JavaScript, where you're kind of swiping across and it's like jittery. You can implement this just in 10 lines of CSS now. So progressive enhancement, so it'll just be a scrollable area, if the browser doesn't support it, but browser support is fantastic on this feature. 0 JavaScript required, and it's GPU accelerated, so you don't even need to worry about getting any more advanced than this. Don't worry about this CSS. This is just to show you how to implement it. All the slides are at that link just in the corner there, and there's a QR code at the end for you. But effectively, this is just to show how simple this really is. The only trouble is that this pattern doesn't work so well on tablet and desktop, where it just looks like an element's been kind of cut off if you're using the kind of card style. So I wanted to introduce these, you might see these little shadows on either side, just to give that bit of affordance that there's something underneath. So that's where scroll-linked animation comes in. And again, it's a progressive enhancement. I did have the slide just saying that WebKit are viewing this as something that they're supportive of. But literally, I think it was yesterday or the day before, I had to update this slide because they've just merged in the tests to support building this feature in, which suggests that it is imminent now in Safari. So again, progressive enhancement, few lines of CSS, no JavaScript necessary, though there is a JavaScript API if you do want to use it. And we can polyfill it just using an intersection observer. Here's another example of how you can use it. I've got these little indicators beneath each product, and you can kind of swipe left and right. So we wanted to show someone that there is 2 images. So it's a nice little use case for it. Again, very simple amount of CSS to do this, using the keyframe API. This has moved on since I actually created this slide. You might want to use animation range rather than using 1% to animate on. But you can see how simple this is. I think there's 2 new CSS attributes here. And when it comes to our custom elements, these are a great way to polyfill in support. We can just effectively leave them as undefined components for the browsers that do support these features. We don't need that intersection observer in those instances, so we might just use like display contents in CSS for the undefined version. That way they're effectively invisible, and it just renders as if the children are part of the parent node. And then yeah, we just enhance that to say, okay, well these are browsers that don't support scroll-linked animation, and the latter is only for those larger devices where they're on tablet and upwards. My second visual feature is view transitions. So I think a lot of people use single-page apps because they like the visual nature of these page transitions. It feels more fluid. And it's a massive trade-off. We kind of fight this problem quite often. All of the reasons I mentioned earlier are problematic with single-page apps. But no one likes having their toys taken away from them, and I kind of get that, which is where this API comes in. So there's kind of 2 variations of it. You can do cross-document transitions, or MPA transitions. This, we don't know what Safari or WebKit are thinking about. I think there were some problems as to, some kind of concerns as to how it needs to work. You do have to delay certain things from rendering in order to get that kind of smooth render between the 2. But you can enable this with just 1 line of HTML. There's 0 JavaScript required, and again, GPU accelerated, so you don't need to worry about the performance of it. It's literally this 1 line, a meta tag that you put in the head. If you want to get a kind of style as per the previous demo, you need to tag your elements as to which ones you want to transition, otherwise it'll just do a fade between the pages. And you can customize those animations again, just using the keyframes attribute in CSS as we're all used to. This is a slightly different implementation where it's an on-page transition. So this is someone filtering around. I'm not a fan of this animation really, but it's a good way to kind of illustrate it. And this is the single document version of this API. So this is more called the kind of SPA style. Again, progressive enhancement. It does require JavaScript because it is on page. And ultimately, if you're going to be fetching some content to load in, you're going to need JavaScript for that anyway. But you can customize it in just the same way with CSS, and again, you get that GPU acceleration. The API is really straightforward. You basically have this one line. This includes the fallback, so it's very straightforward, but there's one line at the bottom, start view transition, and you give it a callback. It'll effectively take some screenshots of before, do whatever updates you tell it to, and then animate those screenshots for you. So very straightforward. And you can actually somewhat patch this in to the browser itself for additional support by using the navigation API. So again, it's not supported in WebKit or Firefox at this stage. However, both have indicated that they're very positive about implementing it, and I've been kind of fighting that fight for a while. So you may have all heard of the history API. It's how a lot of single-page apps works today. But there's a lot of trade-offs with this. You've got to manually attach loads of DOM event handlers, to click and submit events. You've got to implement loading feedback, as I mentioned earlier. You've got to make sure you've got spinners or loading states somehow. You've got to implement announcements of page changes to accessibility tools, and you've got to manage that scroll position all yourself. Whereas if we use the navigation API, you have one event to listen on. It's a global event, effectively, for any navigation. You can decide whether you want to intercept it or not. Things like the can intercept here thing is just for refreshes and things like that. But you can have some conditional logic on there. You might only want to intercept certain URLs. And then again, you call it event.intercept, give it a callback. During that time, when that callback is running, the browser will show its native loading state. So you'll get the little spinner. The user will actually see something. You don't have to show something on the screen, although I'd still recommend doing that. You can go away, make a fetch call, whatever it might be, and then render that content back to the screen. And after that point, it will assume that it's done. So this is how you can patch in that view transition. Quite straightforward, right? Just literally that one line. And you can kind of get that single-page app-style behavior, but just using these very native APIs. So the great thing here is that it's decoupled from the DOM. You get that native browser loading state. You don't have to worry about accessibility tools because it manages that for you. And it handles restoring the scroll position for you. There's various different options for it, but it will do that for you with just one line. I'm running out of time. I'm actually on negative time now. So I've just got a couple more minutes. I've got a couple of bonus noteworthy mentions, things that I don't have time to go into detail on, but they're very straightforward and are great uses of the platform. So we use the dialogue element for a kind of light box zoomed in view of the product images. It doesn't show the zoom bit here, but you can kind of see how it pops out. We use the details elements for a kind of accordion view of all the details on the product page. And then we used CSS-based toggles and then enhanced them with JavaScript to provide some extra accessibility for the burger menu and the basket. And that meant that even without JavaScript, this would still work. It wouldn't be accessible as such, but at least we're getting that, that interaction works immediately as soon as that web page loads. There are a whole bunch, we didn't use all of these, but there are a whole bunch of really, really exciting things happening on the web platform. I encourage you to check out all of these different features. Just understand what they are. You don't need to understand how really they work or all the kind of syntax behind them. But next time you're implementing something, it might be like, oh yeah, actually I can just do this natively. So I suppose the kind of main takeaway here is use the platform, don't re-implement it. But you might have noticed I've kind of missed out on going back to those stats. So I'll just quickly cover those off. We took 55,000 lines of JavaScript down to just 650. And I'll refresh you on what Speak of used to look like. And bear in mind, the scale on these charts will change because it will look like things got a lot worse, but actually they did get better. This is the after. You can see that we no longer have problems with JavaScript. I know this isn't IMP, but it's the closest proxy we had at the time. And as I say, the scale of the chart did change to 3 seconds from 12. So while the purple bar didn't change on there and all the other bars got a lot worse, actually, relatively, it is better. So if you want to be successful working with the web platform, really understand your audience. They may be using different browsers to what you expect, different devices, and obviously different performance constraints. Don't limit yourself just to really well adopted features, sorry. Consider the standards positions of the browsers. You can see what they're thinking. There's various different GitHub repos for that. Consider the maturity of these standards. If you're going to adopt something early on, is it going to change significantly? And if it does, how much of a problem is that going to be for you? Is it very low risk to implement? If not, why not go ahead for it? And then consider how far back and how wide these polyfills need to be. And hopefully that will mean that you can give people a really great experience to, say the majority of your customer base and not impact performance too much. Thank you for your time. That's all I've got for you.
Ryan, come on over and perch here with me. I'm trying not to get emotional about the number of times you used the word progressive enhancement. I'm so happy to hear that phrase. It feels like it's such an important thing. I've been told I'm only allowed to ask one question because it was more important that we heard the content rather than hear me waffle on. So I would like to talk about lots of different things, but I'm just purely going to call out the number of exciting web APIs you mentioned there. It feels like we're getting access to an incredible toolbox, and it's replacing so many, I don't know, more roundabout, more convoluted way of getting access to some of these experiences. So I guess maybe just the one question I'd ask is about discovering those. How do you find out about the new or the upcoming web APIs, and how do you start learning about them? That's maybe the one thing we should ask.
Yeah, so I mentioned the standards positions of each of the browsers. They are open source GitHub repos, so you can just search for like WebKit standards positions or Firefox, or I don't know whether it's under Gecko, but yeah, so each browser's got a repo where they open issues on those, and you can obviously search through them and follow those repos. Web.dev do a great monthly roundup of new features to the web platform API, so definitely subscribe to that. And there's also the interop movement, who every year focus on a collection of different features and try and bring it to every browser. So again, I think they've got a GitHub repo, and there's a website for that as well. So just give it a little Google.
Excellent. And I recommend that people also, I see you've got the slides up there and a QR code to them as well, so people can get a bunch of resources from there. I'd love to chat more, but will you be available for people to talk to
I'll
up at the speaker table? Excellent. So don't forget to check out the speaker table, where you'll be able to find several of our speakers, including Ryan. So for now, join me in showing your thanks to the wonderful Ryan Townsend.
Thank you.
Thanks, Ryan.
Thank you.
Right then, okie dokie. How's everyone doing? Come on in, find yourself a seat. We'll get started. Was there a whoop there, or was that a scream? There was a whoop. Hooray! Okay, we are almost ready to go. While people are finding a seat, I want to share with you a magic trick. Yeah, now you're interested, aren't you? I need you all to help me with something. So what I want you to do is I want you to take your left hand, and I want you to pinch your left earlobe with your left hand. Everyone do that? Okay, now you can put that down again. Now I want you to take your right hand, and I want you to pinch your right earlobe. This is fun for me so far. I love it. One of you will have found that magically you're missing an earring, and that was my magic trick. So if you've lost an earring, you don't need to come and get that right this second. But so there's no shaming. But if you have lost an earring, come and find me at the end, and I have that for you. So worst magic trick ever. I can say, okay, don't patronize me. Don't. I mean, I'll take it, but it did seem a bit patronizing. But I got what I deserved. Okay, has everyone found their way in? Okay, I think we're ready to go. Are you plugged in and ready? Excellent. Tammy looks ready. So how lovely it is that we're now at the stage of the day we can introduce Tammy Everts to the stage. Tammy, aside from being co-chair of this conference and putting together this wonderful program of speakers and content for us to enjoy, she's also Chief Experience Officer at Speed Curve, and has done loads of work over the years. Sorry, that sounded like you really long in the tooth when I said that. I was emphasizing the amount of work, not the amount of years. Keep going, Philip. So much experience kind of researching how people use the web, how the experiences are influenced, and so much like learnings that comes from that. Also, of course, the author of the book Time is Money, the business value of web development, and we're certainly kind of acutely aware of how important that is. So, she's also pops up at lots of conferences. I've seen her kind of staffing stalls offering kind of free performance audits on people's sites and having people come along and say, help me, and she certainly does. And she would, in fact, I don't know if you're going to be doing that, but I know that Tammy's going to be at the Google stand tomorrow in the morning break, so you can chat to her there as well. But before that, of course, we get to hear from her right now. So talking about the performance impacts and on the changing, how it's affected by the changing tech landscape, which of course changes all the time. A giant round of applause, I think, please, for Tammy Everts.
Thanks very much. That's a really nice introduction. Thanks, Phil. Can everyone hear me at the back? Oh, thank you. So yeah, that's, there we go, getting the clicker to work. The slides is okay, readable. This might be a North American phrase. Who's familiar with this expression, work smarter, not harder? Okay. Years and years ago, maybe I am long in the tooth. Years and years ago, before I got involved in performance, at my first kind of big job where I had a large team and I was working as part of a big organization that I'm not going to name, there was a recession. It was the early aughts. There was a recession, as there is from time to time. We're in one now, arguably. And we cut people. Our teams got smaller. All of those things, all those recession things happened. And we were expected to do not just the same things that we had always been doing, but in order to kind of justify our existence, we were almost expected to do more than we had been doing before with fewer resources. And I had a really great boss at the time. We all adored him. But we were frustrated and we were getting burned out and things like that. And so we called kind of a meeting with him, all of us who were managers, called a meeting with him just so that we could kind of express how we were feeling at the time. And he said, these are tough times. I expect you to work smarter, not harder. And as I said, I adored this man. He was amazing. But it's the angriest I've ever been in a professional environment. And this was just me on the inside, just raging. It was like, to a high-performing person, and it's not a brag to call myself that. Everybody in this room is probably a high performer. To a high-performing person, being told to work smarter, not harder, is possibly one of the most demotivating things you can hear, because it implies that up until this time, you've been working stupid. And nobody wants to think that about themselves. So I promise that in this talk, it's not going to be about working smarter, not harder. I hate that expression. I banned it from my life. So this is me. If you want to find me on Twitter and Mastodon, this is how you can find me and reach out to me after this talk if you have any questions or some feedback or some suggestions. I'm always trying to learn from other people as much as I'm trying to help you with things that I've learned. As Phil said, I wrote this book, and I co-curate WPO Stats, which is a repository of web performance case studies. There are a few of us who work on that. Tim started it, Tim Cadleck, who's also a co-chair here. Very small world. So if you are interested in web performance case studies where we prove, or people prove, the business value or the user engagement value of any web optimization projects, it's a good place to go. And yeah, I work at SpeedCurve. We celebrate our 10th anniversary this month, as Mark mentioned earlier this morning. And I've been with the company for about 6.5 years, and I've been really, really lucky to help just like a lot of companies of all sizes, this is just a handful, to make their sites faster, and to learn how to make their sites faster, and learn how to keep their sites from getting slower. And the thing that I've learned over the years is that performance is hard. Yeah. One of the things that I'll just kind of go back for a second. So when I started working at SpeedCurve, we were still in the beginning of kind of like the bubble. Like things are always bubbling and bursting and bubbling and bursting. And so we were bubble. So teams were large. People had lots of time, money, resources for investing in performance, investing in new tools, trying out new things, really having kind of the mental bandwidth to be really experimental. And that's changed, for a number of reasons. Kind of the elephant in the room, in this room, in all rooms, when a conversation about the tech landscape comes up, is just, there have been layoffs. Teams are smaller. There have been reorgs. Org charts are really confusing, or you're just working with brand new people, or the person you used to report to, the performance champion in your organization, might no longer be with the organization. And also with so much remote working happening, maybe you're just not even seeing each other face to face anymore. So there's just a lot of things that have changed in the past 6.5 years that I've been talking to different customers. And of course, we have this like rapidly evolving tech stack, or rapidly growing tech stack. And of course, as I pull out this slide pretty much every conference that I do, more and more metrics, and people don't know what they mean, or why they matter, or what they measure. And so we're just really tasked with learning a lot all the time. And one interesting kind of thing that I just read recently is Sauce Labs recently commissioned a study, or like a poll, of 500 developers. And one of the interesting takeaways from that poll is that 77% of developers have assumed more responsibility for testing in the past year. That's huge, and I see that playing out in the conversations that I'm having, where we have a lot of new users, people who are brand new to performance, or brand new to performance testing and monitoring, and they're just trying to learn it all, in addition to everything that they're already doing. It's a lot, trying to juggle it all, trying to keep everything going, trying to keep it all in the air. And I want to talk about how to manage that juggling and how to create impact. So you're not just keeping all the balls or chainsaws or whatever it is you juggle up in the air, but you're actually making a difference. And the core idea behind this is to kind of sit back from your situation. And I remember reading this like a while back and thinking, this really resonated for me, was that problems for the company represent opportunities for you as an individual to demonstrate impact. And what that really means is to kind of like not just think like, oh, that's a problem, but to actually like identify unsolved problems and really run toward them. And what I mean by that is, Oh, sorry. I put this slide in here to remind myself to say to all of you, the thing to keep in mind about performance, and we say this a lot, is just keep in mind that you're running towards these problems, but you're really kind of like marathon running. It's a marathon, not a sprint, and you're just trying to do what you're doing at a sustainable pace. So you can define unsolved problems by asking yourself a lot of questions. Things like, am I looking at the right metrics? Are my optimizations working? Are the things I'm doing working? Am I reporting as effectively as I could be to whoever needs to hear reports? Am I involving the right people? Am I involving them at the right time? Am I motivating my team? Am I motivated? Which is a really important question to ask yourself. And if you're not asking yourself that from time to time, I definitely suggest that you pause and do that. Maybe not right now, maybe later. Am I proving business value? Am I making my company care about performance? These are all these questions are potential unsolved problems that you can kind of sit down and ask yourself. And the reason why it's important to embrace this idea of chasing impact is that it's really a healthy mental model for your career, yes, but just in life to chase impact. It challenges your comfort zone, and it treats your skills as a means to an end, so that you always can feel, even on a hard day or a hard week or hard quarter, that you're working towards some measurable goal, some real outcome, something you're trying to improve, the impact that you're trying to create. What I'm going to talk about today is how to simplify that and how to recognize the fact that in this increasingly complex landscape where we are ironically sometimes working with fewer people and less time to do the things we need to do, how can we do this as easily as possible? And that kind of boils down to a bit of simplification. And I really believe in easy as a goal. And I don't think it's necessarily something we're going to get to overnight. But if you're not always asking yourself, how can I make this easier? How can I simplify this? You might be not doing yourself any favors. And so a couple of things to kind of think about and that I'm going to be talking about for the next little bit is just this idea of don't do the hard stuff until you've done the easy stuff. And if you're doing the hard stuff, make sure that the hard things you're doing are actually making a difference. Otherwise, you're kind of wasting your time. And those might sound like common sense things to say, but common sense, as probably most of us know by now, is actually kind of uncommon. We can get kind of so deep in the weeds of what we're doing and really down into the kind of nuanced bits and pieces of what we do day to day that we forget to ask ourselves, is this actually, am I doing the easy things first? And is what I'm doing having an impact? And there might be some of you for whom the things I'm about to say are you're going to say oh, I'm already doing that, and I'm doing that, and I'm doing that, and I'm doing that, and you literally check off all the boxes. To which I say, if this is you, if you are that person who's checked off all the boxes of things I'm about to say, please come and talk to me. I would like to know how you're managing to do it, and maybe you need to be on the stage next year delivering a case study. So the things I'm about to say are going to sound like common sense things, and hopefully as you're hearing them, you're like, oh yeah, obviously I should be doing that, or obviously I am doing that. So the obvious thing, focus on what matters. But how do you define what actually matters? There's this meme that's been going on for a long time. Optimize all the things, whatever, all the things. And so quickly, just a little quick shout out. Everybody cites this meme, but nobody actually cites the source. This is a really amazing book, and this is a total tangential book recommendation. You read this book if you like laughing. I definitely recommend it. So you have to take a photo. Ali Brosh, she had a blog. It got turned into a book, and that book was so amazing. She wrote a sequel, and it's laugh out loud funny. So focusing on what matters. This is a waterfall chart. Most of you probably know what it is. For those of you who don't, it's kind of, I explain it to people as basically being kind of like a Gantt chart, but for your page. You're just showing all the different resources on the page as they render. And it's kind of showing top to bottom. You can see this is a page. You can't see actually in maybe you can if you've got really good vision. This is a waterfall chart generated from synthetic test of the IKEA.com homepage. And I'm not picking on IKEA. This is actually a pretty fast page, so I'm not here to name and shame anybody. It's like good vibes only. So this is, nevertheless, a waterfall chart that has a lot of resources on it. So well over 100 resources. And what you might not be able to see is this bar right here that has the little the little yellow tags on it. That's showing where largest contentful paint is happening. And I kind of pick largest contentful paint because for this particular page, it's a metric that aligns with what users would see in the viewport in terms of really important content. So this is a lot of stuff. It's a lot of stuff. And if you were trying to optimize all these things, you would be working really, really hard and maybe not necessarily seeing any impact when you would expect to see impact. And the reason why is because all of these grayed out bits that happen after LCP don't necessarily matter as much as you might think that they would. The things that matter are the things that happen up to, sorry, I'm going to just like step back for a second. The things that matter in terms of helping users know that they've landed on a page, the page is performant, the page is like the right page they want to be on because it's showing them a picture of something they expected to see or wanted to see. So it's meeting that expectation. There's other things that are happening behind the scenes where you want to make sure the page is actually properly interactive. It doesn't just like appear, but it actually can function. But for our purposes right now, we're going to talk about making sure the page appears to be performant in rendering. So none of these things matter. So suddenly the waterfall, if you eliminate this grayed out bit, it's a much shorter list of resources. And 56 in total, which seems like a lot. And I've kind of like counted them all out for you. And you can see that there's a fair bit of blocking CSS, some blocking JavaScript, some other JavaScript, some images, and some custom fonts. So once you've funneled your list down into everything that renders up to a certain point, you see that you're kind of it's a way to kind of manage what you need to do. A couple of people have talked about the critical rendering path today, and I'm really, really happy to hear that this concept is being revisited. It's not a new idea. Ilya Grigorik talked about this and kind of popularized the idea 10 years ago. And the idea of the critical rendering path is that you're prioritizing the display of content that relates to the current user action. And it seems like, again, a really common sense idea, and yet we've fallen away from this. I see many, many, many waterfalls where there's a lot of non-critical content that's in the critical rendering path. And so I invite you to think about what's the critical rendering path for your own site, and what are the resources that you can get out of that critical rendering path. There's a great article you can read called The Fight for the Main Thread that just came out on Smashing. And in it, Geoff Graham, he talks about the main thread, defines it as a concept, and a few people have talked about the main thread today as well, so I won't kind of go into all of that again. But he does a really great job of breaking down not just what it is, but what are the elements that get in the way of that main thread activity. And he focuses quite closely on third parties, and doesn't just like kind of break it down and do an analysis of like, okay, this is what's blocking the main thread, but provides a lot of resources and kind of best practices and tips for actually doing the optimizations that you need to do there. So the purpose of my talk isn't to tell you what all of those things are, but I'm kind of like more of a traffic director. I want to kind of get you to the resources that you need. The other thing to think about when you're focusing on what matters is keeping in mind that not all pages are equal. And I did my undergrad thesis, I was an English literature major, which I don't know if a lot of other people here. Oh, thank you. Yeah, almost became an academic, just decided not to, thank goodness. Yeah, so I'm a big George Orwell fan, that's what I did my thesis on. And so, yeah, not all pages are equal, some are more equal than others. A few years ago, participated in some research on conversion impact scoring, and also something called activity impact scoring, where looking at RUM data, we actually figured out that some pages matter more than others in terms of being faster and their impact on conversion rate. Some pages matter very little. And it's kind of surprising. So for example, for a retail page, and this is looking at like millions and millions of beacons worth of data, the most important page to optimize is your product page. Least important page is search. Home is only kind of somewhere in the middle. And so if you're kind of starting at home because that's the first page and you're doing that, kind of making that mistake of reading your website like it's a book, which Mark warned us not to do, not to think about our sites that way, then you're kind of doing it maybe not in a way that's best for your site and for your users and ultimately for your business. So product pages, category pages, the pages that actually have the real meat of your site are the pages that matter. For a media site, article pages, search pages, department pages, those are kind of the more important ones, but primarily those article pages. Homepage matters relatively little. So if you're, this is I'm kind of pointing these out to help you prioritize what pages to focus on. Find the low-hanging fruit. And what do we mean by this? It's a pretty, common expression. As my colleague Andy has said on stages, it's the dull, boring stuff. It's not exciting, it's not sexy, but it's the things that are probably the most common issues on your pages. Scripts, especially third parties, images, extraneous code, and undeferred resources. The dull, boring stuff. I did an audit of frequently, I did sort of an inventory of the most frequent Lighthouse audits that were showing up on, we have an industry benchmarks dashboard that's public facing in SpeedCurve. So I went through the sites in the benchmarks dashboard and I just identified all the most common Lighthouse audits and they're here. And some of these have been discussed already today, which is great. And I'm not going to read them all out. But the most common one, if you go away and you only do one thing today, add your width and height attributes to your images if you want to improve CLS. And then there's a few others. One thing that I hope you can make out is that a lot of these are badged with the different Core Web Vital that they should help to improve. So you can see that there's a relationship between these audits and the actual Core Web Vital. So if you do nothing else, just take away this list, make sure you're doing these things on your own pages and see what that does for you. It's really important, and this is kind of going back to the dull, boring stuff. Small changes, really small changes can have a surprisingly huge impact on your site. So this is a US site called Priceline, and this is their homepage. And they presented a case study a while back, and actually Tim Cadlick interviewed them for the Chasing Waterfalls podcast. It's a really, really good podcast. It's several episodes from really interesting people. So this is from Malik Hakim, shared how all they did was they ran an A/B test where they shaved 15 kilobytes off their logo, and they increased bookings. This is just one optimization, because the logo, when you think about it, that's in your critical rendering path. And if it's something that's less performant or really non-performant, just making that one tweak can make a huge difference. Another example, this is another US, it's a retail site called Fanatics. They sell sports gear for sports fans. And they did a few very basic optimizations, like they did some image compression, they deferred the sprite that was blocking the critical rendering path, and they optimized some CSS and JS on the critical rendering path. And what happened for them, just with these three kind of groups of optimizations, they had a 2-second improvement in the metric that they were tracking, which was load time, and they almost doubled their mobile conversions. So again, it's not necessarily the big things. It's really important also when it comes to focusing on the right things is managing people's expectations, including your own. So I think it's really easy to feel like you have to do all the things, you have to do everything well, you have to do everything right away, and you have to make big changes to see big impacts. And so I'm going to kind of read this because it's a little bit of a mini essay from Dan Goel at Crate and Barrel. I don't know if this helps anyone, but one thing I've been stressing to our dev teams at Crate and Barrel is this. we're not trying to speed up the website by 500 milliseconds. We're trying to speed up the website by 100 milliseconds 5 times, or 50 milliseconds 10 times. There's more. Getting teams to think incrementally has proven to be more effective than trying to do everything all at once. It's less stressful. It's faster to implement. Everyone, including product managers, seems to just get it. Smaller projects get more buy-in than megalithic projects that span multiple sprints or multiple teams. So I think this was a really interesting kind of takeaway, because it's really easy to get caught up in this idea that you have to take on these really big, as dances, like megalithic projects where you're going to do some big performance sprint and you're going to try to get all the things done, and instead focus on small incremental changes. And as he says, it's not to say that large structural issues shouldn't be addressed someday, but while you're waiting for someday to come around, you can do what you can right now to improve in smaller chunks that ultimately add up. So again, it's not a super sexy, exciting takeaway. It's very small and unsexy, but ultimately really effective. Another really important thing to do in terms of just managing expectations is to understand your performance plateau. So your performance plateau is the point at which, even if you're making improvements to your pages, you're not seeing any impact or any really noticeable impact to things like conversion rate or to bounce rate. And the reason is because you've bottomed out in terms of business and user engagement metrics. So what that means is, there's a couple of charts. This is a correlation chart where you can see LCP in these cohorts in the histogram, and then bounce rate is the blue line that's kind of running across there. And what you can see is how bounce rate goes from almost 50% at 0.5 seconds to 84% at 9.5 seconds. And that whole trajectory is where making changes is going to have an impact on your business or UX metrics. If you look beyond that, you see that's your plateau. And so you can make your page, if you have pages that are 16 seconds, which I hope you don't, and you get them to 10 seconds, and you think, wow, we just did a lot of work. We shaved 6 seconds off our load time, and yet it did make a difference in what we're doing on the business side of the UX side. That can be really disheartening. And this is why you need to know, using your RUM data, what your plateau is and what you need to do to get off that plateau into that trajectory where you're making a difference. And it varies from site to site, which is why you need to look at your own data. These are not benchmarks that you should be aiming for. This is another correlation chart where you can see the plateau comes in a lot earlier at like 2.5 seconds. So it really does vary from site to site. Fighting regression. While you're doing the things that you're doing to make your pages faster, you really need to keep an eye on not making sure your pages aren't getting slower. And again, it sounds like a really obvious thing to say, but it's amazing how many times I speak with people who aren't implementing tools, strategies for doing this. This comes from that Sauce Labs poll that I mentioned earlier. 67% of developers in that poll said that they push code without testing first. Only 33%, like 1/3, are testing their code changes before they deploy it, or at least at deploy. And this one kind of blew me away. About 60% of developers are pushing ChatGPT generated code without testing it. And I don't, like, I'm not here to diss ChatGPT. I think there are advantages to it, and I know people who use ChatGPT well to generate code. It's just this idea of pushing untested code is a little bit like, whoa. But it boils back to what we were talking about earlier, the fact that 77% of developers have assumed more responsibility for testing. If you're taking on that load, something's got to give, and maybe some of that is that you're just not going to test everything that you push live. So I'm sympathetic to that as a real problem. I really like this quote from Renato Sinahara at West Wing. My company used to do focus weeks for performance, and I found that to be ineffective. So we now have a continuous process for monitoring and improvement, and it works much better. I'm not going to read all of this, but basically, in this, he talks about a few different strategies for what people were doing, like just frequent monitoring, having meetings, just this idea of integrating your performance testing with it's just your continuous kind of development process. And this is where performance budgets come in. And so I'm not going to ask people who's using performance budgets, but who is familiar with the idea of performance budgets? Okay. So that was about half the group. I did a talk on performance budgets last year, and it's a really important concept that I feel, again, everybody's really busy. It's taking on the additional load of learning about how to use a new strategy can be time-consuming, but it is. Once you've grasped the concept of performance budgets and you've put them in place on your own site, it's the easiest way to make sure that you are automating how you make sure that you don't push performance regressions onto your live site. And so what is a performance budget? Well, it's a threshold that you set for whatever metrics are important on your own site. So this is an example of one that's on CLS. And what a performance budget allows you to see is, A, what your budget is that red line, and where you go in and out of bounds. And so in this case, you can see the budget got violated a bunch of times, and it kind of stayed above the threshold for a prolonged period of time. It's really important. Oh, and if you go to the link, it's just a guide to performance budgets with a lot of best practices in there based on the talk that I did last year. It's really important to keep in mind that a performance budget is not a performance goal. It's great if you want to have a start render of 2 seconds because that's how fast your fastest competitor is, but that's just something to work towards. It's not your budget. Your budget is something that you put into place to fight regressions. And the great thing about performance budgets is that you can automate them and you can integrate them into your CI process. You can create performance budgets. Then once you make any changes to your code or your content, it can trigger tests. You can set up the testing to happen on your dev site. You can maybe, and you can even have your budgets set up so that you break the build and you don't push non-performant code to your live site. So there's a lot of kind of wiggle room with how to implement performance budgets on your site. But if you're not using performance budgets right now, I really, really can't urge you strongly enough to do some research and figure out a way to do that, and to do it in a really accessible, easy way. Even if you're just figuring out what is one metric that matters, start render is a good one to start with because it does often correlate to meaningful user outcomes, business metrics, things like that, and because it's available in Raman synthetic, and because it's supported by all browsers. So I really do recommend that as something to consider. And the way to think about performance budgets is and performance budgets and how they work with your CI process is that your performance budget is kind of like having a motion sensor in an environment you want to have secure. So if something unsafe seems to happen, something unfamiliar enters the room, the motion sensor goes off. And that's great. Integrating it with your CI process and automating it is like having your motion sensor then send a SWAT team into your environment to get the bad guys out of there so they don't do anything. So I really recommend it. And as I said before, I'm a big proponent of MVB, minimum viable budgets. So even if it's, as I said, just one metric and you're just experimenting with that, I really encourage you to do that. It doesn't have to be Core Web Vitals. That can be something to start with as well. The important thing is to go back to, say, your synthetic tests where you're able to generate visuals like film strips and line up whatever metric you're looking at, whether it's start render or any of the other metrics, with the film strip to make sure that it actually lines up with something that is visible in the viewport. I did an audit a little while ago of a bunch of different metrics and kind of the pros and cons of each. I wish that there was one kind of perfect unicorn metric that I could point everybody towards. But this is kind of me auditing a bunch of different metrics, common metrics, and maybe some less common ones like last painted hero or long tasks, which you might have learned more about earlier today. But these are metrics for you to explore and kind of test in your own environment. Make sure that you share the load. And this is a really hard thing to do, especially if we're really busy. And this is kind of like, I find it sort of one of those things that if you're a person who in your day-to-day life just feels like, well, if I want it done right, I should do it myself. Or if everybody else is really busy, so I'll do it myself. We can always make reasons for why we're going to do it ourselves. We don't have the time to teach other people how to do things. There's so many reasons, but I really encourage you to find ways to share the load with what you're doing, even if your team is much tinier than it used to be, even if right now you don't feel like you have a team, if there's just one person. Everyone who touches a page should care about the performance of that page. Everyone, not just developers. I like this, it's another podcast interview with, this is with Dan Chilton, who used to be at Vox Media. And he said and his performance team at the time was that they didn't want to set themselves up to be performance cops, but they did want to involve people throughout the organization and create multidisciplinary teams. They didn't want to slap people on the wrist saying, you did a bad thing. They wanted to help people to basically set up best practices, teach people about those best practices, set up systems, teach people about those systems, and then ultimately make people responsible for the systems and make people excited about the systems, whether it's a performance budget or anything else that you're doing in terms of your performing or your monitoring. So it's really important, as hard as it is, to give people ownership. So for example, if your marketing team is responsible for adding and maintaining third-party tags, you should, logically, make sure they understand the metrics that those tags affect, such as long task time. You should get them to collaborate on setting the budget. They should receive alerts, not just you, when the budget is violated so they can know when that's happening. And they should at least have visibility, even if they're not directly involved, in making the fixes that they need to make to fix your long task time and get that non-performant third party out of there or make it better. Also, you need to have a champion higher up. And I can't stress this enough. If you need to have somebody who is at the highest possible level of seniority in your company who cares about performance, and you need to help them understand why they care. And often that comes down to talking about the business metrics that your site has direct impact on. So find that champion, and having a champion higher up in the organization will make your life so much easier. And so I find that that's actually one of the things that when I talk with people over the past year or so, they've lost their performance champion due to reorgs, due to people leaving the company, that sort of thing. And if there's one thing that you can do for yourself to make your kind of just your work culture, your performance culture at your company better, it would be to find that person. You need to measure success. Again, this is from the interview with Malik Hakim. We as engineers should learn how to show the impact on anything we do. So for example, if you have a competitive benchmarking dashboard, you should be able to quantify. We moved from 6th place to 3rd place in our competitive dashboard. This is what a competitive dashboard can look like with film strip views that are stacked in order of, I think this one is stacked in order of start render. And moving up the leaderboard, having a leaderboard like this and this has been a feature that's been available in web page test and other tools like SpeedCurve that are built on our own instances of web page test, but it's a really incredibly valuable tool to be able to kind of show people in your organization where you rank compared to competitors or where you rank compared to the kind of best in breed retail sites. Or we optimized or removed a third party and reduced bounce rate from 87.5% to 62.1%. Harry did a really great case study in a presentation he did here at perf.now in 2019, where he just showed an A/B test where they were experimenting with a third party, and that's where I got that particular stat. If you are not running A/B tests, and I recommend that you consider doing that, there are a lot of resources and case studies that you can find at this URL and just kind of looking online. But just be the ability to do A/B tests so that people in your org can see, you know, we changed one thing on our page, like we deferred some third parties or we optimized an image and we saw some very tangible, measurable change in our business metrics, not just in our performance metrics. Or we improved LCP by 0.8 seconds, and we increased conversions by 4.2 to 5.3%. These, again, based on real case studies. All of these things are very measurable if you're using synthetic and RUM tools together. And if you are tracking conversions and, or even just bounce rate. Conversion tracking is a little bit trickier because you have to kind of bring in conversion data, but you can at least create correlation charts using bounce rate because that's available in RUM tools, or most or all RUM tools right out of the box. It's very easy to measure. And often if you can, I've looked at a lot of correlation charts. Generally, you can use bounce rate as a proxy for conversions. If you're making UX better for people and improving bounce rate, you're almost probably improving conversions as well. Or you can even just say like what you prevented. We prevented 3 regressions to LCP from going live, and based on what we know about LCP and its impact on our conversion rate, we prevented a degradation to conversion rate. So just celebrating things that you stopped are really important as well. And when I say celebrate, I mean, I don't know what celebration looks like to you, but a common problem with high-performing people is that we do these hard things and we don't pause and look around and congratulate ourselves for doing hard things. We just move on to the next hard thing. So you wouldn't climb a mountain, get to the top, and then just be looking at your feet the whole time and then just be like, okay, well, I guess I'm just gonna go down now. Like, you would stop, you would take some pictures, and you would, pat yourself on the back or give yourself a hug. Do those things in your performance work as well. And that can take a lot of different forms depending on what kind of feels authentic and enjoyable for you. So it can take the form of just, I love this one from Nicholas Hawazi. He just posted like this boring chart because his CLS is 0, which is great, it's achievable, and it stayed 0. Fantastic, that's a win. And he posted it on his blog and on Twitter, and I loved it. You can ring the bell for other people as well. Sometimes people aren't great at kind of shouting their own victories out. Most of us aren't. So do that for other people in your team. At Etsy, I don't know if Etsy still does this, and there are a few folks from Etsy here, so maybe we can ask them at one of the breaks. They used to have performance heroes, and they would kind of like shout out, and they would broadcast on social media who their performance hero of the month was, and they would be really specific about it. This person removed a non-performant piece of JavaScript, or this person figured out a way to fix some image optimization, and it made a big difference in some metrics that we care about. And it's really cute. And I like that there's a little certificate that you get. You can write a case study if you've got the time and the wherewithal, and then you can send it to WPO Stats, and we'll post it there. And that's a great way to celebrate some wins as well. At SpeedCurve, we have a Slack channel called Ring the Bell, and we post anything there. If we're proud of it, we're excited about it, it's a ring the bell moment, we post it there. And so you could even just do it in your own Slack. And it's one of my favorite channels. So just to sum up, how to increase your impact: identify your critical rendering path, focus on it before you focus on other things. Focus on the pages that matter. Fix the low-hanging fruit. Manage expectations, other people's expectations, your own expectations. Definitely, please use performance budgets to fight regressions. Otherwise, you're doing all this work on optimizations over here, not realizing that, if you're lucky, maybe you're just leveling things out because there's degradation happening over here, and you're not going to understand why your optimizations aren't making things better. Quantify your successes so that you can brag about them, so that you can build performance culture in your company, so that you can increase your level of championship from kind of management and executive levels in your company. You really just need to be able to quantify things. And those kind of brag statements that I shared earlier, like, we fixed this metric and we made conversions better. Those are just simple statements you can use and should use because they're things everybody can get behind. So there's no magic at all. It's very simple. I know the work is actually hard when you actually have to do it, but the principles, the first principles to come back to are just that you need to have a plan, show up every day, do the work, be patient, and while you're doing that, just be really kind And I think of kindness as having, it's really an umbrella concept. You want to be kind to your teammates and support them in what they're doing. You want to be kind to your users by delivering, hopefully, delightful, joyous user experiences. And really be kind to yourself, because I think it's really easy when we're in tough times as we are right now to be really, really hard on ourselves and to feel like even, treading water and staying in place isn't enough. Sometimes treading in water and staying in place is enough, and it's great that you're doing that. So I just really want people to keep that in mind as well. So thank you very much. Thanks for having me. And I can't resist citing sources, so here you go.
Thank you, Tammy. Thanks so much. How do you feel about perching over here?
I feel like I'm going to climb a mountain.
Oh, look at
maybe,
this. Using the step. It's bold.
No, I'm not going to do that. I'm going to be a leaner.
Okay, well, I'll lean as well. I'll lean, and we can both be jaunty. Thank you for such a thoughtful talk. I love the level of thought and like the care that goes into a talk like that, because it's very easy. I mean, I've done this in the past. I've done lots of finger wagging and saying, "Oh, we should do this. We should make this better." And I think your message at the end there is really a valuable one. So that's less of a comment and less of a question and more of a comment. We thought we were done with those, didn't we? Okay, but actually onto a question. You kind of talk about running towards the problem, and you talked about asking yourself, am I making my organization care about performance? And one of the things that I've always found difficult is how to make the right stakeholders care about it and how to raise the visibility of those things. So I'd ask about that, and I guess as a bit of a run-on, I'm going to combine this with another question which came in, which talks about case studies and says a lot of case studies cite really high impact numbers. Iron customers struggle to trust them. So how do you know what's real and what's just sliced and cherry-picked data? So maybe those questions, I don't know, maybe relate to each other a little bit, but there we are.
I'm a little jet-lagged, so I already forgot your first question.
Okay,
I'm not good with two-parters, I guess.
That's fair. How do we make stakeholders care about performance in the first place is the big part.
Yeah, well, actually, and the answer to that kind of does sort of answer the second question as well, which is that it's really hard to get people to care with data that isn't your own. So this is where other people's case studies, that works for some people just to kind of capture their interest, but to hold their interest, you're really going to want to get as quickly as possible into looking at your own data. So learning how to run an A/B test on your own site, and learning how to create a competitive benchmarking dashboard, for example. Right. So just all of those things. And figuring out kind of what are the metrics that matter to the person that you're speaking with. Right. I didn't really kind of go into a lot of detail on this because I feel like I've talked about this a lot in other talks that I've done. But there is a UX or business metric that matters to every person at your company, whether they care about performance or not, or whether they think they care about performance or not. They care about bounce rate. They care about user retention. They care about page views if they're a media site. They care about SEO. They care about all of those things. And so you have to tailor the metric that you are focusing on as an outcome metric to the person that you're speaking with. And then I also firmly believe that you can find a performance metric, and it's usually one of the metrics that I mentioned before, like start render, or some of the more UX-oriented metrics, like maybe LCP or last painted hero, that really, if you create a correlation chart using your own data, you can see that there's a really strong correlation between that metric and user behavior or conversions. So it really just does come down to the fact that you need to have your own data. And I hear all the time, like, well, why would I believe a case study that somebody else has done? Maybe they are cherry picking their data. Nobody believes in it until they look at their own numbers.
Right. Yeah, and maybe that kind of other data, that cherry picked or that other case study data, might not be a good instigator for actually doing the work, but it might be a good instigator for, well, let's look at our own data and prove it. So that's
exactly.
Yeah, I mean, I'm still blown away by the 15 kilobyte reduction in just a logo.
That was an A/B test. So it's and the reason why how many people here actually are do A/B tests, like performance related A/B tests? So a few. Quite a few, not most. So what I love about A/B tests is the fact that you are basically testing the same page with some variable change in the same time frame. So it's not oh, well, you know, we did a performance sprint and we made some metric better and conversions improved, but it could also be because we did some kind of ad campaign that happened, you know, during this part of the, you know, the phase of operations, like after the sprint, or the content changed, or the offer changed in some way. So doing A/B tests or multivariate testing is really kind of the way to go if you really want something kind of meaty that people can believe in.
Right, and that seems to marry quite nicely as well with that wonderful bit of advice about, you know, we're not going for 500 millisecond improvement. We're hoping for, you know, 50 millisecond improvement 10 times. And because, you know, if you're going for a smaller change, that's probably easier to test and easier to measure and kind of isolate, I suppose. A question I did have about that is how do we make the impact of that visible as well? And because that is something that I guess happens over time, gradually. And so again, like making these reports visible and taking those to the right people seems like a really important thing to kind of get the buy-in to continue that work over a long period of time.
I think it's almost like what you don't want to do. So what you don't want to do is show people a million charts or spreadsheets or things like that. It like really does come down to like, what is that impact statement that you want to say? And you should obviously have all the data you need to kind of back it up, but most people don't want to look at charts. Like, I mean, everybody in this room likes charts, but people outside this room don't. So you know, making things as simple as possible, not obfuscating the very clear win or goal that you have with a lot of other stuff. So yeah.
Nice. You're definitely right about this room loving charts. There was an audible intake of breath at the point that you put Nicholas's chart up with the straight line, where haven't broken it yet. Amazing. I feel like there are so many more questions I'd love to ask you, but we're kind of out of time. So you're around for some of this evening and tomorrow, and
I'm here. I basically live here for the next.
There you go.
Like
Tammy basically lives
yeah.
here, so you'll be able to ask your questions directly. Tammy, thanks so much for a wonderful talk and for hanging out and chatting a little bit as well. Big round of applause, please, for Tammy Everts. Okay, so we are approaching the end of the day, but fear not, we do have another talk before we wrap up. So I'm going to be able to introduce Robin in just a moment. A reminder, again, of course, that we do have a social this evening, which is going to be right here. I'll tell you a little bit more about that in a few moments, I think. And of course, we've got a whole other day tomorrow as well, so there's plenty more to come. But for today, you know, we are going to be rounding off the day with Robin Marx, who is a web performance expert at Akamai. Robin's traveled to us from Hasselt in Belgium. Is that still right? Is that still where you're based? Hasselt, Belgium, and so hasn't had to come too far, but no, still it's a journey. We're very happy to see him here. A web performance expert at Akamai, as I mentioned, and I know that Robin gets deep into the weeds in protocols and optimizing things, and really, he goes to the places that I'm glad people do that I don't have to, because it gets way deeper than I would ever be able to comprehend. And is also a contributor to the IETF Quick Working Group, and in this talk, I think we're going to hear some things that are a little bit deep, but also relaying them to real-world examples and real-world usages, which for me always lands the point much better. If we can talk about things and how they're actually applied in the real world, it's always really valuable to me. So talking a little bit about using kind of tools and insights correctly, this title, Resourcing Loading at the Cutting Edge. You good? You plugged in? You happy?
So.
He thinks so. All right, let's make him certain of that by giving him a giant round of applause. Welcome him, please. It's Robin Marx.
All right. Hello, everyone. I am Robin, and there we go. I'm Robin, and really the only reason that I am speaking here today is because of a misunderstanding. You see, when they asked me to come talk about cutting-edge networking, I thought, well, that's interesting, because in my free time, I am actually a longsword fencer, a sport called historical European martial arts. So when I heard cutting edge, I thought, well, that's right up my alley, right? You can imagine my disappointment when it turned out that when you guys say cutting edge, you mean the latest and greatest, not that I would get to play with swords. Now, luckily, it all turned out well in the end, you know, because I do happen to know a little bit about this stuff as well. And as you can see, we are very spoiled nowadays, right? These are all network performance features that have come out the last 2 years. And just looking at this, you might think, oh, networking performance is in a very good state right now, right? I don't actually agree with that. My opinion is a bit more like this, or to be very accurate, maybe this, and I'm at night in a flaming room saying, this is fine. My goal today is not really to convince you that I'm right, it's just an opinion. My goal is more to explain to you why this is my opinion, so that maybe we might have a discussion about it afterwards. I'm going to talk a lot about priorities today. If the clicker is working. There we go. Priorities today. You might notice if you go into the browser DevTools, the networking tab, each resource has a priority associated with it. So it has something to do with resource loading. Question is, why do we need these priorities in the first place? Well, it all has to do because bandwidth is not unlimited, right? If you have a 5 megabyte page, it's not going to load instantly. It needs some time on the network. And especially if a new connection, it begins in something called slow start, right? It can only send about 14 to 50 kilobytes in the first round trip. This then doubles the second, doubles again the third. We don't need to know the details today. The only thing we need to know is that at the beginning of especially a cold page load, the amount of data we can send is very, very low. And so we need to be smart about what we actually send. So let's say we have a server that it can send 200 kilobytes. On HTTP 2 and 3, it will probably have received several requests on that one connection. So how will it fill these 200 kilobytes? You might say, Robin, that is very easy. It's just going to send the parser blocking JavaScript, right? Very important. The question then is, how would the server know that this is actually parser blocking, right? It could have been tagged as async or defer by in the HTML. And in that case, it might make more sense to send the CSS or even the image. The answer there is that the server can't know this. The server does not have this context. The only entity that does have this is, of course, the browser, because that is what parsing the HTML and seeing all these hints. So the browser somehow needs to communicate to the server in which order resources should be sent. Now, we don't want to send all of this detail. That's way too complex. So we need a kind of like a high-level signal just to let the server know in what order stuff should be sent, right? And that is exactly what these priorities are supposed to be. High-level signals from the browser to the server. And here the server can just say, OK, I'm first going to send all the highest priority stuff, then the high, then the medium, then the low, and so on, right? Very simple concept. Now, you might start thinking, well, how does that actually work internally? What is the mechanism, right? If you would have to design this yourself, you might come up with something like this, right? Just use an HTTP request header. Very simple. In practice, slightly more complex. Especially for HTTP 2, we have this thing called the prioritization tree, where the position of the resource in the tree determines which bandwidth it gets and when. Some have called this an elegant system. I like to refer to it as a Lovecraftian horror that sucks all the joy out of my life. It's terribly complex, very buggy in most implementations, as we'll also see later. Which is why for HTTP 3, we actually decided to do it a bit more easy. So again, this is just a HTTP request header. Slightly more complex, though. We have two parameters. The first one is urgency, which is the U, which is basically the priority, but numerical. Where 0 is actually the highest priority, and 7 is the lowest priority. So it's inverted, right? Remember that, because you're going to need that later. Urgency is really exactly what I explained before. You expect the server first to send everything with an urgency of 0, then 1, then 2, and so on. That makes sense. There is, however, a second parameter there called incremental, which is a Boolean, true or false. What this does, let's explore. Simple example. What happens if the Boolean is false? We have 3 resources, the same urgency. What this would mean is that the browser expects the server to send them in request order, right? So download the first one fully before moving on to the next one. I'm going to be calling this a sequential behavior next. This is very different from if that incremental Boolean would be true. This is basically telling the server, you know what, I want you to start sending these resources in chunks. Send a chunk of the first, then stop, move to the second, the third, and then go to the first one again. Basically, you're getting a little bit of bandwidth sharing between these different resources. This is useful in a number of use cases. For example, let's say you have a lot of very large resources and a lot of smaller ones after that. If you do that sequentially, you will actually end up blocking the smaller resources behind the large ones. And so in this case, it might make sense to do this. The smaller ones get in much earlier because they get a little bit of bandwidth at the start, right? Another use case is because a lot of file formats can actually do something useful when they're even partially downloaded. So images again, most formats can be loaded at least top-down, or in the case of like progressive JPEGs, you might start with a low-quality version first, which then gets better as more data comes in. So this is very useful for some use cases, but it can also be very bad for others. Specifically, JavaScript, CSS, and fonts need to be fully downloaded to be used. They can often be parsed or compiled incrementally, but they need to be 100% there before they're actually executed. And if you would load those types of resources incrementally, you might actually be actively delaying when that happens. So you should never do this for these types of resources. Spoiler alert, that's of course exactly what happens. Now, this is the theory. Before we go to the practice, I would like to invite my colleague, Tim Verreke, to the stage. If you didn't know, Tim is actually also a speaker here tomorrow. Now, please don't tell Tim this, but he is kind of an annoying colleague. Tim is often very mean to me. So today I'm going to teach Tim a lesson. Because Tim, tell us, how much do you know about sword fighting? Nothing. Perfect. Right, because Tim, I'm going to show you 3 different sword fighting styles throughout the ages. We're going to start in the the only thing I want you to do is very simple. One of the most basic attacks you can do. You saw on the right shoulder. And you're just going to throw me a diagonal cut towards me like this. With a step, Tim, with a step. Very important. There we go. He can follow basic instructions. Excellent. So Tim, as you can see, 16th century, by then, sword fighting was actually already a bit of a sport, right? It was mostly to show off, which you can see in the puffy pants, and also the fancy stances that they used to take, right? So in this style, if Tim would attack me, do the attack again. All right? What I would probably do is I'm going to beat away his sword, very cool, like this, and continue to swing and hit Tim in the face with the flat of the blade. Because my aim is to maim, not to kill. That's different in the 15th century. 15th century style, if you would attack me with the same attack, with a step. There we go. I would probably catch it like this. I would then do something which is called a winden, which is used to give me more leverage on the blade, after which I can put my point online and stab him in the chest. Right? Very efficient. The 14th century, this is real battlefield stuff, you know, very practical. In that style, if Tim would attack me, right, I would also block probably like this. But then I would say, Tim, what a nice knee you have. It would be a shame if something were to happen to it. So this technique is you kick the knee, hopefully breaking it, which will cause him to buckle, which leaves me free to revert my sword, use the pommel to knock out most of Tim's teeth. Okay? So Tim, I hope you've learned your lesson. You can go sit back down. Thank you. Oh. Thank you. Now, if you think I was being a little bit hard on Tim just now, believe me, it could have been worse. It could have been so much worse. Now, why am I telling you this? It's cool, fine. Same sword, same thing, same principle, very different styles, right? Very different approaches. This is, of course, true for priorities as well, right? Same basic mechanism, but implementations will use this very, very differently. We're going to start by looking at the browsers. We're going to focus just on the urgency for now. We can see that the browsers kind of agree that HTML is important, highest priority. CSS on the bottom, it's either high or highest, okay. But fonts, Firefox does not care about your marketing department, okay? Custom fonts are low priority, which is the exact opposite of Chrome, which is highest priority, right? Let's make it worse. Let's look at JavaScript. Many different ways of loading JavaScript. Chrome and Firefox first. Chrome and Firefox agree that JavaScript in the head, parser blocking, high priority. After that, Firefox doesn't really care what you do with your JavaScript. It's all medium priority to Firefox. Chrome is a little bit more fine-grained. If it's async or defer, it's going to take that as a clear signal that it's not parser blocking, and it can be a lower priority load there as well, right? Makes some sense. Let's look at Safari. Safari does not care where your JavaScript is in the HTML, okay? And the only exception is async, which it moves to medium. I find this a bit weird. Why is defer not a medium? So the explanation people have given to me is that it's because defer ends up blocking the DOM content loaded event, right? And should be slightly higher priority. My question then would be, well, then shouldn't Chrome also have it at a higher priority than async? You know, maybe, if that was the reason. Let's make it worse. Let's talk about preload. Very specific case. What happens if we preload an async or defer JavaScript file? What do you think will be the priority of the preload request? You might be naive and think, oh, it's going to be the same, right? Because preload does not change priority. It only changes when a request is made, right? Not really. Especially in Chrome, the priority is going to get bumped from low to high. It's actually, it makes a lot of sense, right? Because by the time the browser discovers the preload, it doesn't know this JavaScript is going to be defer or async, right? It hasn't parsed that part yet, and there's no way to indicate on a preload that it will be that in the end. So the browser has too little context to make the full decision. In this case, Chrome and Safari are going to be very conservative. They're like, there is a chance this is going to be parser blocking, so I'm going to put it at high. Firefox does not agree. It says if you want it to be parser blocking, you shouldn't be using preload, okay? It's going to be in the medium column. The thing is that the conservative browsers are not actually very consistent with this. For example, in Safari, if you preload an image, it's actually going to go down in priority. Same in Chrome, if you preload a font, it's going to go from highest to high. Again, for good reasons, but the point is this is very inconsistent, and so potentially confusing to developers. Originally, I was going to make it even worse to talk about images, but I just can't, okay? That's way too much. The main thing I wanted to highlight here is that Chrome has recently added something new, where it assigns the first 5 images in the body a medium priority, which is higher than the default of low. It tries to do this to improve LCP, even if people are not using fetch priority, right? So if you have newer traces, you might see that show up, and then you know where that is actually coming from. So we've talked about urgency. Let's talk about incremental next. The browser needs to decide which resources can be incremental or sequential. The simplest things to do is to just say everything is sequential, which is basically what Firefox is doing, or everything is incremental, which is what Safari is doing. Everything, including JavaScript, CSS, and fonts, which really shouldn't be. You might think, Robin, why this rough thing? Can't we be more fine-grained? Right? Because the priority stuff is being sent on a per request basis, right? So we can change this per request that we make. And of course, that's possible. This is actually what Firefox does for HTTP2. It has a very fine-grained logic there, but they've actually switched to a more coarse-grained logic for HTTP3. which I find endlessly fascinating because Chrome has done the exact opposite. HTTP2 Chrome, everything is sequential. HTTP3, quite recently, Chrome changed to default having everything incremental, except for JavaScript, CSS, and fonts, as it should be. Okay? Now, I personally don't fully agree with this change in Chrome. It means that all images are now being incrementally loaded, so bandwidth sharing. And that's not a problem for most image formats, but it's very unclear what this is doing to AVIF, right? The latest and greatest in the font formats. I've even asked experts about this, and even they can't tell me if AVIF is able to be rendered progressively top-down or not. And I've tested this myself, various AVIF encoders. I have never seen an incremental AVIF load in Chrome today. So this needs a bit more research, fair, but if this is true, if you're using AVIF over HTTP3 right now, you might be actually severely degrading your rendering of images because they all need to wait until they're fully loaded, but they're all stealing bandwidth from each other at the same time, right? So again, needs a bit more work, but I suspect this will need a change in Chrome in the near future. But the worst part about all of this is that I was just talking that browsers are inconsistent when you look at different browsers. That makes some sense. But now I'm telling you that the browsers are inconsistent with themselves. Okay? Depending on the protocol you're using, they have different behavior, which is the opposite of what another browser is doing. It's almost as if these people don't actually know what the best approach is, which is kind of sobering thought. Now, I've been dunking too much in the browsers. Let's talk about the night in the server room. As you may know, a couple of years ago, Andy Davies and Patrick Meenan, they looked at service HTTP2 prioritization, how well they actually listen to the browser signals. They found out that most of them are actively broken, not doing this correctly. I've recently been redoing some of these tests for both H2 and H3 for a lot of the very big deployments, very well-known servers. The results are not positive. Now, I am not going to show you which result is for which backend. My aim is not to blame, right? My aim is to show how widespread this issue is, even in the biggest deployments in the world. Now, the results I'm going to show, for reasons I'll talk about later, are not using web page test. They're using my own tools, which are very similar though. So you have like a waterfall equivalent that you will sometimes see, and then you have what is called the connection view, which is basically the waterfall condensed into a single line, so it's easier to see patterns, right? So the first test, very simple. I have 10 resources, same urgency, not incremental. What I'm trying to tell the server is, I want you to deliver these to me in request order, back to back. So this is a good example, right? This is a server that is listening to the signals that I am sending it. Nice. This one is not, right? This one is basically just ignoring my incremental flag and just sending everything incrementally, doing the exact opposite of what I had asked. Now, interestingly, there are several variations of this going on. This is another one. You can see the screenshot is a bit blurred. This is because this one actually switches resource every single packet. So different color every packet, while the other one switches every 15 packets. So it shows up as a bit larger chunks. Both of them, of course, are not doing what it should be. The opposite use case. So again, 10 resources, all the same urgency, but this time incremental is on. Right? So this is what we now expect to happen. And as we just saw, yes, there are some servers that do this, obviously. There are some that get this mostly right. You know, sometimes they get confused and they do switch back to a sequential bit, but mostly it's okay. And then you have some that don't really seem to get the assignment, you know. I think this is like a cat, you know, do you want to go out? Do you want to stay in? Do you want to do both? I don't know. But you're not doing what I want you to do. The last example is a bit more complex. Again, 10 resources. The first 4 and the last 4 are going to be relatively low priority. so high urgency, right? But the two in the middle, number 5 and 6, the light blue and the scarlet one, those are actually going to be a much higher priority, right? So what I expect to happen is that these two are actually indeed going to be sent first. Even though they're requested later, they should be sent first because they have a higher priority, right? So this is a good server that does this. Of course, you have servers that do this. This is expected by now. Sadly, you also have servers that just do this. That basically ignore the urgency, that only look at the request order. Luckily, they're still doing sequential. That's about all you can say about this, right? Now, I could keep going. I, of course, tested more complex things and more realistic things as well. But I think you can all agree that if they even struggle to get the basics right, how can you expect them to do well on the more complex cases, right? Now, some of you might say, Robin, that's not very fair. This is HTTP 3. We've only had that for 2 years. Okay, might be a fair argument. I don't agree, but might be. So let's look at HTTP 2. It's gotten to be a little bit of a hobby of mine to every time I see a bad HTTP 2 waterfall to take a screenshot or a picture. So just a couple of examples. Clearly multiplexing behavior, which is in Chrome, which it shouldn't be doing. Delaying important JavaScript and especially fonts, right? This one is particularly fun. You actually get an inversion of the order. The last request is sent first, backup. Might not matter too much for images. You can imagine if this happens for JavaScript or CSS, could be a much bigger problem. And my favorite is from the We Love Speed conference earlier this year in Paris, where the speaker was talking about like relatively minor issue with deferred JavaScript. And I was sitting there in the public going like, there is something seriously wrong with this HTTP 2 server. Strangely though, the speaker didn't even mention this at all, right? Even though this was a much bigger problem than the defer stuff that he was actually explaining. I found that very weird. And I think it is because people don't really know what a proper waterfall should look like. Most servers are so broken that I think some of you might think this is actually normal. Might thought before that this is actually normal. That this is just how it's supposed to work because you don't know any better, right? I could keep going. The end result is that only two of these companies do this correctly. The other ones are broken, some of them mildly, some of them completely. Okay. Which is a very bad state for the industry. So yeah, I think by now you're starting to see why I have this opinion, right? But some of you might still be skeptical. You might think, Robin, I think you're lying, right? Because if what you're telling us is true, that would be terrible for the web, right? Nothing would actually load, right? That would be very, very slow, and that's obviously not the case, right? And you have a good point there. But there are a few things, a few shielding factors in play that actually hide us from the worst of these issues. Some of them intentionally, some of them not. I'm going to talk about 3 of them right now. So the first thing is that network performance oftentimes actually isn't the most important thing, right? If you have a very optimized site and you're using a CDN, your network is probably going to be fast enough to compensate for most of these issues. On the other end, if you have a 5 megabyte JavaScript file, you have worse problems than the network. Okay? Another thing that will help mitigate this, maybe not yet, but definitely in the future, is of course fetch priority, where we can actually indicate for various resources what urgency they should be requested as. You might take from this syntax that you can actually control this directly, right? That you might also set highest or lowest, but that's actually not how it works. This should really be read as higher or lower than the default browser priority, right? So you're not really controlling the urgency, you're kind of bumping it to one of both sides. And even that doesn't always work. Like for example in Chrome, you can bring an image from low to high, But if you add fetch priority low, that's actually not going to do anything. It's going to stay at low. The inverse for fonts. Fonts are already highest. They can't go anymore. But even if you specify low, it's going to go from highest to high, not to low. Sorry. In fact, the only resource type that I know of that allows you to bump in both directions is actually late discovered JavaScript. So JavaScript at the bottom of the page, for example, that will allow you to go from medium to high or medium to low. Right. So important to note. And there's a different caveat here as well. This only allows you to control urgency. Right? So there is currently no way in this API to control incremental. You are stuck with whatever the browser decides is good for you. As I've explained before, that is not necessarily what is actually good for you. Still, I think fetch priority is an excellent thing. think this will help mitigate a lot of the browser inconsistencies that I have talked about before. And this was Chrome only for a very long time. Not really, but very long to me. But I'm very happy to say that this has actually been in a Safari preview since a couple of weeks. I've been playing around with that. It actually works quite well. And Firefox also has a very active implementation effort for this. So very soon you will be able to start using this in production, which is very good. And the last thing, mitigating factor that I want to talk about is something called tight mode, also something called two-phase loading. I think this is the single most important reason why the internet is not on fire today, right? This is the one thing that makes all these priority issues much less visible than they otherwise would be. You might notice, right? Most browsers are going to load resources into big chunks, right? This is not because these resources are discovered late or anything, right? They are all in the HTML. They're all identified by the preload scanner early on, but the browser actively delays requesting them until a later point in time. And it's not just Chrome doing this, it's of course also Safari and Firefox, though they are somewhat less advanced in their logic than Chrome. So as I said, single most important feature to help us with this, which is why I find it so ironic that it is also one of the least documented features in the entire web platform, okay? There is literally like 2 blog posts and 1 Google Doc that has like 3 paragraphs of very high-level explanation, and that's it, okay? So for this talk, I wanted to really know what was going on there. So one of the things I did, I actually interviewed Patrick Meenan. In case you don't know him, he's a speaker here tomorrow as well. He's also the main guy implementing this in Chrome. He wrote the document. And so he explained a lot of this to me, and it was very interesting. But I quickly found out that this is so nuanced and so complex and so many edge cases that it would be completely impossible for me to do this justice during this talk. Okay, so I'm not even going to try. The good news is that you have one of my infamous long-form blog posts to look out for, right? Perf calendar, yay. But for today, I'm just going to give you the very high-level, very unnuanced reasons why this actually matters in practice. So what the browser high-level is doing, it's basically, again, of course, looking at priorities. It's going to gather all the high and highest priority resources, independent of where they are in the document, and then also a couple of less important, just to help them make progress as well. And they're going to start loading those in the first phase. When that phase is done, which is usually when the head is done, when the head is fully processed, then the browser is going to kick off the second phase with most of the other resources in there, right? Now, why does this work? It basically reduces the amount of in-flight requests, right? So even if you have a bad server that doesn't listen to priorities, that sends everything incrementally, it is only stealing bandwidth within, let's say, the first 10 to 15 resources. It's still an issue, but it's much less impactful than if it would be sharing bandwidth between all 100 resources that might be on the page, right? So this, somewhat unintentionally maybe, I don't know, lowers the impact of the prioritization issues considerably. They're definitely still there, they're just much less visible because of this thing that is in play. The thing is, this is so complex, so heuristics driven, and so badly documented that it's also easy to make mistakes that make this thing go wrong. Just one example, this is something that I've seen as like an emerging best practice, right? If you want to make sure your largest contentful paint image is loaded as soon as possible, you should preload it with fetch priority high, right? You've probably heard about this. I would agree if that preload is on the bottom of the head, after the JavaScript and the CSS. Because if it's not, you might get something like this, where the image is actually sent first, delaying your parser blocking JavaScript and CSS. And this is actually expected, right? Because the fetch priority high makes the image high priority. The JavaScript also has high priority. And the preload is the first one to come in. And so the server, even a well-behaving server, will delay your JavaScript in this case, right? Now some of you might be, Robin, well, duh. That's expected, right? We all know the order of things in the HTML matters. Makes sense. I would argue, sure, but this is a very easy foot gun, right? This is very easy to get wrong. And in some cases, you might even have situations where developers can't fully control where these things end up. Right? If you're using certain frameworks or you're using multiple teams, you might not have full control over where this ends up. And it's very easy to get quite a bad impact from this. I could keep going, but you know, the message is clear. Even though there are some mitigating factors, there are some features that shield us from the worst of these things, that does not mean that the problem is gone. It just means that it's not always as visible as it might be. The final part of my talk is going to be about tooling. The idea is here that my sword is a tool, right? Tool to be used. Now sometimes if you look at the medieval manuscripts, you sometimes see people holding swords like that. They put their left hand on the blade, which is very weird because those are sharp blades, right? Now the context here is very important. Because what you need to know is this really only supposed to be used if you are in full armor, right? Because in that case, you can whack at each other as much as you want. Even with sharp swords, that's not going to do much. So what you're going to do here, you're going to grab the sword and basically turn it into kind of a miniature spear. You're basically using the sharp point, you're going to try to stab your opponent where they're least protected. For example, under the chin, or in the elbow, or you could go for the crown jewels, right? Now the point is that the context matters, right? Same tool can be used in very different ways and very different in effectiveness depending on the context. And you could even make the argument that if the context changes enough, you should probably also change your tools. Now, why am I talking about this? It's because I think we actually have very good web performance tooling. I really do. I'm very happy with what we have right now. However, I do think we have some work to do specifically on networking feature support, right? Tools in general are good, but they're not very made. They're not adequately made to do this kind of networking debugging. For example, one of my strong opinions is that one of the main reasons all of this prioritization stuff has gone under the radar for so long is because the Chrome waterfall in the DevTools doesn't actually show the resource chunks when they come in, unlike web page test. Right? I think if Chrome would do that, or had done that for the past few years, it would have been much more obvious that things were going wrong to many more people. Another example was about a year ago. I was talking to some of our engineers and I said, you know, guys, we really need to support HTTP3 prioritization. And they said to me, oh, Robin, that's not urgent, you know, because we looked into it and none of the browsers support it. I was very confused because I had literally just ran tests showing that all of the browsers were using it. So what they said is, we looked at the spec, and the spec says this thing uses an HTTP request header. We looked at the browser DevTools, and we saw no priority headers, so the browsers are not using it, right? That was a very long and very awkward conversation with a very senior engineer who didn't believe that DevTools don't always show you the whole truth. In fact, they are sometimes even actively lying to you. Okay. Another example from last week. So I've been debugging Safari fetch priorities. In the DevTools, if you put fetch priority low, that actually nicely shows up at low, but the high would stay at medium. And like I said, that might be true, right? Safari might not allow us to bump it higher than medium. That might be true. However, if you look at the waterfall, you can see that it did have some effects, right? Because the image is now suddenly moved to the first part of the tight mode, right? It's usually the second phase, and now it's suddenly the first phase. So it had some impact somewhere. So I went to look at what is actually happening on the network level. Turns out Safari is actually requesting the image as medium, default priority, and then immediately after that, increasing the priority to high. And it's just that the DevTools was not reflecting that update in the UI. Interesting to note that Chrome, until very recently, had a similar issue that has been fixed. Chrome should now properly show if priorities have changed during the page load. That's Chrome and Safari. Firefox sits on a throne of lies. Real trace, okay? So, first resource, highest priority. I would expect urgency 0, right? Remember, urgency is the lower number is the more higher priority. They put it at 1. Okay, I can live with that. The next 3 resources are at high, right? High is 1 lower than highest, so I would expect 2. Turns out it's 3, right? A bit weird, but maybe they are intentionally skipping number 2. Who knows? Makes fine. The next 3 are again highest. Excellent. We know what that means. Highest priority is an urgency of 1. Or not. Okay? No worries. Slight bug. But of course, the next 6 are all normal. Okay? Very predictable. They're all going to be the same. And normal, that's basically medium. That's 1 lower than high. So we expect it to be 4, maybe 5, right? Of course, what we get, the first 4 are 2, and then the last 2 are 3 again, even though they're all normal. Now, I'm sure there are perfectly reasonable explanations for this. The point I'm trying to make is that I don't know these explanations. And to me, this seems very, very inconsistent and very difficult. And I might regard this as buggy, unuseful DevTools. The last thing I wanted to show is one of my favorite bugs ever. Okay? I was browsing some Akamai sites, and I saw the top waterfall. Red flags everywhere. We were incrementally sending CSS, should never happen. So I escalate to an engineer and I say, look, this needs to be fixed immediately, right? We need to start sending resources like this, sequentially. That's what the browser is telling us. The engineer immediately told me to calm down. Fair. And he said, well, actually, we are sending sequentially. The code doesn't even allow us to send multiplexed. It has to be sequentially. Your tool must be wrong. I'm like, no way. Web page test is the best thing to happen to web performance since Internet Explorer 6. Okay? There is no way that tool is wrong, right? It's the engineer who is wrong, and I'm going to prove it. And I'm going to use web page test to do it. Because web page test is this cool feature. You can actually capture a network dump of all the packets. This will then show up on the left of the waterfall. We can download the TCP dump file and the TLS keys. You can then put these into another tool, which is called Wireshark. which will show you per packet information on the network. And what Wireshark is showing us is that each resource gets assigned a number. So the two CSS files on top, they get 9 and 11. But then we see that indeed, all the data for number 9 is sent sequentially. Number 9 is fully downloaded before number 11 starts to come in. So Wireshark says the engineer is actually right. Web page test must be wrong. Luckily, no. Turns out both of the tools were actually right. What's happening here actually is that the data is coming in the correct order on the Wireshark side, on the network. It is then passed into Chrome. Now, Chrome is a very complex piece of software. It has many different processes and threads, and somewhere along all of that complexity, something happens that makes the data go multiplexed, becomes interchanged, right? And it turns out what web page test is actually showing is more akin to like one of the final steps in that pipeline, when the data actually becomes ready to use by, let's say, the rendering process there, right? And so, in this case, I wouldn't actually call that a bug in web page test, right? It is showing when the data becomes usable, and that is, in this case, not what you expect. So that's actually good. The problem here was more in the context, right? I am trying to use web page test as a network debugging tool, even though it was not fully made for that, because it's not showing the pure network stuff, it is showing the higher level stuff, right? So it's about context and expectations. And so even if tools get things right, it can still sometimes be very difficult to interpret. And I'm finally ready to wrap up, right? I think it's very clear now why I have this opinion, right? The point I'm trying to make is that if you have a sharp sword, the edges can cut you both ways. So we have all these cool new networking features that can definitely help improve performance, yes, but they can also very easily deteriorate it if used incorrectly. And I've been focusing a lot on these priorities today, right? But it's not just them. All of these features here, I've been debugging the past year, all of them have similar issues, okay? It's actually very systemic. I think the fact that this has remained under the radar for so long is, again, mainly tooling support, right? I think we have focused a lot on optimizing front-end performance, but network has stayed by the roadside. And in many cases, that's probably fine. It doesn't matter all that much, right? I agree with that. However, sometimes it really does, and it can go wrong quite badly. Like, for example, when WordPress decided to lazy load all of their images, even the LCP ones, right? And they didn't do this because the WordPress devs are idiots, right? Obviously, they are not. This probably is because they didn't fully understand what the lazy loading feature was supposed to do, and they didn't have tooling that immediately showed that something was wrong. And this is a very important point for the wider web ecosystem, because we have a very big over-reliance on Chromium Core Web Vitals and the Chrome Crux dataset. This might be okay for desktop, might be, but especially for mobile, of course, you will have a lot of Safari and iOS traffic. Two of the platforms that have the biggest lack of tooling that you can imagine. They also don't support Core Web Vitals. They are not present in the Crux dataset. They are a very big blind spot, right? Now, the RUM archive data I'm using here is a bit biased. It's mostly biased towards rich Western countries. You could make the argument that some regions will be more heavily Android biased. Fine. The main point I'm trying to make is that most of our pages load much slower in Safari and iOS than they potentially could. And that's a problem. So I think it's time for a change. I think we need to First, educate ourselves, learn to recognize these issues. I hope my talk is a good example of that. I then think we should make these companies accountable for their buggy implementations, both the browsers and the servers. I think one of the main ways how to do that is through improved tooling. I think we need to add more network features to existing tools. I think we maybe need to create new tools specifically for network debugging. And I would like to highlight Debug Bear here. They have been adding a ton of network-related features in their tools in the past year. Excellent, excellent work. I think it's a very good beginning, but I think we need a much wider, more concerted, industry-wide effort to improve this over the biggest course. Now, I'm perfectly happy to help lead that charge, right? But I still hope I can have some discussions with you. So if you have any thoughts on this or ideas or feedback, please come find me, after this today or tomorrow, and maybe we can kickstart some of this to help improve this down the line. Now at the end, I would once again like to invite Tim to the stage. I want to teach Tim one final lesson. Tim, I'm going to teach you about something called the Mordslag, literally the killing blow. It's when you take your sword and half sword, and you're going to use the crossguard or the pommel as kind of a war hammer. What this does against an armored opponent, sometimes the crossguard just goes straight through the armor, killing instantly. And even if it does, it will leave a big dent, which is often just as effective. It's such an effective technique, in fact, that this is one of the very few techniques that is banned even from modern sword fighting tournaments. So that's why I'm going to demonstrate it on Tim right now. Let's hope he doesn't have an accident. Now there is one problem. Tim is annoying, yes, but he's not an idiot, okay? The past 30 minutes, Tim has been scrolling on Google, looking up sword fighting techniques. So he actually knows the counter to the Mordslag, right? So Tim is going to go into half sword himself. Yes. And he's going to catch the Mordslag over his head as I'm throwing it, right? So what happens is this. Bam, right? So Tim lives to fight another day. Now Tim is not an idiot, but even he can only do so much in 30 minutes. So Tim doesn't know that there is a counter to the counter. It's actually quite simple. The only thing that I need to do is to pull down my blade, like this, and I can then again use my pommel to make sure that Tim never eats solid food again. So Tim, I hope you've learned your lesson. And I think you will all agree that if you use the Mordslag, even if it gets countered, it's usually lights out, bye-bye, see you later. Kind of like this talk. So thank you all for your attention, and please a warm applause for Tim for being a good sport. Oh.
Terrified coming up on this stage. Absolutely terrified. Robin, thank you so much for a wonderful talk to close the day. Sadly, we're at time, and that's the excuse I'm sticking to rather than I'm too frightened to come and ask questions. Also, you realize we need Tim tomorrow, right? We need him.
He's still alive.
Okay, that's good.
Alive.
We need you tomorrow. Thanks so much, Robin. There were some questions, but we are indeed out of time. But you're around this evening. Come and grab Robin, ask him questions. I can promise you he won't be wielding a sword. You know you can just get a laser pointer to point at the screen, right? You don't have to use that as a flex.
Too basic.
Okay, too basic. Fair enough. But we're very grateful for you for that talk. That's wonderful. Folks, we are at the end of the day. We're at the end of the day. What a lovely day it's been. I've had a fantastic time. A few little odds and ends before we head to the door and head to the drinks. First of all, tomorrow we get to do this all again. The schedule is the same, the structure is the same, but you get a fresh new MC. You're in Sia's hands tomorrow, and we're very excited for that. Yay! Fantastic. Yeah,